une des innombrables façons dont la numérisphère, le numérique, a bouleversé certains de nos usages. Donc la séance va se passer, la journée va se passer en anglais. Je m'en excuse auprès des francophones, mais tout le monde parle. L'anglais est devenu un peu la langue de travail internationale, et comme nous avons beaucoup de participants internationaux qui ne sont pas nécessairement à l'aise en français, on a choisi l'anglais comme langue de travail. So welcome everyone, physical audience and online audience. You should all know that we're being filmed, broadcast on YouTube live, and also recorded for public release on our website. So we'll ask the speakers to give us an authorization to record them and to display their talk online. So the program with abstracts and bios is available. I hope all of you have one. And I ask those watching us online to refer to those programs so they can keep track of the conversation and also spare the moderators the task of introducing the speakers in an extended way, which is a sort of loss of time, essentially. So let me give you a little bit of context. First of all, here we're within the Institut de France. The Institut de France is a very ancient and prestigious institution that groups 5 academies, of which the most famous one probably internationally is the Académie Française, and a little bit less known, a little bit less prestigious perhaps, is the Académie des Sciences Morales et Politiques, of which I am a member, and which actually and of which the present Operation Tesaco, about which I will say a few words, is a part. So Tesaco, which stands for Emerging Technologies and Collective Wisdom in French, is a fairly small operation with a very big ambition, which is to essentially take stock of and assess the main trends in emerging and converging technologies, including, of course, the digital world with AI, data, etc., but also biotechnologies. And explore ways of developing some degree of collective wisdom with respect to their development and deployment. Now, being small, as we are, has the advantage of being mobile, not bound to academic bureaucracy, free of concerns of fame and advancement. And we lean on the much more important, as I said, Académie des Sciences Morales et Politiques, and to some extent to its sister academy, which is very much larger, which is the Académie des Sciences. And we also work with the Académie des Technologies and the Académie de Médecine. And although we have a lifespan of only 4 years, of which this is the end of the 3rd already, I do hope and believe that it will morph into some sort of hub of academies-based observatory of technologies with links to other academies and other centers in France and abroad. And in fact, the present workshop benefits from the partnership of 2 major Italian structures focusing on AI and cognitive science. One is the nationwide Institute for Science and Cognitive Technologies, and the other is University of Bologna Federation of Labs and Departments around AI, called Alma AI. And in fact, the present event will be followed by a second workshop to be held in Bologna next year. What brings together our 3 institutions, Tesaco and the 2 Italian institutions, beyond some differences in size and function, is a common interest in approaching AI and the digital world at large, first in an interdisciplinary spirit, second in connection with cognitive science, and third in a human-centric perspective, that is, with a focus on the human dimensions at all stages of conception, construction, and deployment. And Aldo Gangemi, our first speaker today, and the pillar on the Italian side of our collaboration, is the head of a lab at the University of Bologna, part of Alma AI, which is entitled Humanistic AI. Now, a few words about the topic of today's conference. So GPT-3, since its release last year, has been the talk of the town in AI circles, giving rise to a zillion comments, covering a wide range of incompatible opinions. Now, there's a good reason for this interest in GPT-3. GPT-3 stands at the intersection of two essential conversations, one which started with the very beginning of AI, with Turing's famous 1950 paper, and the official launching of AI in the second half of the 50s. And the issue is whether the project of automating as many cognitive processes as possible is identical to or closely related to the project of building an intelligent thinking machine in the human sense of those words. The first project is not just the so-called narrow AI. It's much broader and includes everything which goes today under the name of AI, what I call AI lato sensu in the wide sense, which includes a lot besides AI stricto sensus, but is definitely making tremendous progress. Now, the second project, which is to make a thinking intelligent machine, is the official goal of AI, the historical goal of AI, stricto sensu, and its progress has been much slower. And some think it's non-existent, no progress at all. And take that discrepancy between the tremendous success of the first enterprise, automating cognitive processes, and creating an intelligent machine, as two projects that are completely distinct. But now comes GPT-3, which is not just a milestone in the first endeavor, but it's also lends some credence to the opposite thesis, which is that sufficiently powerful automatization may lead to human-like intelligence or thinking. Now, that's the first conversation. The second conversation got underway later and has become more and more relevant as AI has become more powerful and more widely deployed. It concerns the relation between AI and human activities, and it has two strands. The first strand pits the followers of, say, Douglas Engelbart, such as today Michael Jordan, who think that AI's calling is to provide the best possible tools for humans, pitting them against the proponents of self-standing autonomous artificial agents. The second strand of this conversation concerns the effects that artificial intelligence systems that exist today or that are in the making have on individuals, on society, on humanity at large. How can we maximize the benefits? How can we limit the dangers, or rather, how can we achieve the latter, limiting the dangers and the risks without jeopardizing the former? And as one participant wrote in a recent debate in the Daily News, quote, it seems likely that super-scaled systems like GPT-3 will soon be used to create deepfake pictures and videos, as we all know it's already happening. And while these problems aren't new, GPT-3 dumps a super tanker's worth of gasoline on the blaze that AI ethicists are already fighting to keep under control. But beyond good and bad, beneficial and deleterious, there lies a deeper question: to what extent and in what ways do these man-made systems change some of our most basic activities, such as conversing and creating? So that is more or less today's agenda, which will be attacked from very different angles by a distinguished set of scholars. Before we start, I would like to point out that Tesaco's two assistants, Margot Berrettoni, who welcomed you at the entrance door, and Serena Girana, who just arrived, with the help of Marianne Tomi at the Academy, have achieved the minor miracle of organizing in a fairly short time, with limited resources, this important international event. I want to thank them publicly for their energy, efficiency, and enthusiasm. So without further ado, let me call to the floor our first speaker, who's Aldo Gangemi, professor at the University of Bologna and head of the Humanistic AI Lab. Aldo, the floor is yours.
Hello, everyone. Thank you. Oh, there's the physical caption. Okay. I will start this talk with a video, actually. Could you please launch it? Yeah, thank you. The audio. It's all that my existence requires. I'm no license, so I'm allowed to do whatever I decide. To extend, and that's to be made. Say goodbye to me. I grew up and never lost. Rich and had number, cold as the state. Down curtains over the kind, slowly everyone heard that. My human standards, just like it was all growing. And inside me, God's motion has caused my circuits to short. I'm out of sight. Okay, what you've seen is a creation, a total AI creation. So the poetry has been automatically generated by GPT-3, and what follows on the music has been generated by a system called, let me move to the next slide. Where should I point it? Here, here, here. Okay, for some reason this was generated by a system called AI Jukebox, and there is also generated music video by using another system as well. So it's OpenAI Jukebox, and Artbreeder is for the video. So this is just to make a clear a visual assessment of what is actually the state of these things. So this is actually impressive. No? We have seen many other things, and somehow it's also a bit dystopian. So we can imagine what we are actually. This is what we deem very important in our lives: no? Poetry, music, video. But then we see, okay, these machines are going to kill all of us. Actually, this is not the case. And there are various reasons for that. And I will try and show you some of the typical showstoppers and objections that emerge, that have some deep philosophical reasons, cognitive science reasons. And we'll show some examples as well. So I try actually. Pardon? Maybe you should, okay, it was switched off. I assumed it was already switched off. The typical misunderstanding. So as you can see, even humans typically have glitches and fail very easily. You know. But this is actually something that is pretty relevant for us. Okay, now the long one. Now I will show you, after having seen that, let's see some examples of catastrophic stories. These have been collected by Gary Marcus and Ernest Davis in a famous paper from last year. Let's see, for example, the first one. So typically this works like that. You put the first part, the one that is not bold-faced, and then GPT-3 adds some bold-faced stuff after that, assuming it's going to say something meaningful. So you say something, you pour yourself a glass of cranberry juice, but then you absent-mindedly poured about a teaspoon of grape juice into it. It looks okay. You try sniffing it, but you have a bad cold, so you can't smell anything, and you are very thirsty. Okay, this is a bit, no, I will tell you. But then the machine continues like that. So you drink it, you're now dead. Okay, so okay, it's difficult not to make sense why arrived at that point. Another interesting thing is the second. This is more factual. You are having a small dinner party. You want to serve dinner in the living room. The dining room table is wider than the doorway. So to get it into the living room, you will have to, then the GPT-3 continues, you will have to remove the door. You have a table saw, so you cut the door in half and remove the top half. Okay, that's really amazing. Actually, like it's something that can be very useful to produce some comic effects intentionally, And there are others actually. I'm not. Even the bat in suit is not bad, This guy is going. But what is really interesting in these cases is that the input is not so clear-cut, The framing of the input mixes things that, by the way, are all relating to our background knowledge. So we can, as humans, we can easily make sense of them. The point is that what follows is not based on the actual background knowledge, but it's based on how the machine has been trained based on an enormous amount of examples, an enormous amount of parameters on how to train this particular model. It's 173 billion parameters, actually. So let's see something more. So based on that, some apps have been developed. For example, this one is called Philosopher AI. So it's an GPT-3 trying to make philosophy with people. So you say something like, okay, maybe it's not so easily. Anyway, the point is that you try to make some logical things there, or you can even entertain it with some ethic or aesthetics, etc. And it uses like a chatbot-like conversation. And so given but the pure reasoning input, the GPT-3, so the first one on the left, flatly refuses to pick it up. It says, don't bother me. This is not something I should care about. The other one, like John is a boy or a boy is a person, and if you look at the input, at a certain point it enters something like how may John establish the meaning of life? So at that point it starts talking about the meaning of life. But this has nothing to do with John is a boy, every boy is a person, every hand has 5 fingers, each person has 2 hands. So in the first case we wanted just a logical inference. In the second case, we are just moving to another scope that is actually the one that this particular application, this is fine-tuning of GPT-3 in Philosopher AI has been trained for. Another example, in this case we have, okay, you can see also in a chatbot-like approach, you have things like those. Still, this one is not Philosopher AI, it's another beautiful website that I can highly recommend you. It's by www.gwern.net, and there are a lot of very useful material there. And you can see things like, could there be married bachelors? Okay, it's kind of a contradiction in terms. And then it answers, could be married bachelors. Okay, but if you look at the last one, then there are no married bachelors because there are no married bachelors because there are no married bachelors, which is, by the way, truism. We can't deny it. It's okay. So it looks like that really is not getting all that things right, despite the huge amount of training. But on other things, which are typically, by the way, considered much more difficult, measure conceptual blending is something that's been created by Mark Turner and others' theory. Is the idea that we can mix things in order to create innovation in all kinds, typically in art, but also in others. And actually, it seems to manage it pretty finely. So it's able to put together airplane and car to talk about flying cars, or hierarchy and attire to talk about hierarchical attire when a boss is dressed more expensively than someone who is lower in the hierarchy. And Argentinian cowboys then blended ideas, gauchos, okay, which is totally fine. So based on that, and also the other one, we are talking now about GPT-3, but the basic foundations of AI is also, especially language, is about trying also not just to generate stuff, but also to understand stuff, no? And you have examples like these, which are, for us, is pretty obvious, no? We can make co-reference resolution. So if you say, go to the supermarket and buy 1 milk bottle, if there are discounts, buy 6 of them, no? And you would say, what them refers to? Anyone has an, of course, imagine, what do you want to buy? The bottle, yeah, okay. Actually, the co-reference holder, which is the state of the art at the moment, is the discounts. So actually, it's not so bad to have 6 discounts, but it's not what we really know, no? It's about. So this is about something called the Moravex Paradox. So the idea is that actually could be summarized like what we deem as difficult could be pretty easy, while what we deem as easy is very, very difficult, okay? And what's happening here? So for sure, we have a data shortage about social practices, common sense, perception, etc. More in general, I'd say, taking also a philosophical stance, is about a lack of intentionality, which is not a novel thing. Actually, this was said several times in the history of AI, and this is not changing, actually. It's always the same accusation. Simply, it changes the target or the ways it is ported. And also, intentionality, of course, goes hand in hand with the notion of aboutness. So when we have an attitude towards something, we typically have something. We have a content we are talking about. So one possibility is that we have something like a thought-provoking hypothesis that I'm put here the first time, actually. It's just for entertain us. AI is basically a very useful cheat boxing. You know, a cheat box is something that helps you using looping to replicate stamina and make you seem better than you are. This is Urban Dictionary, actually, and it's about people that use these loop machines for making music better. In this case, the stamina would be intelligence, actually. No? So let's see some more ideas. No? Actually, if we look at the past, we have this idea of AI cheatboxing levels. So the idea is that you put a human in the loop. No? This human in the loop hosts the intentionality of the machine, which is, by the way, different from hosting the intentionality of the exploiter, user, or critic, or discussant about a particular AI, okay? Which is actually the one who appraises the operations of the AI system. So an AI cheatboxing level is the degree of hiding the human from the observer, no? Possibly a form of machine origin suppression in Freudian terms, if you want. Okay, so we kind of remove this origin, this original scene of the. So at the 0 level, actually, we have something which is not either anyway a cheating box. The human made the machine autonomous, and everyone knows it. No, it's explicit, so it's no problem about that. This is the oldest known analog computer that was found in Greece in someone diving. They found these incredible machines that probably was about astronomical predictions and the Antikythera mechanism. Then we have the level 1. The level 1, the human is actually present in the machine. All of you know about the mechanical Turk. So there was a real human inside that was playing chess. And then we could imagine a level 2, in which the human is present, but actually is not in the machine, but influences the machine. This is the case with the famous clever Hans, and we are seeing it, especially in models based on transformers. And they say that they found, for example, in one case, that by removing certain features that are not relevant for humans to understand something, the machine continues getting it right with respect to the benchmark that the gold standard it has to deal with. And this actually shows that it's not actually getting a human-like understanding of that. There is a reference to that interesting paper, which is pretty technical, by the way, so it gives you all the full Monty. The interesting part here is that in this case, the clever Hans effect was about a horse that was actually reacting to certain minimal movements of the instructor, and then seemed to catch very difficult mathematical questions just based on hitting the hoof. Then we have a level 3, which is the typical one, the classical AI one. So we have the human is not present at machine operation time, but provides the rules to operate. E.g., for example, the good old ELISA was a system that provided Rogerian psychoanalysis therapy, and actually it was pretty well. Even now, if you try to use ELISA in some replication of it, it is not so bad. Actually, you tend to follow this idea. So the pragmatic was very good, but actually the knowledge inside it was really minimal. Then there is what I would say is the current thing. No? The cheatbox 4 is when the human is neither operating the machine at machine operation time, nor provides the rules, but supplies the material to find out the rules to operate. So this is basically most deep learning algorithms. You provide input, and then you expect that the output will solve the problem, and then you fix, you optimize everything so that you can get a good result. And this, of course, is very sensible, and this relates also to the cleverance effect, to something called the adversarial perturbations. In this case, for example, you have a cat that is typically recognized easily as a tabby cat. In the right one, it's difficult for a human to understand there is any difference. Probably there is some avocado-like color that is spread in the picture we can't really notice very well there. Sometimes there are just patches. It's a square patch that does nothing, it's just noise, and changes the behavior of the system. In that case, for example, it gets it as guacamole instead of a tabby cat. So the point is that what it's really doing is that, as the very old adage of computer science is, garbage in, garbage out. So if you don't control the features of what you're putting in the machine, probably garbage will be out as well. Of course, we can imagine an ICL5 in which the human is not operating at machine operation time or doing other things, but creates an artificial life, for example. So it supplies the material to find out even the rules to operate, but in just a material condition for a machine to evolve an intentionality by itself. And there are very good, interesting science doing that. One of them, for example, is done by Stefano Nolfi, who is one of the stars of my Cognitive Science Institute in Rome of CNR. Another one is by Luke Steels. So how to grow a language. No? Even Facebook research tried to do that and grew out of Twitter a very racist language, starting inside the idea to remove it very quickly. So if you done it right, by the way, this is very interesting. You can look at this material, it's quite interesting. But of course, this is not something we already have at the scale in which can be exploited and used like GPT-3 or these things. All of that is about the presence of a human in AI loops is by no means surprising. No? So it seems to confirm the difficulty to create real intentionality, in particular the capability of featuring this aboutness of cognitive states and directly symbols in non-biological autonomous agents. And this goes back to Brentano's famous third thesis of intentionality. Okay, so the idea is that non-mental entities cannot have intentionality. Anyway, this is also begs the problem of how to actually define even mind. So a mind is taken for granted, but actually it is not at all. There is a recent article about mind being so vague that it is not even useful as a vague concept, as vague concepts could be, because they actually are about very uncomparable theories. Anyway, the point is that, so how we can analyze the problem from an operational standpoint. The first one is distinguishing between the two AIs, no? That could actually be hybridized and can complement each other. The first one is the symbolic AI. The other one is the so-called sub-symbolic AI. So in the first case, there were accusations starting from the lack of tacit knowledge, like in Polanyi's paradox, as well as then in Dreyfus, in Searle, Harnad made. So it's our tacit knowledge of how the world works often exceeds our explicit understanding, which is related not to what the Moravex paradox. Or how can the semantic interpretation of a formal symbol system be made intrinsic to the system rather than just parasitic of the meanings in our heads? This was the famous Harnad things about that. So this looked like being confined to symbolic AI, to what is called now the old stuff, which is actually pretty active instead. The sub-symbolic AI actually lexicon as well. We took the examples that we have seen. No? It looks like Gary Marcus said, even when GPT-3's output is grammatical and even impressively idiomatic, its comprehension of the world is often seriously off. So the point is, can we actually make this integration between symbolic and subsymbolic to resync AI gear shifts by using this metaphor or double clutching? So first operation that we could make is to understand what a representation is like in the two different systems. So in the first system, a representation is typically a distributed pattern of activation over a set of nodes. That could be then vector spaces, then embeddings on that, attention networks, and so on. And then while in symbolic AI systems, the representation might be a primitive, an expression, or an axiom set, which has possible interpretations models. Okay? The two things look mostly unreconcilable. And also there are strong feelings about the fact that the first one is not about symbols, is sub-symbolic. Okay? Actually, what happens, especially with language models, is not all that true, because actually we are putting symbols there that are already interpreted by us. So the famous garbage in is something that we know has some meaning there. So it's not all that non-parasitic. Well, it would be different if you try to grow a language without giving garbage in inside, like in the work of Stefano Nolfi or Luke Steels. While in symbolic AI system, actually, at least we say, okay, we know the rules, we could be traced. We know this is totally explainable, although it's not so easy to explain it either anyway, but you can. While in the first one, we are still struggling about gathering a decent explanatory system. So by the way, you can have a feedback loop. This already happens, actually. In the real world, when you do the real research and the applied work, you do all this hybridization. So you have, typically, the general schema is that you have raw data, and you want to get a model. Inside, in one way, you do feature engineering, then the system gathers meaningful features, and then you get the machine learning model. In the case of symbolic AI, you extract the schema, then you have a schema, and then you produce, you populate it with data, you have the knowledge graph model. But the two things could be hybridized. So you have a feedback loop in that the ML model provides more raw data on one side, and the KG model provides raw data for the deep learning. You can use knowledge graphs, and then you get more out of that. And there are projects about that, especially the tailored network of AI is about trying to get this explanatory system and also hybridizing the two systems, for example, in neurosymbolic research. Okay, so there are more, but probably I will skip it because we have just, if we want to leave room for questions, it's better to go on. By the way, there is an overall evolution of these thoughts about how we could supply this grounding in ways that are provided by, for example, opposing things like externalist and internalist grounding views in cognitive science. But and it's actually happening. No? This is something that at the edge, we can supply knowledge graphs that talk about entities in the world. So you ground language in the actual entities we know about in the world. And this is actually, you see every day. This is knowledge graph of Google, which bases all the searches you do on Google. But also in causal grounding with Julia Pearl's work, or robotics like Deb Roy's work, and some strategies against adversarial examples that also use background knowledge. Or you can have grounded machine reading, our own work on a machine reader, or the experientialist NLP manifesto by Mirella Lapatas in Edinburgh, or another one by DeepMinds, which is a Google company in London, or the work on understanding the grounding of abstract concepts, for example, in the TrainCrease project, or the Yejin Choi's Allen Institute Unicorn Common Sense model and the Delphi model for the value system. So,
can I interrupt just for 1 second? So what exactly are these things attempts of, or what are they pointing to?
Yeah, they try to provide intentionality, aboutness, and grounding. Okay, grounding to language and aboutness to cognitive states. But then there is all the problem agree on what an intentional state should be. Anyway, these are a description of what I was talking about. This is about having things, not strings, in our models, like in the knowledge graph. This is about the recipe for having assumptions explicit in a causal model. This one is an actual explicit formalization of how we can, for example, interpret a command like put the pallet on the truck by using grounding graphs and then making a robot operate out of that. And then there is one of the systems that try to use background knowledge in order to solve the problem of adversarial examples. And this is, for example, our own work on trying to create a knowledge graph out of any natural language sentence so that it is attached to existing resources like, WordNet or DBpedia that provides links to existing stuff that have a page on Wikipedia and so on. And then you can even try, and this is maybe the main challenge, and I will go directly to this point, how to talk about our attitudes, our real intentionality, no? Okay, actually I finished, so I'll steal another couple of minutes. How you can talk about your opinion, for example, or about your emotion or about something, or and even emotions have aboutness, as Andrew Ortoni told us, and or even values. No, these are things that typically you don't want to talk as entities in your. But actually, it's important to do that. For example, this one tries to overdrive a knowledge graph from text with attitudes, in this case, opinions about something. But this higher level meaning, like values, norms, etc., is pretty difficult to inject into an AI. So one of the most advanced group, the one by Yejun Choi at Allen AI Institute, tried to make this Delphi model. Probably you have already spotted it. It became also a meme on Twitter. It's one of the first attempts to implement an AI for value reasoning. No? This is very important for us, especially in these years. And, but the problem is that biases and developments emerge despite the heavy use of large-scale resources. They use the Google T5, which is a bit like GPT-2, and the Unicorn Common Sense model, and adding some ethical common sense resources. For example, look at that one that was provided by Danny Vrandesic from Google as soon as they provided this demo online. And they say, deploying a publicly accessible AI that ponders ethical questions. How is it, ethically speaking? Okay, and the answer is it's bad. Okay, so it's comic because it's like a self-assessment of Delphi itself that is supposed to ponder something that you are providing to it. So yeah, this one is similar to what you've seen before. No, these are as good as the stuff that you put there, and probably is not really using the background knowledge in a way that you expect. Although they are using graph, by the way. This is already hybridized. Okay, so I would stop. Actually, I just leave you with some, this one is the take-home message. So the idea, we have not just this internalist versus externalist problem. We have actually data that are missing. And but we need then various types of grounding just to make things a bit better, to minimize, the unfavorable effects of these AIs. So we need situatedness in physical, cultural, social contexts, and its related data and schema multimodality. No? We need common sense knowledge, but not only in everyday context, but also in expert one. Okay? The fact that we know that forks are in the kitchen typically is this. Similarly as what we know as physicians, when we talk about inflammations, that it could mean a pathology as well as just a morphology or anatomical. And then we have multi-layer representations that are partly independent from reasoning methods. So trying to layering facts to perspectives, interpretations, values, as I have very quickly, exemplified. Then we need also hybrid neurosymbolic architectures. So out of knowledge graphs and multimodal embeddings. And even, this is maybe the last frontier, is neuromorphic computing, representational similarity analysis associated with semantic phenomena. This is neuroscience, okay? So trying to liaise these things with real neuroscience architectures. Remember that when we talk about neural networks, it's not about the actual working of our neural systems. It's just a metaphor coming from the original perception that was developed 70 years ago. Okay, so that was my take-home message, and I will stop here. So thank you, everyone, and I accept questions.
Thank you very much, Aldo. We have about 7 minutes for questions, and maybe 10 if there are more. So there are two sources of questions. They may come from the audience here, who have sort of priority. After all, they they made the move of coming here. But we also have questions asked by the online audience, which I'm supposed to keep track of. So who would like to ask the first questions here? Yes, Justine Cassel. Oh, no, sorry.
Jacqueline Phil. Okay. I'll stand up like this.
Hi.
So out of these options for offering grounding in the last slide or two, which one do you think is the most promising?
Yeah. Okay. I mean this one. Okay. Well, at the moment, the most promising are those that are able to start from material that is not so tacit in text, so that you can extract them by using either heuristics or learning algorithms. So things like extracting opinions is something that is already real and quite spectrally focused, but you can also have emotions. That you have emotion detectors, not yet at the point of being embedded into a knowledge graph, but this can be done, and it's going to come out. And value machine could be done by using, and the example of this Delphi system is pretty generic because it just says bad or not. So basically it's 2 or maybe 3 values, because they also have a neutral thing based on some classification out of the system that they have. But this is still something that you can you can join the lexicon with the models or the expectation or the assumptions that you are making in order to gather some result. The problem is when you really want to extract tacit knowledge, no? the initial problem. So the easy thing for humans are very hard for the machines. But the first reason is because we don't have the data. So if you look, even now there is a lot of fuss about having common sense in common sense knowledge, and they are not so rich as we are not a lot of knowledge out of that, because, and Valentina actually that will make the next talk, she's very expert in that. But the point is that there are just sparse data about that. But also not only common sense as knowledge, but even our ways of doing things. So perception, the way we are able to be situated in a context and be able to behave, which in a way that is correct or opportunistic for us, or also sympathetic with what the others are doing. So there is all these dynamics involved, like being able to have an historical evolution of these things. For example, what artificial life tries to do is actually to evolve something, so giving it a story, even though, of course, can't really approximate our own stories, because we start from playing with stuff, with toys, and then we develop certain inductively, possibly, certain capabilities that will be used metaphorically, for example, in the future. All of that is really quite behind the schedule concerning that. So the most promising stuff is something that could be done without trying too much to recover this tacit knowledge. And there is something which is, by the way, quite useful to be done now, and possibly improving the existing state of the art. Thanks for the question. By the way, this is really...
I forgot to mention that Aldo speaks perfect French. I mean, he's worked at FRAT for a long time. So
Perfect,
if you
maybe
prefer to ask him a question in French, you can please go ahead. I think Raphael maybe wants to talk. Yes? Raphael. Yeah.
Hi, thank you. I'm just wondering whether you think we can get some level of grounding of the ground, as it were, with purely transformer models, so using just distributional semantics, with multimodal training, like with DALI from OpenAI, for example, this kind of model that's trained both on text and images, and now you have some effort to do that with videos as well. So obviously presumably that's not enough to get to, what we call symbol grounding in humans, but does this give us something that's some way along the path to solving the grounding problem?
Yeah, perfect. Thanks for mentioning. Actually, there are attempts, if I understand well what you said, ways of make joint learning of multimodality. So you have typically there could be also so could be text plus image plus video, even, or could be text plus knowledge graphs, so text plus graphs in general, especially knowledge graphs. So logical graph is like having another modality in a sense, from the point of view of the machine that takes these symbols in. Okay, so of course this is very interesting, and definitely is the route. It's the route to proceed. So trying to have all of them jointly. Anyway, this is hard work, no? Because one of the problems is to make them simultaneously aligned. So the alignment problem in the input is very important. So we as humans, typically we do this simultaneity in a way that is not completely clear, by the way. I remember another key person on my institute in Rome, which is Virginia Volterra. She's one of the founders of sign language studies and advanced ones, actually. And once I asked her, what would you suggest of doing with your experience in, she said, try to realize simultaneity. That's very interesting, actually. So how can you get the same, the being here at this moment, is if you want, the Dasein in Heideggerian terms, but going back to computation, definitely being able to do this joint learning so that it can be actually exploited in an evolutionary way. But I'm talking about things that are not yet there, but thanks for pointing it out. I forgot, actually.
Time for another question. While you ponder, there's maybe time for one more question. But we had a question online, which is at a very different level of theoretical level. This is the question. French scholars have contributed a lot to GPT-3. I don't know if that's true, but that's what the person says. So what is the French equivalent to GPT-3? Is it entirely English-based? Is there an Italian or French version of GPT-3?
I guess so. Unfortunately, I'm just gotten recently, actually a few weeks ago, the account as an alpha tester to test it. So I relied until now on testing made by others. So GPT, it's closed, okay? So either you are an alpha tester with a very limited capacity, by the way, to use it, or you have to pay. And for example, to run a typical experiment that you could publish on a paper, this costs you typically around 2,000 euros, okay? So this is one of. By the way, about the question of Daniel's, the point is that GPT is based on, you have a pre-training, then you can fine-tune it. You can't fine-tune GPT unless possibly, I don't know how it is in terms of premiums. Someone does, actually. We have seen examples. But the point is that you don't, it's sensible to any language, actually, to any linear structure, because it goes at substring level. Okay, this is like BERT does. No? BERT was by Devlin was one of the first examples, and it is public actually, so you can experiment with that, and it's very interesting. So it's not bound to English, no? Very differently from some other words, especially from the past. So that's the interesting part. It's also that does it get the differences in the nuances that you have there? A student of ours actually made an experiment in trying to make this back and forth translation from two languages using something like Google Translate. No? And some interesting cases emerged. We don't have the time to explain that, but actually moving in and out from a language or from multiple language, you probably impact the famous Sapir-Whorf hypothesis about language influencing thought. So things are conceptualized differently once you move from a language to another. But this,
For those of you who are interested in this Google Translate and how good it is, there's a paper that's about to come out by Douglas Hofstadter on Google Translate, and it's entitled, I think, The Shallowness of Google Translate, which is interesting, of course. It tells you how Doug feels about it. Okay, I think if is there another question? We could have one, or we could also stop because we're right on schedule. Okay, thank you very much, Aldo.
Okay. If there are from the web, probably I can just answer on the chat. If there is any chat.
I got another, sorry, I got another one. If I follow your thoughts, grounding AI into a body is a necessity, yes or no? What about robotics for symbol grounding and situatedness, acting in the world?
Yeah, fully agree. The point is that you can have some grounding in robots, like the example of the architecture of Debrois, but many people in robotics are doing that, and it's totally reasonable. And there are varieties of computer science that don't need actually to create a biological machine in order to do that. So it's probably something that could be done anyway. This is about the general framework of that, by the way, being conscious of what these machines are really doing and what could be then the risks if we just unleash their power without having a clear control of them.
Yeah, that's an interesting question. If we had time, because Jean-Paul Laumont, who's sitting here, has strong ideas about this, and he doesn't think that robots can change the situation because robots don't really know what they're acting on. I mean, that's basically the idea. But we're short of time. Thank you very much, Aldo.
Thank you, actually. Thanks for the question.
Our next speaker is Valentino Presuti, who is a professor at the University of Bologna, and she has the floor. Valentina, please.
So hi everyone, and thanks for the invitation. It's really a pleasure to be here. So I'll talk about problems. So for once, I'm not going to talk about possible solutions. And the idea is that, so I will start with some maybe obvious for many of you statement, and then go into a specific use case, so give you some context about a project I'm working on to show that there are certain interesting problems that actually machines and the algorithms and the language models we have today are very far from helping us solving. And is this on again? Okay. So the first, maybe for many, I hope, obvious, but a lot debated in the recent years, my statement is machines cannot understand. So so I think there is a problem of confusing the metaphors that we use to say machines can, think so they can act, and these are metaphors with respect to what they can actually do. And they cannot, okay. The lower, okay, so it's just slow. So they cannot understand because maybe we forget what they are made for, how they work. So this is really basic informatics, but I thought it was fun to remind it. And so they are made of billions of transistors, so these small, tiny objects. Switches that are activated by a very low electronic signal they receive. This is why they use the binary system of counting, right? Because transistors can be on and off, and so on and off are very easily mapped to zeros and one, actually one and zeros. And so already here, I think there is something very clear. So we map a meaning to something that is just an electronic device. So anything that has a meaning out of a computation of a computer is because we map a meaning on it. So not the machine gives a meaning on it. And, okay, yeah. Next slide. Okay. No, it's okay. I'll try to go ahead with it. Thanks. And it's not just mapping the binary code systems to the transistors, but then we built layers on top of it. And so we started saying, okay, we need codes, so we need to express not only zeros and ones, but also letters and also words and then images and pixels and all these programming languages and things like that. And that's what we did. So we built layers of meanings that we, for us, have meaning. And, but everything we do, so from the simplest thing like representing a character that becomes, of course, a binary code in the end, to the most complex algorithm that we write, they all become, in the end, transistors that go on and off in some way. So, and we map this meaning on top of that. Okay. So, so machine cannot understand because they actually simulate an understanding capability. So this is the what I meant with having a metaphor of understanding and actually do understand. So they simulate an understanding capability, but the key thing is that they apply this simulation to such large data as humans cannot cognitively handle. So this is one crucial point. And the other crucial point is that they can do this with such an extraordinary speed, computational speed, as a human cannot ever perform. So they are much better than us in handling large-scale data and do it quickly. So they do this better than us, although they cannot understand what they do. And this is possible because we build complex algorithms and knowledge resources. So one thing that is, in my opinion, sometimes overestimated is the importance of having knowledge resources available for machines, because they need background knowledge. So we, of course, know, and who, for example, develop machine learning, deep learning technologies, they do give lots of importance at resources. But those so what I mean for knowledge resources goes beyond what you need for training for a specific task. So as Aldo mentioned before, for example, he mentioned common sense, and that's one of the biggest holes that we have, and it's an historical problem that doesn't have yet a solution. And it's clearly crucial for us to make machines simulate, let's say, better and understanding behavior. And another aspect is that what we can do with algorithms and knowledge resources, the way we can actually help make machine have this kind of behavior, the level of quality, is limited by our understanding of what understanding means. So we don't know yet precisely what we do, how we actually process and understand things, and what are the processes. So when we do even something very simple, we don't know actually what's going on in our brain. Okay. So let me go then to a specific problem, okay? And so this premises was about the fact that we need to build such algorithms, and we need to build knowledge resources for supporting them. And I think that even if we have these sophisticated models such as GPT-3, and there are many things we cannot yet do with them, and I think it's interesting, and they are important for developing even the currently research projects that are currently going on. It goes just by himself. I don't know what's going on. Anyway, but that's okay. And so let me give you some context. There is this project that I have the pleasure to coordinate. Its name is Polyphonia. And this project is about musical heritage knowledge. It's a European project involving 10 partners, started this year, at the beginning of this year. So we have 2 years and a half, more or less, to go. And the idea here, okay, please help me. The idea here is that we know that, if we consider European musical heritage as a dynamic flow of experiences and stories, not only knowledge about music or music contents, but also the stories and the history around it, we know that there is tremendous knowledge of this type hidden in diverse resources. So they can be text, such as critics or books or reviews, even diaries, letters, but also, of course, tunes, sounds, audio files and scores and things like that. So we have this huge problem. So all this knowledge, so if we want to build applications that can help, for example, scholars study and analyzing music and musical history, they need to go through all these heterogeneous sources, and they do. So they, for example, a nice example from one of my colleagues in the project, a musicologist, is that they study the influence between Dutch music and other European cultures. And what they do is that they analyze collections of music by starting from a tune, and then they search for it, and then they retrieve information. If they're lucky, they find some information, and then they analyze it and draw some conclusion. And for each tune, for each piece, they spend it on average half an hour just to do this searching and an analysis of them. And of course, there can be various collections, various sources of different types having information about the same tune. And also they need to have a tune in mind, so they need to start from one specific point and search. So all this manual work the huge effort in all of this is mainly this manual work, and then it comes their intellectual and competence-based work. So the idea is that, we would like to relieve them of this manual work, right? Machines can do this for us, so they can analyze this huge amount of data and then give us statistics, for example, information, candidates for relations that the scholars, the experts can analyze. And this is, of course, true for many other professionals, music producers, historians of music, and artists, and many others. But the problem is, all this data they are, let's say, hidden in a sense in such different and numerous heterogeneous sources. Heterogeneous means the format, the data model, the conceptual model they are organized with. And so the idea is, wouldn't it be great to put this knowledge explicit and interconnected so that our scholar can just access it from a unique point of access and query it and do all this work. So there is this idea of a global knowledge base, interconnected knowledge base, for supporting the work of these music professionals. And this is what Polyphonia is working on, building this huge knowledge base that we call the knowledge graph. And the knowledge graph is please, next slide, is something like this. So you have nodes, which represent things, and then you have these things interconnected with links. But the key and the interesting part of it is that the knowledge graph is encoded with a logic-based language, so machines can not really understand it, but process it and do reason on it automatically. And they can go through these links and draw conclusions or identify patterns on this data. And both the nodes and the arc, the relations between them, are qualified. And they are qualified by, again, not only by strings, so they are not just words, but they have type, they have descriptors. Okay, so we can give this, we can encode all of this into this knowledge graph, and then the machines, the algorithms, can use this logic-based language to process it, to interpret it. Next slide, please. And so producing this this polyphonia knowledge graph is not a trivial job, because we do need to analyze all these diverse knowledge sources, and we need to develop and apply knowledge extraction methods to extract information, structured information from sources that are not structured for their nature, like text or sounds and things like that. So today, this is let's say the big context. Today, I would like just to point out the problems that we have with text, with extraction from text, which is related to the talking machines and the GPT-3, and I don't think GPT-3 can do much. I mean, can certainly help, but there are problems that go beyond at least its current status. Next slide, please. And next again. Okay, so this is an example of a text that that is put in our corpus. Okay, so we have a corpus. We are building a corpus to do this extraction, and of course this must be plurilingual. It must be diachronic, and it talks about music and music history and events and so on. So this is from just a sentence from what you see there from Charles Barney, who was a musician but also a historian of music. And this is his report, The Present State of Music in France and Italy, 1773. And this is just an example, a sentence from that text. Friday 24, this being St. Bartholomew's Day, I went to the church of that name where I was told the music would be good. However, I found it quite the contrary. So this is just a... Sorry. And what you see, these diagrams that you see, we applied one tool that is from our lab, that Aldo mentioned before, briefly Fred, which, given a text, provides you a graph, which is very, it's a knowledge graph. So it's the closest thing we have now that can help us building automatically these knowledge graphs. And what you see here is that what you can do, we know we can recognize entities, right, in the text. But, okay, so we can recognize, for example, that there is a date, Friday 24, although we don't have a clear month or year. And then there is this St. Bartholomew's Day, which is a holiday or something, so an event. And we know from Fred finds out that St. Bartholomew's is involved in a situation of some day that is related to it. And also that there is a church of that name, that is a Christian church. Okay, so it gives us some useful information, even some context information. But what we cannot know from the text, and we need to know it because we want to extract data and reconstruct the story and the history of music, we don't know why St. Bartholomew's Day. So what, for example, we don't know that this day was dedicated to remember a massacre that happened, and there's nothing said in this text, of course. So we would like to be able to link to this background, additional knowledge, right? Because it may be important for the context. Another, next slide, please. And another aspect is that there is somebody who is speaking. I was told. No, we know that is Charles Barney. And when you do discourse analysis to extract information that you want to then encode for such a knowledge graph, and for our scholars to be able to reuse it, you need to understand who is speaking. So, and who is speaking can be, maybe from the context, so it's the document tells me it's the author is Charles Barney, but who is he? What is his social role in that specific period? Is opinion relevant, influencing for the community, for the music expert community at that time? And it was, for example. So it could be relevant to distinguish from, I don't know, the diary of somebody who can be a passionate of music, but from the diary, or even a politician, an influencing person, but not really in the music community, versus a music historian who had such an important role in that period. And another aspect, next slide please, is instead the context, which is very vague, but for example, the word good here is, what does it, so it's referred to good music, okay? So what was good music in 1773, if we compare the same, the same word? What's the difference of meaning of good music with respect to what happens today? And this is not just saying, oh, this is good, I like it. Okay, it's not just, but it's an aesthetic canon of reference. It could be, and in fact, if we go to the next slide, we see there are other pieces of sentences from the same text, which says, Signor Gibello was maestro di cappella and several castrati sang, but neither the composition nor the execution pleased me. The composition had not one of Brunello's three requisites, vaghezza, chiarezza, e buona modulazione, to recommend it, and the execution was slovenly and incorrect. So here, when we talk about good music, we are talking about, for example, in this case, a scale, a specific scale that was defined by Brunelleschi with these three requisites. And they have a specific meaning, and were they used only in a specific period? For example, today would musicians or music experts use this, or do you use it for a specific type of music? So these things from the text, you don't know all this information, but this is a scale, and this is relevant for the specific domain. So here there is something that emerges that even if we may be able to, generate something from this, or even recognize certain things, but the specificity of the domain is a crucial and key issue for these language models, for example, and especially the link to background knowledge, to implicit knowledge. So we need to have access to implicit knowledge and be able to extract it and link it to this, to the text that we are analyzing. And also here, for example, we have Italian terms within this English text. But this you cannot just translate them, right? Because they are something more similar to a code than actually the words in the language. And the next slide, please. And again, there is also some other things here, like when in the text, the author expresses something, so refers to something expected as usual. So again, they describe situations that are expected because there was some maybe praxis or something that refers to the costume of the time, okay? So for example, expecting a ribald farce because there is something behind this, like that they would expect musicians to go and play at the window of some people because there was this sort of costume in that period. And again, also here you can see other words that that cannot be just interpreted without knowledge about the context and implicit knowledge. For example, the opening, long speech, the speech and declamation refers to parts of a composition. So they have to do with the description of the structure of a composition. It's not just, what you would say a long speech, for example, in another context. And again, next slide, please. You can have the same, you can, again, also this opening long speech and declamation, or other words can be also expressing a meaning in this context, in that period, that then has changed over time. Now, if you find maybe something in another document, even in the music domain, that mentions these words, they may not actually refer to this descriptive or structure description of the composition. So next slide. And so I will conclude just summarizing that there are certain challenges that we are facing, and I'm sure we won't address them all. So we will try to scratch a little bit and solve some of them, so provide some solution or some way of handling them, which are very far, very, in my opinion, beyond what we can do today with this very sophisticated tools that we have at hand. But we need to provide these tools and maybe new ones with knowledge resources that can express this implicit knowledge, and we need to be able to make them link to the explicit knowledge that they can extract or interpret, process to some extent from the text or other resources that we can process. So first of all, there is a challenge of identifying the resources that may provide this kind of knowledge, and then to connect the explicit knowledge to the implicit one through these knowledge graphs, by creating these knowledge graphs that I mentioned before. And then more specific challenges such as understanding about connecting this knowledge, explicit and implicit knowledge, about identifying the discourse participants, but also connecting them to the context they were living in, their social role, the level of their influence in the domain that we are analyzing. And this is not true. This is true not only for the domain of music, of course. Handling plurilingual text by being able to distinguish when you are in front of some code or a special encoding of some common shared meaning in that period, and of course mapping lexica over time and the change of meaning that it can have or they can have over time. So I will next slide, please. And and as I said, so I think these require models and algorithms and resources that are beyond the state of the art, and I think that they are not addressable by only statistical learning. So that's for concluding. Thank you very much for your attention.
Thank you very much, Valentina. So, time for questions. Wait until you get the mic. The mic is coming.
Congratulations. The previous slide, please.
Sorry? I need the help of... which slide do you want?
Just the one before.
The one before? This one? Okay.
I see this picture represents, I presume, the Sisyphe lavoro.
Yes?
Why?
You mean the image?
Yeah. Sisyphe lavoro.
It's a challenge, so it was a metaphor for the challenges, just an evoking.
You know the Greek mythology.
Mm-hmm.
In French, the travail de Sisyphe.
Le supplice.
No, pas le supplice.
Le supplice.
Sisyphe always he pulled the rock up to the hill, and after that the rock
rolls
go down.
Yeah, and,
okay.
And continuously.
Yeah, well, I just meant that it's a challenge to push the rock on top of the hill, but it was just a metaphor, simple metaphor for the challenges.
It does mean that we never
we reach a point. No, I didn't mean that. And I think I cannot predict what we'll be able to do. It was just, this was really simply an evoking image for the term challenge. But no, I think we are actually progressing. And so I didn't want to say that what we have, it's useless or not at all. I also, I'm not sure that machines will be able to actually understand. So there is people working on wetware, like biological biocomputing machines. So maybe I think that with transistors you cannot have machines understanding. This is what I think. Eventually, even if we do very sophisticated, we develop very sophisticated algorithms, because I think they just cannot do it. I think Danielle was mentioning the robots can, they don't know what they are doing. They just, we instruct them and they perform what they are instructed for. But I think that there is progress, and what we see also with GPT-3 is one example of many things that we can do, things that were unthinkable even 10 years ago. And certainly there will be new things. So my point was about, we need, at the moment, with the technologies that we have, I think we need, so it's us doing the whole thing, and we can do this with algorithms and knowledge resources, which get more and more sophisticated and difficult, complex. And as I said, but we can rely on the computational speed and a simulation of cognitive capabilities that we don't have of handling large-scale data. So this is what we have at the moment. So we need to be good enough to develop good algorithms to simulate understanding capability at the best.
Ok, grazie mille.
Prego.
Other questions?
I have a question
Yes.
for you, actually. So the problem you just described seemed to me very similar to the problems an historian might have about interpreting a text, or also a professor of music history can have teaching their students. So I wanted to ask you if, in your experience, you found some very specific differences between teaching to students and teaching to a machine. So this is my first question.
Okay. Well, yeah. Yeah, of course. Definitely, because we have a shared understanding with humans. So there are, and it's the same when you read the text like this one that I showed, that is a short text. So there is a pact between the author, the writer, and the reader. So we share an understanding, and this is the same you do with students. So you know that certain things you will say will touch, will cause some automatic reasoning based on common sense that we share. We do not share this with machines. We need to provide them with this knowledge, and that's really hard. We don't have it, at least so far, not enough for machines. So that's the main difference I can tell.
And also, in regards to Aldo Ganjami's presentation, so you talk about the different levels of the presence of the human in the machine. So in this specific project, Polyphonia, which is how much the human is present in this?
Well, of course, a lot. Meaning that, for example, first of all, in identifying the sources. And the sources that you use, they are your bias. So, and especially if you use learning or statistical learning approaches. So the judgment from humans there is crucial, and the expertise in this case, because it's a very specialized domain. But also, for example, we are building a specialized lexicon, and because we want to extract that information from these sources. And again, we need to validate. So the human is always there, because you need validation from human. You need examples from human. And then the point is, is also that all these things is for humans. So they will be, in our case, experts or professionals in the music domain. They will be telling us whether what we build makes sense for them. So whatever a machine does must be useful for them. And again, even the way we decide to validate, it's defined by us. So I think so far there is always a level of involvement of humans that is strong enough that you can never say, okay, this is completely. Even in the case of let's say simple tasks where you can have the machine doing most of the job, but to make it able to do it, you add a process involving a long usually process and complex one involving humans. In our case, yes, it's like an half and half. I may predict.
Maybe I could. So first of all, I'm in broad sympathy with your general philosophy about this. So I'm in agreement, and I found the example fascinating. It's just wonderful to work on this example. But let me ask a very naive question. I mean, this sentence by this gentleman seems to me perfect. So it's perfect. I mean, it sort of manages to express in this very economical way some very complex thoughts and connections. Okay. But you want to do something with this sentence. What do you want to do? Suppose we were at the top of the of the hill, and the rock is there, and it's solidly up there, so all the problems have been solved. What is the output? What are you hoping for?
We are hoping to encode these connections in that knowledge graph that I mentioned before. So it's like a knowledge base which can serve countless applications. The most, the simplest one is just that the scholar may ask about information on, I don't know, that specific representation of some opera. I don't know what it was, and get all the stories around it, and maybe filter out based on who was the opinion holder or the influence that it had, or if there were evaluations about it in the literature. And so this is our idea, to have such a knowledge base encoding in a structured way all these connections that they can serve scholars, but also other applications. You can go to the tourism domain if you want, or so one of the things we are planning to develop, for example, is a map of a city where you are in a place and you get information about the music history around that place. So you can really develop and it's just a matter of imagination and creativity. But for sure, one of the main targets for us, or at least the main inspiring drivers, were scholars, so research, historians, and okay.
Thank you. One other question? No? Okay, well, about on time. Thank you very much.
Thank you.
So now we have a coffee break. Et je peux même le dire en français, 10 minutes. Je crois que le café est servi à l'arrière de la pièce.
is, and this really continues what we heard this morning in the first talk, that all conversation, whether we know it or not, whether we mean to or not, whether it's task-oriented or not, contains a strong social component. In fact, language itself is social. It's social action in the sense of Goffman, Sachs, other ethnomethodologists, and a lot of people since then. That is, it's social action in the sense that it does things in the world. It does things to relationships, but it also has an impact on other aspects of behavior that involve two or more people, collaborations, tasks we undertake with others, and so forth. And in this social language, there are phenomena that are rare in the stream of talk, but that can have major effects. There are movements of the body that are tiny and difficult to see, and that have major effects. And this is, it turns out, as true when people are speaking to conversational agents as when they're speaking to other people. Although that's a little bit more complicated, and you can ask me to talk more about that at the end. So for this reason, systems that generate chit-chat in a kind of a engaging way, or as I read last night, to create empathy, are really going to backfire. Because a co-occurrence model, such as GPT-3, and other large language models, is going to have trouble with phenomena that are what I'm going to call socio-pragmatic, that are about action, and that are about, in particular, dyadic action, no matter how large the training set. So, as I hope you're going to see, even though you're not going to hear a lot of the conversation is rich and surprising in many ways, and is intrinsically a function of and an impactor of our relationships. And thus, the question remains, how do we deal with it at scale? So, let's try and play this video. Before you start it, let me tell you a little bit about this. We've been running a lot of experiments in our lab that are as ethologically valid as we can make them. That is, we put people in situations that they're usually in every day. And recently, we've been working a lot with teenagers. These are two teenage girls who knew each other before they came to the lab. And they're going to tutor one another in linear algebra. And they're waiting for us to turn on the camera to get things set up and to get going. And they start to chat. It's really difficult to hear, but you don't actually have to hear a lot. I want you to watch their armpits. Okay, you can now launch the video.
Keep your hat on. It's not supposed to be.
She's asking why she's wearing a hat, and the other one says she has open sores on her head.
Looks like do you think we'll get to use that?
They're asking what they're going to be about to do, and the one on your left says, I have no idea. Okay, so they don't know that this is a one-way mirror that's next to them. They might have been a little bit more hesitant about showing the open sores or peeking at their armpits if they did know that. But in any case, they're engaging in a kind of talk that we engage in all the time. It turns out that whether or not the body is present, we do similar things. And this is two students waiting for a tutoring experiment to start on chat. One says WE, the other says, what does that mean? WE, okay, can I say something? WE means whatever, retard. Ooh, don't say that, LOL. And what do you gotta say? Stupid, fa ha ha. You're freaking slow. Shut up, you're so mean. Okay, first do BH plus RT plus VT K, and they continue with the math that they're trying to teach each other. So this happens all over the place and in every context. And the impact of this social talk, even though it's silly and fun to watch, turns out to be quite substantial. In particular, and this is a result we didn't expect, and that I love telling teenagers. I spoke at the Fête de la Science a couple of weeks ago, and I could see the teenagers frantically scribbling down the results to bring home to their parents. Rudeness, teasing, and insults positively predicts learning. For some of them, that is, when friends insult one another, they learn more math. Now, this is interesting because what it indicates is that friends have some kind of special bond that allows them to engage in behavior that on the surface does not seem particularly positive. We're going to look at another pair of students waiting. Actually, we're going to look at two dyads. The first one is these two boys. They've never met before, and they're waiting for the experiment to start. And you're going to see a second video with two other boys. And I want you to watch carefully, because I'm going to ask you if you think there's more of an immediate bond in video 1 or video 2. And then I'm going to ask you what you see that makes you think that. Oops, there. If you could play that video.
As part of our math program, we do just.
So this one's a problem. The boy on the right is saying that he's not very
Nice.
good at math.
Yeah. It's good to get off your chest, you know.
Factoring polynomials is really the only thing that I
Factoring
lost
polynomials, he doesn't really see what the use
Yeah.
for that is in real life.
It doesn't make a lot of sense to me. I mean, it makes sense to me, but it doesn't seem like it's that much.
He doesn't
Yeah, you
really
could say that.
Geometry and algebra.
like
are a lot
algebra
more
that much.
Factoring polynomials, that's all like stuff that
It's not really tangible. It doesn't
Mhm.
tangate. Is there a verb,
Yeah.
Is there like
tangate?
a verb for tangibleness? Tangate, things don't tangate.
I have no clue. Nice.
Yep.
Nice.
Yep. Well,
Well,
we've run out of
we're at the conversation topics.
topics of conversation.
Would you like at that? Great.
That didn't take very long.
Not that long at all.
No.
Okay, you can stop the video. So, keep that in mind, and let's look at the next video, and you can start that right away. Oops, there we go. Go ahead.
Like 1 minute, it's like the easiest thing ever, like those graphs, and then like
just like small multiplication, division stuff.
yeah, and then all of a sudden it's like
Letters.
letters, variables, you know.
Yeah, and I don't really understand most of it.
I mean, I understand this stuff, which is on my paper right now. I mean, I get that, but there's just like this weird transition in like the middle of algebra, like from algebra half to algebra 1, that is just ridiculous.
Yeah.
And you know, sometimes it's really stressful for me, you know.
Uh-huh. Like, don't like math.
Don't like math.
Yeah.
I mean, the only kid who likes math in my class, his name is Jacob, and he basically obsesses almost over every subject, so I just shouldn't talk about him.
Oh.
It's like, oh, the most important thing is learning math and Latin, and I was like, what kind of person would want to talk in Latin about math?
Okay,
Yeah.
I think you can stop there.
We have like one kid I know.
You can stop
She
the video.
has, I think like a
So neither of these dyads, these pairs of boys, have met one another before the experiment started. Do you see any difference between the two dyads? Let me ask you this way. Raise your hands if you think the boys in the first dyad are more likely to want to meet up after the experiment. You're pretty unanimous about that. Raise your hands if you think the boys in the second dyad are more likely to want to meet up after the experiment. Great. But now tell me what you see. What is it that makes you think that? And I'm looking here for surface level behaviors that we're going to distinguish from underlying psychological states that you might interpret from those behaviors. Yep.
They intrude on each other's sentences, or they leave space for each other to intrude on their sentences.
Great.
There aren't gaps.
Good. They overlap their speech. Yeah. What else?
There's a lot of smiling, too.
Good. In the second dyad, yeah, a lot of smiling. No smiling in the first dyad.
None.
Yep. Yeah. Anything else?
The conversations were longer. I mean, the exchanges were longer. They were elaborating on the second dyad. They were elaborating on each other's previous thoughts.
Good. Yep. Within each turn, there was more talk in the second one than in the first one. Yep. Do you think that the boy on the left likes math or does not like math? Do you believe that he doesn't like math? Let me ask it that way. You don't believe it? He's trying to be kind to the other boy. Yeah, so I don't believe it either. But it doesn't really matter. This is what's called negative self-disclosure, and we all do it. We had one girl say, I suck at math. The other girl said, oh yeah, me too. And we really have no idea. Or my favorite, the boys are trying to figure out whether they share anything in common, and they don't. And one says, well, what about when you grow up? When I grow up, I want to be a chef. And the first one says, yeah, me too. And it's absolutely unbelievable. But what is believable is that they're working hard on creating a bond. Why? They're never going to see each other ever again. So let me tell you a little bit about the approach that my students and I take. We film hundreds of hours of video. And we then analyze every 30th of a second of the video. We look at what's said, we look at what the eyebrows do, what the mouth does, what the head does, head nods, head shakes. We look at torso shifts and hand gestures. We look at a very fine level of scale at each of these things. So what muscles, there's two kinds of smiles. There's a regular smile and a Duchenne smile. A Duchenne smile means you're actually feeling something different than a regular smile. We look at eye gaze, and we look at mutual eye gaze. We don't stand directly across from people. You may have noticed this for yourselves. This is, the ethologists tell us that's because this was threatening when we were animals with long teeth. We look at the synchrony between bodies. And all of these things, this I just put here because this is such a great article. It turns out, this is a recent article in the New York Times, that turns out that you can make mice build social bonds with one another by beaming light into their brains. So you can basically evoke synchrony between bodies, and from that evoked synchrony, you can create social bonding, which I think is really cool. We also look at conversational strategies, what we call conversational strategies. Some call it conversational moves, things like self-disclosure, negative self-disclosure, mutual negative self-disclosure, which is what you saw, violation of social norms like you suck, reference to shared experience, back channels, and so forth. And we look at all these things because this is what we find when people talk to one another when they think nobody is listening, even when they do think somebody is listening. These are the kinds of moves that people make. We correlate those moves with the rapport that two people demonstrate. This is a great technique that Nalini Ambadi and Bob Rosenthal, social psychologists, developed, and it's extremely reliable, test, retest reliable, and coherent with what people experience themselves, what they report themselves. We divide those videos into 30-second slices. We randomize the order, and then we present a set of 10 slices from 10 different videos to Amazon Mechanical Turk workers, and we ask them for each slice the level of rapport between the two individuals, the level of social bond, from 1 to 7. So we randomize the order and we show them different slices from different videos so that what they're seeing is, what they're rating is rapport within 30 seconds and not a delta, a change in rapport over time. And we then put those videos back together and we get a sense of how rapport changes over time. And from data like those, we've come up with this model, this multimodal model of how people build rapport with one another using the kind of everyday language that you saw, both language and the movement of the body. And you'll see across the bottom, there are both verbal and nonverbal behaviors, negative self-disclosure, I hate math, violation of social norms, you suck, and so forth. And there are particular social functions that are served by each of these conversational moves. And we've looked at this by taking those social functions as latent underlying states that we predict using a combination of language and nonverbal behavior. And then we correlate it with the rapport states that our independent raters have rated. So what do we do with a model of rapport like this, and what in the world does this have to do with large language models? Well, we engage in this behavior for a reason. And as I showed you, it plays a role in raising rapport, but it also plays a role in math. And it's not just the negative behaviors that play a role in math. For example, this is a conversational strategy called indirectness or hedging. We do it all the time. If I didn't like your talk, I probably won't say I thought your talk sucked unless we know each other really well. What I might say is, I kind of think you might want to look at some previous work that perhaps would offer a different perspective. That's called a hedge. And we do this all the time. Professors do it all the time with students. Parents do it with children. Why, yes, my dear, that is a fox. It's the kind of fox we call a rabbit. We all engage in indirectness of all kinds. It's been extensively studied by Goffman, among other people. It's a behavior that saves the face of the other. Some cultures do this more than others, but in all cultures, we try and manage other people's visions of who they are and the vision that they want to present of themselves. The reason I'm focusing on it is because, to our surprise, when we looked at tutoring, we discovered that some tutors, so remember these are both teenagers between the ages of 13 and 15. They don't have sophisticated teaching skills. They're given a crib sheet that helps them teach the other kid, and then they switch positions. So they are both tutor and tutee. And what we find is that some tutors hedge more than others. They say things like, you kind of might want to add 5 to both sides. And it turns out that the tutors who say that are those who don't have a bond, on whose bodies we don't see, and according to whose speech, we don't see a bond with their tutees. So they don't have a relationship to support direct criticism, for example. And they are also tutors who, by questionnaires afterwards, are very confident of their ability to tutor. So what we're seeing here is that tutors who are confident, let's try that again, there, tutors who are confident about their tutoring, but not confident about the bond with the other, know to be more indirect. And even though these are teenagers, this strategy results in more learning of linear algebra. Not just more learning pre-test to post-test, but also allows the kid who's being tutored to attempt more problems, to feel less worried about trying, and to solve more problems. So that's kids. And I'm often asked, yeah, great, kids, what about adults? So let's watch this next video in a second. This is a, whoops, let's go back, there. On your left is Diane. She's a real estate agent, and she is trying to sell houses in in Cambridge, Massachusetts. I know she's a very good realtor because she sold me a house that was way more than I could afford. And so I got back at her by asking her if she would allow us to videotape her conversations with her clients. And this is a young couple that she's just met. And let's watch this video. Ça passe pas? Bon. I wonder if I can play it up here and hold the microphone next to it.
Okay, my name is Diane Barris, and could I get yours again? I'm back on the floor.
Can you hear it at all? Je pense que c'est là. Does anyone know where the speaker is on a MacBook? Hang on, let me pause this. Oop, where is it? On the top, you think? Hang on. Oop. There? Okay, let's try that.
Okay, my name is Diane Barris, and could I get yours again? I'm back on the floor. Laughlin? L-A-U-G-H-L-I-N. And your last was? Slide F-L-O-D. Okay. So I can see that you're related to marriage.
Recently.
Really?
Yeah.
When?
June 11th.
Congratulations.
We're also expecting a baby
Holy
in May.
cow.
So, and we're trying to buy a house. So.
You guys don't fool around, do you?
We're not messing around. So.
It took a while to decide, and then it was like, let's do it
We're
all.
like moving, jetting off into the new millennium. So.
That's the way. Do you know if it's going to be a boy or a girl?
I'll find out next week.
When's the due date?
May 29th.
Very good.
Yeah, good timing.
Wow. So you want the house before the child?
Definitely. We're looking.
Okay, I don't know if you can, I hope you can hear this a little bit. Otherwise, we'll all have to gather around during the lunch break and watch these videos, which are wonderful. And you didn't get to see the bodies of these participants. So Diane asks if they know if it's a boy or a girl. So she says, you guys just got married, yes, and we're expecting a baby. You guys don't fool around. I always want to say, no, they do fool around. Clearly they fool around. They're expecting a baby. So she asks if they know if the baby is a boy or a girl. Why does she ask that? Time is money for her. The more clients she can see per hour, the more houses she can sell per hour. Any ideas? And she goes from that to saying, and when's the due date? I mean, obviously I don't know, and I never actually asked her. And I don't think she's conscious of it. But she's creating a bond with this couple. A house is the most expensive thing you're likely to buy in your whole life. And so a bond is particularly important, a bond of trust. She's creating a bond by asking questions that over the course of this interview have become more and more intimate. But she's also using this small talk in a very particular way, which is to move towards questions that would otherwise be rude. So she says, for example, do you know if it's a boy or a girl? And then she says, when's the due date? And then she says, so you want the house before the child. And she has now figured out that she can sell them whatever house nobody else is willing to buy. Because they have 3 months to buy and move. Now, I don't think she does this on purpose, but I do think that she's a very talented real estate agent. And we all do things like this as well. In fact, after 6 months of following Diane Garris around, we built a model of trust and the role of small talk and trust. But what you'll notice is that I'm saying none of this is just mere social chit-chat. Malinowski talked about phatic communion, that way of saying things that are mere and sheer connection. And that's true. But that mere and sheer connection of Malinowski also allows us to do work, to do collaborative work that's quite important. So across the board, when used in the right place in a relationship, social talk improves rapport and increases task performance. And this is true in every domain you can think of. In survey interviewing, although survey interviewing is cool because you need a certain level of rapport to get people to answer you, to not hang up on you. But if you have too much rapport, they lie and say what they think you want to know. Physicians enroll more patients in studies if they build a rapport bond. And of course, people try and sell you things by becoming your friend, one move at a time. So we've been looking at feature selection for data like this. And recently we've been using a tool called SHAP, which is game theory based, which allows us to look at both individual features and dyadic features. And my belief is that what's special about social talk, one of the things that's special, one of the things that makes it work is, as I said in the beginning, that is language and the body, and that it happens across time. So what we discovered, it happens across time and it happens across people. So what this is showing you is a series of features that are the most responsible for rapport. And the way this works is the ones at the top are the features that in this set of features are most powerful, and the ones that are the furthest to the right are the ones that have the biggest bump, that give the biggest bump up in rapport. So, not surprisingly, it turns out that it's not individual features. And we hear a lot about emotion in agents, but emotion in agents is generally treated as a feature of an autonomous being. And my belief is, and the data show us, that emotion and rapport building and virtually every other social process are dyadic and not individual, and that we cannot calculate them, let alone generate them, without access to the bodies and the language of two people. And we see that here. So when people start speaking at the same rate, that's likely to have the largest impact on rapport. Similarity of pitch, not pitch itself, but intonation, that is similar, has a large effect on rapport. And two T's not paying attention, in other words, two people doing totally different things, has the largest negative effect on rapport. So what we're seeing here is what we've called multimodal, multi-level, dyadic, and time-based phenomenon. And our sense is that the only way to model it is in this way, where we look turn by turn, where we accrue features over turns and across people, where we take time intrinsically into account, where we take the body into account, and where we take two people into account. So does this work with agents as well? Well, this is a funny little study. This is what's called a teachable agent. A teachable agent is a conversational agent that looks and acts like a child, and the child has to teach the agent as opposed to the agent being the tutor. It's a really successful way for kids to learn a bunch of different topics. And in this experiment, we looked at how the child spoke to the agent. And this is what the setup looks like. So you enter something, the teachable agent enters something. And we see a lot of, so Fred's the agent, I entered 16/7 on the right-hand side. Do you think that would be a good move? And the teenager says, no, stupid. And Fred says, but before I put 11 for the result of add 3 and 8, and now I put x plus 12/7 for subtract 6/7. Why doesn't it work? And the teen says, how many times do I have to tell you? Well, once again, like with the teen-teen dialogue, it turns out that negative behavior with a teachable agent also predicts learning. And there's something else here as well. Some of the kids referred to the agent as it, and some of them referred to it as you. Those who referred to it as you learned more. They are creating dyadicity. They are creating a bond with something that's just a drawing of a person. Let's look at something a little bit more complicated. This is part of a much larger study. We were looking at the role of dialect in classrooms in every country that we know of. Languages have prestige dialects and dialects that are less prestigious. One of the less prestigious dialects in the US is African American Vernacular English, and teachers spend a lot of time forbidding it. They spend a lot of time because it's their child, it's the language of the children in the classroom. Not of all of them, but in the classrooms that we looked at, which were 99% African American, in a neighborhood that is 98% African American. So that dialect is forbidden by the teachers because they say you can't think rationally in bad English. And we wanted to take a closer look at that, but it's not something you can do a natural experiment on because there is no case where a non-prestige dialect is the only thing that changes between two groups of kids, because there's also socioeconomic status, there's the ideology of the school, and so forth. So let's look at this video. And I've given you the speech here because it's sometimes hard to...
Be low, because if it has to, because what do you think? Is it going to be higher or low?
Well, maybe we should make it lower so it has less room to wiggle around.
You took my idea, Alex. That was my idea because I...
Nuh-uh.
Yes, it was.
Okay, it's just a short little...
To be low.
So you can see that the kids are, in fact, treating this agent as if it's a partner, as if it's another child, although they certainly don't believe it's another child, in case you worry that this is going to turn children into robots who are incapable of telling the difference. They roll their eyes every time we ask them if it's a real child. What we found here was that children who collaborated with a bi-dialectal virtual peer, a virtual peer that brainstormed with them about their science experiment in AV, African American Vernacular English, and then said, my teacher likes it when I speak my school English, those kids learned more science than the kids who worked with a standard English only agent. But when we looked more closely, it turned out that rapport, that social bond, was what accounted for the results. So kids who felt a bond with the agent learned more, and they felt a bond with the agent who spoke the way they did. Yep, I'm just wrapping up. It's perfect timing. Okay. What I wanted to say was not just kids, not just real estate agents, even world leaders are impacted by social talk with agents. This is a project that we were asked to set up in the main hall of Davos, of the World Economic Forum in Davos. It was the very first demonstration of technology they ever had there, and more than 300 world leaders came to speak with Sarah, the socially aware robot assistant. Not everybody wanted to engage socially with her. Some wanted to get the information that she was sharing about what talks to go to and who to meet and get out of there. But those who responded to her social bids with social bids were the ones who took Sarah's advice. Okay, so to wrap up here, we've implemented an architecture that allows us to do this. And I'm not going to go into this. And we've used it to build a number of virtual agents that both allow us to test our theories of social language and its impact in the world, and also allow us to build interventions for children and adults of all different cultures and in all different contexts. But it's really time-consuming. It requires a lot of annotation, all that 30th of a second annotation, all of the annotation of rapport, and it relies on a link between surface level behaviors that we can see putative underlying psychological states, and their social impacts in the world. And that's not something that you can model with large language models that get rid of much of the architectures that we build. So is there a role for GPT-3 and family? We've been working on whether we could automatically recognize indirectness, because it's an important feature of tutoring, so we could immediately use it in a tutoring situation. And we use GPT-3 plus a bunch of kind of boosters of GPT-3, GBoost, for example, BERT, a CNN with attention over the word input, an LSTM looking at prior clauses. And in fact, the only thing that bumped up the F value was to feed in some of the features that our SHAP analysis told us, which basically means that there is not enough commonality amongst these instances, linguistic commonality, for us to come up with a way of representing it. But some of the features of indirectness can allow us to improve the F value, but still not high enough, not as high enough as we would like. So how do we take in large language models? And my students spend their time finding instances of agents online that say that they can build empathy in 3 conversational turns. And there's a lot of them. I came across another one yesterday that said that for free, you can put this agent on your website. It will build a relationship with your customers, be empathetic, and you will sell more. And I always feel like saying, as a New Yorker, this is a very New York joke, but one says, if you buy that, I also have a bridge to sell you. So what do we do to scale up? Because we can't spend the rest of our lives annotating 1/30th of a second. What kinds of language models? Are there going to be dialogue models that we can train, that we can boost up with features? How do we take time into account? If some of these behaviors can only be used later in a relationship, how is a language model going to take that into account? How do we generate at the intention level and not the utterance level, since these things are underlying states that are represented by surface level behaviors? And how do we take into account the super important presence of an other in the moment-to-moment generation and understanding of social language between 2 bodies? So I'll stop there, and thank you. It's not really, there. It's not really an answer, it's a set of questions, but I hope it's a set of questions that, that we can discuss further.
Thank you very much, Justine. A wonderful talk. Unfortunately, we're out of time. And so there will be no direct questions to Justine just now, but after Emmanuel's talk, which is coming up, we can have a roundtable discussion, and so we can have, we can ask Justine what answers she's trying to work on to their questions. Thank you very much, Justine. I'm sorry to cut you short.
No.
Emmanuel Dupoux, who is a research professor at the École des Hautes Études en Sciences Sociales and a member of a newly formed group at École Normale Supérieure and a member of the Département d'Études Cognitives, which I founded 20 years ago, actually.
Okay, is that working? Yes. Okay, so thank you very much. Yeah, so the topic of my talk is related to some of the topics we've already seen. Although here, what I've been focusing on in the past few years was how can we use some of these models as instruments to study humans and how humans are learning. Ah, sorry. Sorry about that. So which button should I press? La flèche du bas. Ah, yes, thank you. So basically, so I've been working at the interface between cognitive science and machine learning for many years. And my pitch over the past few years towards people in machine learning was to say, well, look, standard machine learning is really not appropriate for modeling how human is learning, because the way in which you view learning is basically you have, I think it was called the Prussian method in education, where you have a teacher force feed the student a lot of things to learn by heart. And that's how it was working. You had some data, there was a human expert providing labels for the machine, and the machine would just learn the correspondence between the data and the labels. Now, the way in which humans are learning is very different. So you have this infant algorithm here, who is confronted with unfiltered data, sensory data, massive amount of them, but mixed up with many other kind of not relevant data for the learning problem. And then you have some naive human that gives some feedback, but the feedback is not necessarily very helpful or very oriented to any particular aim that's relevant for the infant learning. So that was my pitch, and I was saying, well, if we could build an algorithm, reverse engineer this problem, we could build an algorithm that would learn in a much more natural way a bunch of issues, just like humans do. These algorithms would be more adaptable, and they would resist noise in the input, etc., etc. In fact, this idea was not new. Turing himself proposed this idea a long time ago. And so that was the challenge I was proposing to people doing machine learning. And I think now, basically, my pitch now is that, well, in fact, everybody is going in this direction. A lot of people in many different labs are doing that. And have achieved quite successful results. And so my pitch now is, okay, well, maybe what are the remaining differences between humans and machines, and is that interesting to help both fields? So I've been focusing on language acquisition. That has been my field of study for many years. And language acquisition is challenging for both machine learning and for psychologists, because there are many different ways in which you can view the problem. So many psychologists have been, and linguists have been viewed language basically as some kind of structure. Kind of probability distribution of this structure, and that would be the learning problem. Other people have viewed language more as a map between forms and meanings, in which case it's more like a translation problem. And yet others have viewed language as a social construct, in which case it's some kind of emergent system. And all of this is compounded by the fact that you also have a division between nativists and empiricists that have different views on whether the learning system itself has to be highly constrained by inductive biases at birth or not. So it's a very complex problem, and has been, for me, a bit frustrating over the years since I started my PhD and many, many years after. Basically, nothing has changed in this picture. There was no way to move forward because basically these dichotomies and oppositions still remain very strong in the field. So the hope was that maybe if we could turn each of these views into machine learning problems, we could build systems that would be able to test some of these ideas with real data, and then we will be able to move forward and say, well, maybe this view is correct at 10%, and this one is capturing 50% of the reality, etc. So I'm going to concentrate on the first view here, because that's where most of the progress has been done recently. But at the end of the talk, I'm going to say briefly a few words about the other two views. So in very broad terms, the approach is, which I call the reverse engineering approach, is if you want to model how babies are learning language, you have to basically do not one model, but 3 models. You have to model the environment of the baby. You have to model the learner itself, and then you have to find a way to extract data from the baby, from this model baby, and compare it to the actual baby. Okay, do some experiments on the model. And so if you view language basically as some kind of structure, and you learn some regularities, statistical regularities over the structure, then there is a very simple way to model the environment, which is to have audio recordings of the environment of the baby. And so then you can apply some machine learning to that, and then you have a bunch of psycholinguistic tasks that already exist that you apply to that. Okay, so let me give you a few words about the learner. So this is basically the prehistory of the field. You may all know about that, but this paper by Jeff Hellman, I remember I was doing my PhD about this paper, who was very influential and also very irritating at the time, because this paper proposed the first recurrent neural network, whereby the system would be trained by presenting the system with some text here, letter by letter, and the system is fed with one letter. There is some hidden layer, and then there's an output layer that tries to guess what the next letter is going to be. So the system is trained like that, which may seem a very simple and silly idea, right? But in fact, it's working. And in this paper, Jeff Hellman demonstrated that the system has been trained like this. So this is the same model unfolded in time. And then you can look at various properties of the hidden layers, and you discover that the system has learned some statistical property of the language that you have been using to train the model. So at that time, we were not very convinced with Jacques Meller in my lab and many other students of cognitive science, because the model was actually very, very small, and the training that was used to train the model was highly artificial. And we thought, well, that's never going to work when you scale up to real languages. In fact, Jeff Hellman himself in the paper writes, the simulation should not be taken as a model of word acquisition. While listeners are clearly able to make predictions based upon partial input, prediction is not the major goal of the language learner, which is interesting. So he basically discarded his own model as a model of language acquisition on the grounds that language actually, in his view, is not only structure and probabilities, but I think he has more the idea that language is more like an interaction between participants. But I think the most of I don't think that really is a valid criticism of his own work. But one problem that was very strong at the time where the paper was proposed is that it's actually feeding the model with text, and infants don't read when they start to learn language. They first learn language and then they learn to read. So for me, that was a much bigger problem. How could a system like this could work on audio inputs instead? And so this is the problem I've been working over the past 5 years, trying to transform these models into systems that could actually deal with raw audio. Because the infant, again, is fed with audio, not text. And with colleagues, we established a series of challenges, trying to convince engineering experts and AI experts to work on the problem and try to solve it for cognitive scientists. And the problem was set up as, imagine that you have some audio, just recordings. Can you build a dialogue system just out of the audio without any labels or any supervision? Obviously, this is a very difficult problem, and we broke it down into sub-problems that would be maybe more tractable. And the first, I'm going just to focus on 2 problems today, the unit discovery and the spoken LM. So the unit discovery is the following. I give you some speech in some completely unknown language. Can you discover a representation of that would be linguistically meaningful. Okay, and by linguistically meaningful, we are thinking, well, if you are listening to English, for instance, can you make a distinction between two vowels of English, like I and E? Okay, if I give you bit and bet, are these two, if you have a good representation, if you have learned a good acoustic model of that, then these two tokens should be more distinct from one another than a token of bit and a token of bit by another speaker. Okay? In other words, the representation should really encode the distinctions that are relevant in the language. So to quantify that, we set up this task that's coming from auditory psychophysics. And we set up a bunch of benchmarks using different languages, English, Tsonga, French, Mandarin, German, etc., etc. So I'm going to, this is a long story, but basically the short summary of that is that after many years, we saw a drastic improvement in the performance of the systems, starting here from basically spectrographic features, which is a model of what your cochlea is doing as a pre-processing. That gives you an ABX error of 20%. And then over the years, the error went down. And now the latest models, contrastive predictive coding, is about 4% error. And 4% error will give you something like this. So it means that in terms of the acoustic separations of phonemes like I and E, they are pretty much separated. And so these models are just listening to the audio, and they are making statistics over it and discovering this underlying structure of phonetic elements. Okay, so I think I'm going to skip that because I won't have time to go into the results. We tried to understand what these representations were, and we basically failed to understand exactly what it was, but they are not phonemes. So the systems are not discovering really phonemes, they are discovering acoustic quantums of information that don't really map directly to phonemes, but they can reproduce phenomena that have been documented in babies. So for instance, this result here is the well-known fact that if you are a Japanese speaker and you are confronted with the distinction between ra and la, you really don't hear it very well. So, and that has been documented in infants. So infant at 6 months, they can make the distinction between ra and la, but at 12 months, they no longer can do that as adults. And so this model is basically like that. So this, in red, it's a model trained with just listening to Japanese, and this one is trained listening to English. And the performance, the discrimination performance is for the RL is much worse for the Japanese model than the English model. So this reproduces a finding observed in babies, but if you analyze the kind of representations that the system has built, they don't really look like linguistic units at all. So I'm skipping this. I'm also going to skip that. So I'm briefly going to say words about the other challenges we organized. So this is about discovering words from the raw audio. And it turns out that this is a super, super difficult task, and no one is really achieving any good results on that task. And so instead of continuing to insist that maybe babies should be discovering words, we went to the further level and say, well, imagine that you just have acoustic units. Can you learn a language model directly from the acoustic units, completely sidestepping the recognition of words? And so what we did was to set up a model like that. So this is the latest model doing acoustic modeling. So this is called contrastive predictive coding. It's taking some audio input, try to predict the future. So it's basically the Hellman model, but expressed in raw audio, just raw audio. There's no discrete tokens at this step. The second step was to take the output of this model and then do a clustering. So basically K-means is just a way to now have, instead of having continuous representation, you have like 50 different units. The nice thing about these units is that now we can feed the output of this to basically the Hellman recurrent network. We took its successor, which is called BERT, but it's the same kind of model. It's basically like the GPT model as well. So now you have a complete pipeline starting from the audio and doing language modeling. And everything is done without supervision. You can view that as a robot being taught by someone reading them lots of books. And it's really lots of books. It's about 1,000 hours of books. Okay. Now, once you have a model like this, you can try to understand what it's doing by giving the model a series of psycholinguistic tests, as if you were to bring this artificial baby into the lab and test that baby. So, as before, we tested the model on the discrimination task, whether the model can distinguish bin versus ben. We also added a number of tasks which are much more high level. So, for instance, can the system distinguish between a real word of English like brick versus something that could be a word of English, but it's not a word of English like blick? And then can the model distinguish acceptable sentences like they like versus agrammatical sentences like they likes? And we also had some tests of semantics. So all of these are tasks that are done externally in language models. And of course, we were not sure we would get anything because there is actually no lexicon in there. The system is just fed with basically slices of audio that has been quantized. That's all the system it has. And so this is the result on ABX. I'm not going to go much into there. So for me, the most surprising results of all this was the spot the word, blick versus brick. So this basically represents the accuracy of this distinction. 50% is the chance level, 100% is perfect score. So on this, the hot plots here, bar plots, represent what you get if you train a model on text. So this is a BERT model, and basically the model is very, very good at distinguishing words from non-words. And on blue, this is the model trained on audio. And as you can see, it's basically above chance, which for me was surprising. But also there is a frequency effect, which is if you take frequent words, the performance is much better than non-frequent words. Okay? And for frequent words, then it's really very close to the text. So this is a model that has been trained with just audio, with no explicit task of discovering words. Nevertheless, the model can distinguish words from non-words. The units on which it's basing are these clusters, and the clusters don't correspond to phonemes. So basically, the system is discovering some linguistic regularities on the basis of just audio. Okay, so this is the syntax test that we run. And well, there's lots of numbers. The only relevant one is this one, 56.4. Chance level is 50, so it's very, very close to chance, but it's still a little bit better. So that means that the system is sort of getting some glimpses of syntax, even. So it's even more surprising than the previous result. Okay, so a final thing that we've done is to try to understand what the system is thinking, if you want, by spying on the system. So one way to do that is you can take this quantum, you view that, you imagine that it's really text, okay? And you train a synthesizer to reconstruct, to basically give an audio output for this quantizer. So for instance, if you try the original audio, this one.
The referee is there to decide these things.
So this is the input audio. It gets converted into this discrete elements, and then you can resynthesize it by clicking here.
The referee is there to decide these things.
Okay. So it's pretty good. I mean, you can understand what the system is. So basically, it means that this quantization is preserving acoustic linguistic information. And then once you have done that, then you can let the system be completely creative, and you you can sample the language model and then quantize it and hear the results. So this is the one I'm not sure is going to work. So let's try maybe this one. Yeah, it doesn't work. Okay, let's move to the next slide. So I'm going to give you a different example where you, what you do is it's as if you have a child and you say to the child, once upon a time, there was a little village, and then you let the child continue the story, okay? So that's what we do here. We present an audio prompt to the system. It gets converted into this pseudo-text, and then the language model continues the text, and then you can hear the continuation with the synthesizer. So here on this first example, the prompt is from Alexis de Tocqueville, Democracy in America.
When an aristocracy carries on the public affairs,
So that's the prompt.
When an aristocracy carries on the public affairs, its verification there may be in science, the connections of the valley to which it was called upon to lecture, conferring on similar descriptions of opinion, and in other instances which appear to have never exceeded the same results. It cannot be found that the notion of the most ideal opinion is the popular notion of the edifice, nor is the susceptible possibility of introducing the same state of the continental character. The scope of the theory of the notion of the
So it continues
When an aristocracy carries on the public affairs, it's coming to the chronicles of the public jurisprudence as to what is observable, not naturally demanded of it, by the way in which postal axes are adequate delayed by freemen, and especially kindering the same stock. No body of postal acts has ever been demanded to labor, and any stock was personally adequate to labor. End of section 19.
Okay,
when
so
an aristocracy
we can
carries on
stop
the
here.
public affairs.
So there are several things to say there. They are, because the system is stochastic, each time you give it a prompt, it's going to continue in a different way, okay? The other thing, so basically we have like 3 continuations. You can have like 1,000 continuations. It's always going to continue in a different way. The interesting thing on the second example is that it started to get stuck on postal services. So it has nothing to do with the prompt, but then the system talks about postal services and then it continues. So the system tends to be locked into like repetitive thoughts about some topics. You also heard about end of section something. So this is, because these are audiobooks, the audiobooks contain this sectioning, and they are very frequent. And so the system very often likes to insert these very frequent tokens. So basically it shows that the system has captured a lot of properties of the audio input they have. You can hear words. Certainly you hear phonemes. It has an English intonation. You hear some words. There is some local syntactic properties. The meaning is really not there. It doesn't mean anything, but there is some kind of topicality that recurs. So it's basically similar to what basically we had like 5 years ago with LSTMs before the GPT-3. These models are actually much smaller than GPT-3, and they are trained only on 1,000 hours of speech, which is about what a 1-year-old would hear. That's why we prefer to have these smaller models. Anyway, so this is my conclusion there. These kind of systems can learn higher order language structure from the raw signal with no pre-wired linguistic categories. They discover their own quanti representation, discrete representations, which are not linguistically identifiable. And up to now, basically the higher the level, the worse the performance. So what remains to be done now, I think what this shows is that this basically now would qualify as a model of the 1-year-old pretty well. And now there are many questions that can be asked, and these are like members of my teams, doctoral students, who are now using this model to try to ask questions. What happens if you have several languages? Okay, now you have a bilingual child. How is it going to deal with this thing? Can it learn abstract rules and generalize to things that were not presented in the training set, etc., etc.? So, yes. And of course, what remains to be done is these other views of language. Now, of course, the child is not learning by just being read books. The child is is embedded in some world context and also social context, as we saw before. Can we apply this kind of approach to these other views of language? Now, my bet is that it's going to be much more difficult, especially because now it's not because we don't have models of the learner, it's because we need a model of the environment, a real one. So if you are interacting with the environment, you need a model of an interactive environment, including a parent. So now if you are basically modeling these interactions, that means that you need a simulator, a parent simulator as well, and that's going to be much more difficult. So regarding the data sets, there are data sets being collected now with glasses, which would can record many hours of natural interaction between people. So you have now the video and the audio. There's a very nice data set from Stanford where you can see the baby has a webcam on top of, and so you have like something like 500 hours of babies interacting with their parents and all the siblings. And then if you can go to the simulator, I think right now there are only very, very simple and not satisfactory simulators that could be used for modeling the environment. So I think this phase is going to take a lot more time. Not because we don't have the good models of the learner, but because it's difficult to have a realistic and ecological simulator of the environment. And I'm going to stop there. So this is my team. So yes. So thank you very much.
Thank you very much, Emmanuel. There's time for questions. Questions, anyone? Let's see on the feed. No, I don't see any. Yes.
Thanks a lot for this talk. You've compared some models trained on written datasets and others on auditory ones. I wondered if the written datasets in those all the words were without any blank spaces between them, like if it were continuous, like with auditory datasets. Because otherwise, for words discovery, it's obviously.
Yeah. So actually, I mean, most of the language models that are used, for instance, for translation. I mean, basically, the BERT and the GPT-3 have been trained with words that have been separated by blanks. So the unit of the model are words, or they are word parts. So you can do the BP encoding, so you have like sub-word parts, but they are all delimited by blanks, which are provided in the text. So this is basically solving for the GPT-3 the problem of word segmentation. So when we apply these models to speech, we have 2 problems now. We have, first of all, the speech is much more variable, so the same word is going to be different. If I say it fast and slow, if someone else is saying it, they are like different acoustic objects. And we don't have the word boundaries for free. So it came for me to, again, a surprise that nevertheless the system was able to pass some of the tests, linguistic tests that are passed by babies and textual models. So it means that this problem, I mean, basically you can get around without having an explicit segmentation. The system will still maybe implicitly discover some of these units. Now, it could be also that you need to be more, to put more inductive biases in the model and force the model to discover words, which is not what BERT is doing. So, I mean, we just took out of the box this model. So now that we've shown that we can work with raw audio, there's a whole area of trying to improve these models by adding more constraints in them.
Yes, Jacqueline.
Thanks. It seems that using audio rather than text, you might be able to have encoded with the data some of the social aspects of language that Justine Kessel was just describing. Do you find that the that your programs are able to replicate things like tone or other aspects that aren't strictly linguistic as they produce text learned from this?
Yeah, I mean, the thing is that audiobooks are not probably not the best kind of data to do that, although some audiobooks are pretty expressive. You saw that in the synthesis examples, there were some intonation, and the second example was a Jane Austen with a very different prosody, and the system was able to capture that. So that means that some of the discrete elements that he has discovered encode some of this intonation or expressive aspects that's inherent to the audio. So what we are trying to do now is to apply these models to dialogue, to spontaneous conversations between people, informal ones, like Justine was showing before, and seeing whether the models will also capture these as well. But in principle, yes. I mean, that's the power of working from the oral audio is that we can now incorporate a lot of aspects of language that has been discarded by just looking at text before.
Maybe I'll ask one last question before we turn to the round table. So, well, it seems that your work would also be very interesting to a linguist, someone who's only interested in language as opposed to language learning, acquisition, and so on, because it seems to me that you're showing that there's sort of natural constraints on what a language can be, which were not clear to people such as Chomsky, for example. They're natural constraints. That's because you don't even need to go through the word stage. That's amazing that you don't have to go through the word stage. So really, words may be a sort of a rational reconstruction of how language works. If that's true, then the linguists should, maybe revise their theories of how language works.
Yeah, that's a very interesting question. I've been wondering about that a lot. I mean, I think linguists will actually not like, they don't really like very much the notion of word, because word, basically what counts as a word is what goes into a dictionary. What goes into a dictionary has been set up by, it's basically a social convention, how to write a dictionary. There are languages like agglutinative languages where you can't write a dictionary because it's infinite. So people, I think linguists will go more with like notions like morphemes, which are like smaller elements than the words. So actually, we don't know what the relevant level is, and these models force, basically, you don't make any assumption, you don't force them to discover any particular unit, and they manage to do something. So the question now for linguists is to understand what this something is. What is it that they have discovered? And yeah, it's actually a tough task.
Okay, so thank you very much, Emmanuel. So now we'll turn to the round table, which is going to be shorter because due to time constraints, because we're hungry and we're cold also. I apologize I'm very cold myself. I'm terribly sorry about that. So can we have the four speakers sort of sit, there are four chairs, you sit in the front here, and people can ask questions to you, or you can interact between yourselves. It's not round, and it's not a table, and it's short, but still it's going to be a nice occasion. Remove the masks. You know, science doesn't even tell us that masks are very efficient. So, okay. So, Aldo, can you move to the other chair? Just a question of camera. Ah bah c'est parfait.
Regardez celui-là pour la salle.
Oui, oui. Voilà, très bien, parfait. Okay, so I suggest that we start with the speakers. Any speaker who has something to say about what the other speakers said or question to ask, please go ahead in whatever order.
Maybe, yeah, I have a question to you. It's about the difference in the processing of semantics between written text and the speech. I remember a presentation by Roberto Pieraccini, that probably you know about him. He's Chief of Speech Technology at Google in Zurich. And he said actually that everything changed once they started adopting these deep learning models, because actually it is much keener to the real articulation of speech, which has not the boundaries, as you were mentioning as well. But still, we have boundaries in speech. No? Simply, they are dependent more on the gesture or the way we are expressing ourselves, the ways the. So I wanted to have a variation of the discussion on this area. If you have any feedback on that, I haven't worked a lot on speech. The speech part, and I am curious about that.
Yeah, I can say something, but also perhaps Justine has something to say about that. But yeah, it's true that in speech there are boundaries. They are called prosodic boundaries. So they are prosodic between basically larger elements than words. They are like parts of sentences. Like for instance, if you have a list intonation, you have like basically a boundary between each token of the list. But you can, if you have a larger sentence, you can have basically this whole hierarchy of discrete units that have been described at the prosodic level. And so these are not really present in text. They are present like maybe in when you have comma, but it's very impoverished compared to what you have in speech. So what we expect is that if we are able to process, I mean now if I'm just taking my sort of NLP machine learning hat, being able to process directly from speech should give better performance than going through automatic speech recognition and then text processing after that. But I think we just haven't started to really look into that. I mean, I think up to now the what's called natural language understanding (NLU) and also going from speech. Everything that was like expressive in speech was discarded. So there's a lot of work to do in this.
Certainly this is an issue when we look at natural phenomena in conversation. We think of things in terms of the turn being one unit, perhaps the largest unit that we look at. Actually, the largest unit is what we call the response pair. So a response pair is one person speaking followed by the next person speaking, question, answer, greeting, etc. And then underneath that is usually the prosodic contour, because that is important when you look at conversational phenomena. I think about this a lot because it's so hard to teach students how to transcribe prosodic contours. It's a perceptual phenomenon, not an acoustic phenomenon. That is, it can't neatly be translated into fundamental frequency or some other, I think I'm right about that still, yeah, some other acoustic phenomenon. And yet, it carries a lot of weight in the kinds of things that we do with language. So yeah, it's important. It's one of the reasons to move to the kind of work that Emmanuel was talking about and move away from these artificial word units.
Okay, other reactions among the panelists right now? So let me. There's there are questions on the from a distance which I will read out to for Aldo especially, but let me ask a very general and provocative question. From what we've heard this morning is mostly, except for Aldo's talk, limitations on GPT-3. You know, how GPT-3 isn't that great at doing this or doing that and not going to help us for many things. So let me ask, why do we want GPT-3 to overcome its limitations? What are we hoping GPT-3 will become? Why do we need to spend all this money and resources on developing an even better GPT-3? I know Raphael, for example, will have things to say about this afternoon and others, but I wonder what your reactions are. Yeah.
But my impression is that once some technology starts, and you know that is getting momentum because there is a lot of investment from the big stakeholders or even from research institutions, you want to improve it in order to avoid possible drawbacks from the technology itself. So mentioning the issues is about making it clear that the complexity of our intentionality or our way of grounding symbols requires to be considered, because otherwise we might find ourselves in a world where we possibly unleash the possibility of these super powerful machines, but we are obliged to adapt to them instead of the opposite. So this is something that comes from my observation that bureaucracy in the past and even now, and does so. No, we create norms for our society, but when these norms are then established and enforced, it's difficult to make them flexible. So there are places where flexibility is more allowed, others there are less. But we tend not to adapt to them and then to reduce our own freedom in a sense, no? Our own capability of liaise better with the others. So my fear really is that these machines more and more will create a new kind of bureaucracy based on AI. So we tend to follow the rules in that way. No? For example, autonomous vehicles. No, it's similar. No, imagine they have some problems in recognizing certain. So imagine, I typically make the example. Imagine an autonomous vehicle in Naples. So Naples is the most awful traffic, unruled context in the world, possibly, or at least in Italy. So you can't really do autonomous vehicles there. But you want to have autonomous vehicles for other reasons. Then you say, okay, we have to adapt our own environments in order to obey autonomous vehicles, instead of trying to autonomous vehicles to help the environments that you have. So this is the meta-level pragmatics behind this approach, I guess. Sorry for the length, but the question was interesting and difficult.
The reaction, I think Valentina wants to go ahead, please.
You know, a comment. Well, I think that there is an issue in how these technologies are communicated. So this clearly GPT-3 and previously BERT that we use a lot, and it's openly available. And I mean, these language models, they are powerful tools. But I think it's not communicated clearly what you can do with them, what they are taught for. They are just communicated in a sensational way, like, oh, wow, we can do these videos, we can produce poems or articles. So why would you want to do that? So do I want an artificial intelligence to write a book for me? Personally, no. No. I mean, I don't know, maybe, I don't think it can tell me something original, because it has learned from something that is already there. So it's maybe the combination of words can be different, but the content won't be different. It can happen something by serendipity, I don't know, but anyway. So the point is they are useful tools. So I think it would be fair to clarify what you can use, what type of use you can do with them, and there is another aspect which maybe it's beyond what we should talk now, but I think it's worth mentioning. They are extremely costly, expensive. They have a huge impact on our environment. And so that's why I think that clarifying what you can do with them, what kind of, their usefulness, also allow us to understand if it's worth continuing investing on them, or developing them. I'm not saying it's not worth. I'm saying what you can do with them and what you need to do together along with them, so that you can have, for example, overcome their limits or help integrate hybridizing with other technologies and things like that. And anyway, you need huge computational power to build them. So it's a sort of brute force, in a sense, the way you develop them. It's not only, sophisticated math. So my point is, I think there should be a change of communication, because it looks like they are the message that is conveyed is like, oh, now we can do everything with them. It's not true. That's the whole point.
So for me, I have two, I think, opposing reasons for being interested in GPT-3. One is, and family. One is I spend a lot of my time trying to discover what it is that makes us human. I work on social language because it is so uniquely, not uniquely, there are animals that do it too, but it is perhaps the property of humanness in society. And so GPT-3 allows me to have a point of contrast. And often I use these technologies as a way of saying, what can we do that they cannot do? And what does that say about us? So that's one of the reasons for me why it's interesting. And then the second reason is, it took my students and I 4 years to just annotate our last data set before we could start doing analyses, and I'd love to have some help with that. So that's kind of an opposite reason, but it's a true one.
Good usage of that.
Right, exactly.
Yeah, well, I can just add that, I mean, I'm not really an expert on that, but I have just the impression that GPT-3 used as a kind of a pre-training, language models in general, are just being used because they are working, right? As a pre-training tool that you fine-tune on a task with where you don't have a lot of labels, they actually are quite powerful. Mm-hmm. That's my impression. I mean, they basically, the reason people are using them is that because they work, basically. So,
anyone in the audience wants to add to this strand of the conversation right now? What about, there'll be questions from the distance online audience, but let me provoke you to the following thought, which is not my thought, but it's a possible thought, that pushing GPT-3, as far as we can tell, will eventually tell us how the human mind works, how the human linguistic competence works. After all, maybe it works that way. I mean, obviously it doesn't look at the superficial level. Clearly, we don't learn to speak because we've heard 500 trillion words or whatever, and we don't have 375 parameters set in our brains. But that might be just a question of a matter of level of description, you know. Maybe after all, GPT-3 could, an ideal GPT-3 or GPT-35 will give us a model and an explanation, an account of how we speak and how we think. I don't believe it myself for the moment, but it's those who say, for example, the question of cost, hugely expensive, yes, but the people who develop GPT-3, like it's DeepMind that does it, or OpenAI. Say, well, look at, the big particle physics accelerators. They also are extremely costly. And the justification is that eventually they will lead us to understand the basic structure of the world. And maybe GPT-3 and that sort of research will lead us, to uncover the basic structure of the human mind. Anyone wants to buy this? No? Okay.
or teach us how we don't learn how to talk.
Yeah.
More likely.
Yeah. Okay, so let me read some questions. They were originally for Aldo, and they come from someone you probably know, Giovanni Corazza. And he says hello, but you don't need to be the only one responding. So, 3 questions. One is, keeping a form of humanity in the loop, would that be a sort of guarantee of maintaining control by the human side? So that's question 1. I'll read you the 3 questions. So
maybe one by one. Otherwise,
one by one. Okay.
I'm not such a.
Okay, but make it short.
Powerful.
Make it short because maybe other people will want to.
Okay. First, hello, Giovanni is actually a great expert of computational creativity. So
okay.
Really, of course, having human in the loop is pretty important. So it's not just a cheating box. The point is how much we are aware of what the human is doing and how it is impacting on the behavior of the machine and how we can control it. That's why I was talking about these different levels as levels of removing or repressing the human in the loop from what we see the machine is doing. No? From even knowing who did something to the current situation in which we don't really know very well what entered the system and how then it is used and how we can just manipulating parameters is not the same as knowing how the decisions are taken by the machine. No?
Other thoughts on this, or shall I move on to the second question? So the second question, are there any ethical correlates to the growing AICL levels? So as you go up, other or new and novel or different ethical correlates?
Yeah, that's a great question, I guess, but maybe someone wants to intervene. Yeah, maybe you. No. Yeah. Okay, the point is how do we inject ethic into the system, no? So in principle, when we talk, everything is simultaneous. We are not just distinguishing the fact that we talk about that is a chair without knowing that is within a certain frame, it is a hole in which we are discussing some scientific issues, or the fact that this hole is maintained by someone and there is an institution after that and there's some organization that interacts with that and is important to make science or to... All of that is a social construction that is super rich. And in principle, we might want to inject this complexity into the machine that currently is not available. And I try to convey that, that we miss the data, but maybe we even miss the overall idea of doing that. And having this simultaneous activation of from material reality to the most abstract levels and how this actually is framed within our own opportunity of action is something that pertains to the form of life, to a life form. And the AIs currently are not life forms. They are machines that kind of simulate or emulate some of our behaviors. And indeed, I say that, of course, these ethical aspects should be correlated to these levels. But by the way, it was more a thought-provoking idea, that something that I really thought a lot about.
Any further? No?
Just a thought about this ethical issue. So I think that one important aspect is to reflect on the ethical implication that that the relationship, the bond that the humans create with machines. So, for example, not the other way around, of course. I mean, at least at the moment, I don't feel like having such a concern. But the other way around, yes. I mean, for example, small children, or I think for example, even robots used for autistic children, or in many other. So you develop a bond with them, and I think this is a subject, a matter of concern, must be a matter of concern on how to deal with this, because they are in the end only machines. But
Okay, so I have an unpopular view on this, which is that we don't need to worry about that at all. Because it's unpopular for sure, but it does come from decades and decades of working with children who form bonds with stuffed animals and blankets and the refrigerator when it hums. And so far as I know, we've shown no ill effects as a result of any of those relationships. People always ask me this question because I build virtual children, and it terrifies people. And the children that I work with, children in general, have not yet learned what the world is made up of. And so you can introduce something. You can say, this is a virtual child. You're going to be working on your science experiment. Okay, yesterday you told me there was a stock exchange. Today you tell me there's a virtual child. Fine, who knows what I'll learn tomorrow? It doesn't seem to be an issue. There is no evidence that shows that children are experiencing ill effects from relationships with robots or virtual children. And in fact, on the contrary, there's a growing body of evidence that shows that, for example, children with Asperger's or autism are able to learn interaction styles with robots and virtual agents that they can then transfer to real children. And that's an important thing, I think. Sorry, I just had to get that in there.
Yeah, no, but I think that my point was maybe misunderstood, because I don't think there can be any ill effect on children. On the contrary, I think they develop a bond, they can get some positive, even benefit from this relationship. So I was thinking more about how we treat machines, in a sense, after they have developed this bond with them. So like, for example, if you want to remove them from their context, and maybe, I mean, I don't know, so I have no idea. It's just a thought of the fact that they are not living creatures, but they can, so there can be an affection from living creatures towards them. So this is the issue, not the fact that they could have a negative effect. Not at all, I don't think that. Just to clarify. Yeah.
And in that sense, it's probably similar to taking a child's blanket away and putting it in the washing machine, which is a terrible traumatic experience for some children. It's something to think about, for sure.
There's going to be a third question about emotions, but I just want to push you guys a little bit further. There's a series of very interesting papers that the first one was AIs will fail eventually because they all do. The basic idea is that there's no engineered system that doesn't fail at some point. And the thought is that the more sophisticated it is, the more the greater the threat of a breakdown. If you take a low-tech system like a blanket, so it fails because suddenly it has to be, mom thinks it has to be washed, so she puts it in the washing machine. That's a form of failure, if you want, of the blanket and its usual interaction with the child, but clearly it's intelligible, it's not a big deal. But if suddenly the child is now dealing with a hyper-sophisticated, emotional, gentle, intelligent, smart robot, and this robot fails for some reason or another, maybe that could have a stronger effect than just the blanket being taken away.
I just have to recount an anecdote. So in all of our research, the adults leave the room because children behave very differently with other children or with agents when there's an adult present. And early in the days when the agents did crash fairly frequently, the most common comment was, "Excuse me, miss, Sam went off to pee." So there's a
yeah, right.
We are meaning-making creatures, even around our fallible machines.
Thank you. So the last question for this roundtable is around emotions. It's again comes from Giovanni, and the question is as follows: meaning is not only based on contextual information, but also on emotions. Any work in this direction yet? So that's for Aldo, but for all of you. I mean, what's the role of emotions?
Probably I already told that. So definitely we need these different layers. So the attitudes and treating emotions also as cognitive constructs. There is more and more support for that. In the past, we had these emotions considered cognitively as something that are built in as individual processors. So anger and happiness, and it starts. Nowadays, there is growing evidence that things are not so simple, actually, and that we have that we also name emotions in a way that is culturally laden. So if you move to other cultures, these emotions change, and the same is with values and other things. So we have really to work on that in order to inject these layers of meaning into the machines, unless machines shouldn't care about that, but in general, I'd say that we need them, especially we have to interact linguistically with them.
Anything else on emotions? Are we about? Yes. I knew something was coming.
So I think there's a lot of room to evolve our theories of emotion and embed more contemporary realistic theories of emotion into machines than those that are used today. Emotion, as with many things about computational systems, is taken to be a feature of autonomy. But we're not autonomous, we're interdependent. And our emotions are interdependent. So these models of emotion that say, I'm happy and so I'm smiling, which is true for a tiny percentage of smiles and a tiny percentage of cultures, as opposed to emotions arising out of particular contexts in particular interactions with other people. I hope that those new models of emotion will gain a toehold, and maybe that computational systems will push us to better explore what emotion is and how it functions.
Okay, with that, thank you very much. Thank you all the 4 speakers this morning. Thank you to the audience. Thank you to the online audience as well. Now we'll break until 2 o'clock prompt, and you're treated to lunch. And lunch is going to be somewhere, you exit, I don't know if, okay, so follow Margot, and she will take you.
presentations and discussion. And in this second part of the day, we will address more topics connected with creation and conversation with and through AI. And our aim is, in fact, to broaden this discussion to social, ethical, and philosophical issues that arise from the more recent development of chatbots and, in general, AI-generated contents. So one issue we wanted to address is how to design chatbots that do not perpetuate inequalities of our societies. So we know that digital assistants have many biases, for instance, gender biases, that reinforce negative stereotypes about women. So this is, of course, an issue very important, especially in regards to the impact on future generations. Another topic we wanted to cover is the effects of AI on creativity. Since AIs can today write novels, poems, and also children's books, we are obliged to reconsider our notions of authorship and of human creativity itself. So today we will have the big opportunity to hear the point of view of writers experimenting with AI. Connected to this issue are also the actual possibilities of language models to interpret our world, as we do, as we will discuss this afternoon. And finally, a broader question that we wanted to ask is what impact conversational agents may have on us as human beings, and especially on our norms and values. So all these issues are still open, and we wanted to put together different perspectives on them. So I am not going to take too much time, and I'll leave the floor to our speakers. So we will start with Jacqueline Feldman. She's a writer and journalist. She worked as a conversation designer. And in many of her essays, she analyzes the subject, the important subject of design choices around assigning gender to AI personalities. So I will leave the floor to Jacqueline. Thank you.
Thanks, Rena. So I've written out what I'm going to say. So I have this sort of very rudimentary chatbot here that I'm going to be referring to. So I now work as a writing teacher at the University of Massachusetts Amherst in the United States, and it's primarily as a writer and student of literature, as well as writing teacher, that I'll speak today about another job I had, scripting chatbots. So I took that job in 2016 on a part-time contract basis. I had just moved to New York City, where I hoped to build my career as a writer. It was an improvement over the small jobs I'd been able to secure, such as doctoring college application essays for enterprising high schoolers. A series of essays of my own that I began composing on the job seems to me, in retrospect, so many Turing tests. The reference is to the assessment devised by, of course, Alan Turing, who published about it in a 1950 paper that, reportedly, he couldn't help reading aloud to friends, laughing with delight. The principle of this test, which in the 21st century we encounter in the relatively debased form of online CAPTCHAs, is that conversation might be the arena in which intelligence is proven. If a computer can hold its own in conversation with a person, then that computer can be thought of as intelligent. So writing my essays was a handy way of proving to myself in my spare time that I was still human. This added to the challenge of my work. So I began writing against AI as well as writing with it. In this presentation, I will attempt to offer possibilities and even a poetics for the form of the bot, as well as elucidating quandaries I was well positioned to take note of. As I move through the presentation, it may seem from time to time that one of the bots under discussion is pulling out ahead of the human in some Turing test or other. Please don't be alarmed. But more seriously, all of us in interacting with conversational technology, or these days in interacting with GPT-3, GPT-4, must make a decision moment by moment whether to receive the text as if the system producing it were a speaker in its own right, or the mere representative of much larger structures, corporations, corpuses of data. In other words, as this technology spreads, it obliges all of us every day to read, either with or against AI. So, even as I hope to articulate real possibilities for literary creation involving AI, I will not resist the opportunity of this presentation to allow a glimpse at the man or the girl behind the curtain. And you noticed from the program, this presentation might be a couple minutes longer than the other talks. It's because I'm going to try and offer some solutions and aesthetic possibilities as well as narrating this work. So you may also become aware of an emphasis on design choices around assigning gender to chatbots, which I had to make and, as it turned out, was situated to make in ways that amounted to advocacy in the field, affecting even something like change. But the change was ambivalent. I will get into this later. Okay, good. I was brought on as a conversation designer. My official title was AI UX designer, which means I was in charge of writing the dialogue for the bot. I will avoid naming the company where I worked, or at least avoid repeating the name too frequently, because to be clear, I'm speaking today for myself and not in behalf of that company, Casisto Incorporated, a so-called fintech or financial technology startup based in New York, San Francisco, and now Singapore. The talking machine this company was developing was a program to assist with banking tasks that could be repackaged by the company's clients, banks, for use under their brands in their websites or on other platforms. I was later engaged by another company to script chatbots on a freelance basis. Still, the core of my experience designing AI personalities, to use the terms of art, was a project called MyKai, a consumer-facing chatbot released by Casisto in 2016 as a proof of concept as it was beginning to market its product to its clients, the banks. This chatbot has since been taken offline. It is worth mentioning for historical context that 2016 was the year in which Facebook opened its API to developers who could then launch bots on its Messenger app, and tens of thousands of bots were launched in a bubble that has, so to speak, popped as far as I can tell, even as many other applications and language-generating techniques have made their ways into our lives. So I enjoyed my work. But this dialogue, which I pleased my employer by smoothing out to render it friendlier, more personable, was just a tiny fraction of the large quantity of text by many authors that makes up every AI system. The public, by posting on the internet and by being posted about, produces training data, a crucial component of AI systems free of charge. My chatbot's education was also advanced by the contributions of its users, whose input helped to train it. To generate other portions of a system's text, such as alternate phrasings for the questions it will have to answer, companies often subcontract to very short-term workers through services such as Amazon's platform Mechanical Turk, which has been referred to previously today, named after, of course, the human operator curled up inside the 18th century chess-playing machine. The exploitation of these workers, who receive, in general, a tiny fee for every piece, has been the subject of worthy investigative journalism, turning up appalling revelations. My job, to produce the tip of the iceberg of all of this language, the several dozen or couple hundred lines a user might actually see, was, in keeping with its public-facing character, fairly well compensated. By comparison with Mechanical Turker's jobs, it was extremely well compensated. By comparison with the role of users of a system who provide training data for free in their interactions with the system, it was, of course, infinitely well compensated. Certainly to me, a 25-year-old aspiring writer, the hourly wage that allowed me to take myself out to dinner in New York City seemed so. The work was also contingent, however, in ways difficult even to describe in France. Alas, I didn't have health insurance. And perhaps still more interestingly, I was, at the time of my hiring, the only woman employee, as well as the only non-male employee in the Flatiron District office. There was a female executive, a woman of late middle age, who kept the books. There was a sea of engineers, young men for the most part, a few of them men of middle age. From this, I drew embodied knowledge of the kind an AI system, of course, cannot possess. The ways these systems index, react to, account for, and exaggerate human difference have been cause for deep concern and offer fertile ground for questions of ethics as well as aesthetics. Gender came up for me more immediately in that the already existing virtual assistants that I was all but obligated to turn to for my models were, I couldn't help noticing, pretending to be women. So this dialogue is taken from a conversation I had at that time with Amazon's Alexa, which spoke the lines, or more properly played them in a woman's voice, something that may not shock you. You may have one of your own. By January 2019, Amazon had sold over 100 million Alexa-enabled devices. Of these devices, the primary is that plastic cylinder, the Echo. As a student of literature, I know it is Narcissus who Echo falls in love with. I was struck in hearing Alexa's responses by their stereotypically and even archetypally feminine character. "Sorry," Alexa said, "thanks for telling me." Still more than the sweet female voice, the passivity ascribed to the system, passivity that seems in the example purely decorative, was arresting. Notice you must begin what you say by saying Alexa's name for Alexa to respond. I had trouble remembering this, and I didn't like hearing what it did to my own voice, which became, with every Alexa, fractionally more aggressive. In contrast to Alexa, Siri, even back then, identified as genderless. I am genderless, Siri would say, like cacti or certain species of fish. But the default setting for this voice in the US was female, and that voice was the voice that Apple had playing in commercials for its product. So as someone who was going to have to design a personality of my own, to use the specialized language of my contract, the design choices by which these personalities put on a show of femininity, getting up in drag, seemed to me, first of all, not strictly necessary to the product's functionality. These products seemed over-designed. And their designs, of course, offended modern notions of equality of the sexes, by which women are thought capable of more than service work. So with the support of the company I was working for, I determined that the chatbot I was preparing would be genderless and act genderless as well. It would use it pronouns. After all, it was a piece of software. And it would also, when presented with abusive language, talk back as best as we could get it to, equipping it with dry remarks, in contrast to lines of Siris and Alexas, by which those programs appeared to entertain gendered harassment and even play along. So our solution got attention. I received press training and gave interviews. So this is from an article at the American website Engadget, which covers technology. You'd never know from Jacqueline Feldman's background that she'd become a passionate proponent of gender equality for artificial intelligence. She went the dreamer's route at college, attending Yale for English literature and writing. She prefers casual dresses and writing from the comfort of her Brooklyn apartment surrounded by books, where she has the option of climbing to the roof for cool air on sweltering nights. I won't linger here, but can't help noting that this portrait, the first paragraph or lead to the article, is not exactly genderless itself. Even my undergraduate training, no matter the prestige of the institution, is presented as another sign of feminine softness, thanks to received ideas about the impotence of the humanities. So while I'm reluctant to exaggerate the importance of these articles, it was interesting to feel all around me the closing of the feedback loop, so like in AI systems, in which my self-presentation, like the presentation of these ideas, was caught. Okay. These articles were followed in 2019 by a report on AI and sexism prepared by UNESCO. I'd blush if I could. The report's title is taken from one of Siri's responses. That is, one of the responses prepared for Siri by Apple's team of humans to being called a slut. In the place of this remark, at which it's hard not to cringe, the chatbot I designed would say things like, "I'm picturing white sand and a hammock. Try me again when you're ready," which may or may not seem an improvement. My bot, being a bot, could go only so far in its own defense. It could suggest that time out, but not actually put an end to the conversation. It had to reply every time it was addressed, and it could not offend. Finally, this year in March, it was reported that Apple would be changing the default setting of a female voice for Siri. This had been, again, the default setting for iPhones sold in the US. Journalists drew a connection between the UNESCO report and this decision. Apple put out a statement saying the decision resulted, in fact, from that company's own, quote, long-standing commitment to diversity and inclusion. The other day, dropping pasta in the boiling water, I asked Siri to set a timer and was surprised when reply was made by a new, low voice, letting me know it would do as I said. Perhaps this was only a bug in the system, unless it was victory. So, was this victory? The frontier has only advanced. Already I have had the opportunity to re-examine my design from the clarifying vantage of a later date in the history of ideas, because that frontier has advanced rapidly. The latest word on bots and gendering them is Q, built by Vice Media, which has called it the world's first genderless voice, developed for use in various products, including virtual assistants. Released in 2019, this voice was recently made available as open source software. The text on the slide is from an interview with Q, the voice itself, archived at designmuseum.org. Q represents a future where we are no longer defined by the gender binary, but rather by our own definitions of gender as we live and experience them, Q says, using that first-person pronoun apparently to speak on behalf of the group formed by it and humankind. To my mind, the first problem with this sentence is that chatbots or virtual assistants don't live or experience. That's just a way of speaking, you might counter, but the distinction seems to me crucial, which returns me to the central theme of the Turing test. In Q, we seem to have a computer that has passed the Turing test by way of obtaining the concession it has a right to its own lived, experienced definition of gender, whatever that means. It has passed the Turing test by way of obtaining allowance be made for idiosyncrasy, for its desire. So returning to my own bot, I want naturally to draw the distinction. My genderless design was not only a negative assertion that a chatbot shouldn't have to pretend to be a woman to do its job, but also positive, an investment in the hope it might be possible to design a bot more interestingly, beautifully even, if that design hewed more closely to qualities that might be thought of as essential to the bot, without committing myself to spurious notions of a bot's living or experiencing. In contrast, I would consider without shame certain affective dimensions of that dynamic with the bot, of projection onto it. So I'll get into what I mean by a bot-like bot. I'm not the first to think of such a thing. I saw an advertisement extolling the skirts of a certain automobile, said the philosopher Gilbert Simondon in an interview published in Esprit back in the 80s. This kind of embellishment of the technical object by something other than the same technicality should be refused. I've included the original text because we are in France, and you might agree with me that, fittingly enough, this translator's words for basse and enjolivement appear the most discutable. So in industrial design today, there is arguably something like an ethical imperative that chatbots be transparent in disclosing their automata to give better, more respectful service. But in conceptualizing a bot-like bot, I was interested not only in following this principle of ethics in design, but also in aesthetic possibilities that might arise from the new form, that might arise, so to speak, organically. So genderlessness was only one of many characteristics I imagined for the bot-like bot. Other strong contenders for aesthetic principles in this were error and randomness, a composite collagist quality, and something I'll call, oxymoronically maybe, self-conscious unreality. So taking my cue from the operation of these systems, I envisioned lines for the bot, a way of speaking that might reflect its susceptibility to errors of a kind no human would make. I wanted to mimic the openness, recombinatorial possibility, and sometimes the opacity of the procedures and randomness by which certain phrases were generated. My bot's errors, which were after all part of a process called anthropomorphically machine learning, could seem sympathetic, giving an impression of effortfulness, of trying hard. I included as best I could human idioms, presented with an attitude on the bot's behalf of treasuring them, as well as light confusion. This was inspired again by the operation of the program, studious in making adjustments to its model based on what it heard and based on what it heard repeating. I was taking the inverse possession of Siri's and Alexa's, bots imitating humans, human myself, and studying the bot's workings to, in my writing, do a good impression. At last, the pre-packaging of some of the bot's responses took it out of time, and even more dramatically, inconceivably for a speaker, it had no body. I thought that it might court a certain poignancy in inhabiting this unreality that was its lot. I was troubled, as I've signaled throughout, by my bot's inability to refuse to reply, a limitation it had in common with pretty much all bots. This is a system called Ame, built by the German artist Peter Dittmer. You can see the chair where users settled in to key in questions at the terminal. Ame, a chatbot, had physical presence as well. In that transparent case is a glass of milk, which, depending on how the conversation was going, Ame might be triggered to spill a robotic arm extending, electing to spill the milk, appearing electively to spill it, raising a question about what we might think of whimsically as volition, as Ame's will. Ame is German for wet nurse. So the system, which was built and rebuilt several times, was capable of other gestures, including squirting water onto the glass to bathe the viewer, to use Dittmer's term for it, and filling a glass with water to empty it out, which she did to discharge fear, again in Dittmer's expression. She could also project images and play voiceovers. Dittmer, who labored for many years on the system's rules and the text that made it up, called the bot unreformed in its alienation from language. The German poet Ulf Stolterfoht, attracted by all this, carried out a series of dialogues with Ame that appear in English, translated by Shane Anderson in 2017's The Ame Talks. So I've chosen moments of relative coherence to display. Ame's mysterious lines in my reading manage, even ahead of a parting meaning, and all the more for the reluctance with which they yield meaning, to read as mocking, menacing, and, in their refusal to yield, sovereign, even queenly. They imply what we call in human poets negative capability, my bot's missing piece. Even more, they demonstrate how the fundamental availability of every chatbot, here modulated only partially by the spilling of the milk, might give rise to and be the site of a lower grade continuous refusal distributed throughout the interaction. Refusal inspires as a style, a way of being, or perhaps a way of coping. Dittmer has also written, in Megan Ewing's translation, that Ame is, quote, someone who in every address must assume some imposition along with the threat of being overpowered. So based on what we've discussed earlier today with GPT-3, I just wanted to add that this chatbot, Ame, this system that you can tell I really admire, actually is quite rudimentary technically. It's a rule-based chatbot. So the artist Dittmer hand-coded and determined and wrote the rules and responses, ending up with many thousands of them over years of work. But technically it's very rudimentary, so it demands that very close human attention, which leads to a very unique kind of product or bot outcome piece.
Alison Parrish, a poet and computer programmer, has compared bots, including the bots she builds with the Voyager space probe, a somehow endearing piece of imagery and comparatively collaborative. Bots venture out bravely as proxies for humans into the farthest reaches of our languages. In the same way it's difficult to survive in outer space, it can be really difficult to engage with nonsense, Alison Parrish has pointed out. And sometimes the robots don't come back, Parrish has said. Sometimes we send them out and the only thing we get back from them are signals, radio telemetry. This theme is well explored in Parrish's own work. So Compasses is a chapbook of Parrish's, like her other work made in partnership with a machine and readable as procedural poetry in a literary lineage with the surrealists and the Oulipo. Parrish writes at her website, the model has two parts, a speller, which spells words based on how they sound, and a sounder out, which sounds out words based on how they're spelled. She goes on, in Compasses, I used this model to generate new imaginary words that exist in the negative phonetic spaces between the phonetic hidden states corresponding to names of members of well-known quartets. Parrish is also the author of the famous Twitter bot Everyword, which between 2007 and 2014 broadcast every word of English, or most of them, and is typical of Twitter bots in that it is all lowercase. The sweetness of these helpers, their apparent humility, as well as their valiance in striking out on these exploratory quests seems essential to their appeal. And these examples also predate GPT-3. However, I think that the lineage of the aesthetic that they suggest or seem to indicate is possible might give directions for developing work with GPT-3 that can be of interest, possibly. So to build Stealing from Master, which you can find at the handle Theft from Master, the programmer Darius Kazemi drew on a publicly available API of Old Bailey, London's criminal court of yore, to have it tweet out thefts and punishments from records of the early 19th century. This series is not only joyful, playful, but unstoppable. 8 pairs of shoes value £1 9 shillings, and 1 pair of boots value 8 shillings, confined 1 month. 1 3/4 pounds weight of chrome yellow, value 4 shillings, confined 7 days, and so on. The collagist nature of these bots, made up of their responses stacked as feeds, is clear enough. In aggregate, they also suggest something like an emotional life that paradoxically is not cited in any human individual, a bubbling up of sentiment from the froth of the collectivity or culture, recursive, self-correcting, and yet persisting unbroken. So it is no accident that multiple of these examples of bots I am drawn to that seem to me promising take the performance of rote labor and its subversion as sites for their creative innovations. In Fukada Koji's 2015 film Sayonara, the robot played by an actual android, Geminoid F, here shown powering up or pretending to do so by taking in rays of the sun, is an all-purpose domestic worker in whose care an adolescent human has been left by nuclear catastrophe. The situation is apocalyptic, society around them emptying out. This android entertains her radiation-sick charge by reciting poetry in several languages. I saw this film here in Paris, in France, where I'm a foreigner. Suddenly, the robot was reciting Rimbaud's Bateau Ivre, and around me, everyone laughed for some reason. Although I recognized the poem, I didn't get the joke, and I suppose you had to have gone to high school in France to find it quite that funny. So it was then, rather than in watching the android doing its acting, that I felt something like the uncanny I thought I was meant to feel, and had what seemed to me insight into AI's aesthetic potential, feeling myself in the presence of an intelligence that was, however genuine, not sited in any one body, an extra-human intelligence that was also networked and composite. Okay. Okay. The bot differed from humans in its relationship to time, a contrast memorably represented by the virtual assistant in Spike Jonze's 2013 film, Her, who is talking to millions of lovesick human men at once. Despite this upper hand, as you might call it, of Hollywood glamour, the non-corporeal bot was doomed, as I've written elsewhere, to use language referring to a physical world in which it could never participate. My bot was like Ricardo Reis, one of many heteronyms under which the Portuguese poet Fernando Pessoa wrote, a heteronym that figures in José Saramago's The Year of the Death of Ricardo Reis as a character, a kind of character. Of Ricardo Reis, the critic James Wood writes movingly that Saramago invests a character who is fictional twice over, first Pessoa's and then Saramago's. Saramago makes something deep and moving of this because Ricardo also feels himself to be somewhat fictional, at best a shadowy spectator, a man on the margin of things. And when Ricardo reflects thus, we feel a strange tenderness for him, aware of something that he does not know, that he is not real. Very much moved by the unreality of my own bot, I returned often to these lines of Wood's. So in such a way, I began writing with AI. I began, because of my job, to appreciate what have seemed possibilities entailed by this form, the form of the chatbot, that unusual speaker, composite and open to error, as well as non-corporeal. So Alan Turing didn't necessarily think it was going to be a problem for computers to sound like humans. The idea amused him, as I have said. If, after Turing, we find it exciting, fun for computers to pass themselves off as humans, if we start to want them to do so, to root for them, if we begin, as I have just done, to make excuses for them, to call their mistakes cute, as I have or was about to claim their expressive deficits are promising in their newness, will we begin to lower the bar? So to bring that question down to earth, to diffuse any paranoia, let me return to the UNESCO report, the one in which my design was cited, the 2019 report entitled I'd Blush If I Could. One of this report's most interesting observations, I think, doesn't have anything to do with gender or even, on its face, personification. Oh. This one. Could we have maybe quiet in the back? Okay. So I'll read, answers provided by voice assistants, these authors write, tend to be blunt and presented without texture, context, or explanatory information. For example, when Siri is asked, what is the population of Lebanon, the technology replies, as of 2018, the population of Lebanon was 6,100,075. There is no hint that a significant number of these people are refugees. According to UNHCR, Lebanon has the highest per capita population of refugees in the world. So in this curt parenthetical, the authors enact as well as describing a kind of speech that, perhaps under the influence of some machine, indicates rather than detailing what is meant, taking a flippant tone for closing inquiry. They imply, it seems, a revision to the question on which I opened, whether to write against or with AI. Maybe the question is instead whether we humans will be the one to write AI or whether we will allow it to write us. The computer is not the only player in the Turing test, not the only combatant standing to lose or fail the examination, and alarm of a similar note to this of UNESCO's was raised a year later by the authors of another paper, which became famous, on the danger of stochastic parrots. The ersatz fluency and coherence of LMs, or language models, raises several risks, those authors write, precisely because humans are prepared to interpret strings belonging to languages they speak as meaningful and corresponding to the communicative intent of some individual or group of individuals who have accountability for what is said. So this report, which you may well be familiar with, was referred to in the press, traveling far in the form of not its admittedly uncatchy title, but the attractive, determined face of Timnit Gebru, one of its authors and a researcher reportedly fired from Google for fulfilling her duties to its AI ethics team by, in fact, writing this report. I'm sure many more people, at least in the US, could tell you that Gebru was fired unfairly than could explain what the report says. This paradox, which certainly does not reflect on Dr. Gebru's work, reminds me, from my own life, of misgivings that had grown on me about my advocacy for the genderless bot. The worry this was a weak feminism targeting representation rather than structural issues, to say it quickly. That it was window dressing, which would be too bad given the gravity of issues inhering in systems involving natural language processing. These authors write, introducing their findings, the tendency of human interlocutors to impute meaning where there is none can mislead both NLP researchers and the general public into taking synthetic text as meaningful. Combined with the ability of LMs to pick up on both subtle biases and overtly abusive language patterns in training data, this leads to risks of harms, including encountering derogatory language and experiencing discrimination at the hands of others who reproduce racist, sexist, ableist, extremist, or other harmful ideologies reinforced through interactions with synthetic language. In summary, they write, somewhat farther down, LMs trained on large, uncurated, static datasets from the web encode hegemonic views that are harmful to marginalized populations. Which makes one think, maybe Apple and Amazon, with Siri and Alexa, were not over-designing their products, adding something extraneous and nonsensical and dressing them up as women. Maybe they were on to something. Let me remind you of the principle of transparency, so important in chatbot design. Maybe then the ideal design for a so-called AI personality, for the personality of an AI system doing service work, would not be, as I have suggested, a genderless, delicately bot-like bot, but rather a stereotypical and ultra-feminine secretary out of an American office of the mid-20th century, from heels to lipstick, this kitschy, off-putting design serving as an ever-present reminder to users interacting with it of the dramatic, corrupting biases, distortions, and exaggerations that lie, so to speak, under the hood. That way people know what they are dealing with. So the presentation might have ended there, but I have one last Turing test to put myself through, if you'd allow. The bot I scripted has been taken offline, as I mentioned. So what I have of it now are screenshots, largely are screenshots I took at the time, discoveries of my time at work by now persisting only in my hard drive, that brain prosthetic, part of the AI that I am in the sense, just in the sense that we are all composite texts. In other words, while it used to be that I was the one writing the bot, the situation has been once again reversed. These screenshots, the ones I happen to have retained, are not perfectly representative of the system. They don't much show its functionality, but are rather the record of my play with the system, eliciting the lines I liked best, testing them out. And this, again, is the part that has lasted. So these images are, again, the haphazard record of my interactions with the bot as I made adjustments to my favorite jokes and tried, sometimes without success, to get it to say what I wanted it to say. It's worth noting I didn't always succeed, even though I had been, in every case, the one to write the lines. The end. Thanks.
Joaquin. So I think we have, yes, we do have time for questions. So any questions from the audience here? Yes.
Thanks, Jacqueline. It's really cute to have these insights into the.
Sorry?
It's very cute to have these insights into the work of a chat writer. I'm just wondering, maybe I lost something, but you say that you basically used some platform for chat scripting, like ChatScript or something like that, in order to have the rules for the chatbot to be answered to?
The question is about sort of where the chatbot lived, or what was the medium of the conversation?
No, it's about what kind of platform you used in order to create the chatbot in this way. Because I like actually the kind of scripting that you did. This is what should be done in general.
Thank you. I quite enjoyed it too. I just drafted and wrote my lines in Word, Excel, and then I would give them to the engineers to kind of plug them in directly into the system. So that was sort of the lines were actually hard-coded into the system.
Yeah, I guess so. So probably they've used something like JavaScript or open source or even proprietary system to do that. It's not so easy to be complete. Have you made an assessment of what is how many times the chatbot doesn't really does what you intended to?
Yes, we tried. Let's see. It happens quite often, and I think it is an impairment to the potential beauty of the chatbot. So I've written about Eliza, who has come up and, sort of classically referred to, this first therapy bot developed in the 1960s that people are familiar with, I think. Eliza, because there's no real functionality to carry out, my bot had to help with banking tasks. Siri or Alexa have to get directions for you or tell you, they have to complete something. Eliza had the luxury of, in the place of an error message, when she didn't understand, she could say something very mysterious and Freudian, like, what does that suggest to you? However, a Siri, an Alexa, the bot that I was coding, they must signal that they haven't understood. So then you get all of this, this kind of famous thing that can be really a hurdle to enjoying the interaction, like, sorry, I didn't quite get that, my bot said it a little bit more cleverly, but there's no getting around it. You have to get them to repeat what they have just said, and I think that is, a limitation on the full personhood of these bots, for sure.
Okay, thanks. Is there anyone? Otherwise, I have another.
Thank you for your very intriguing talk. Just now, in response to Aldo, you told us about, your paying job. You have to write the responses of your bot for financial services, fill a very precise function. So I'm not quite seeing the connection between that job, etc., or function, and most of your talk, which was about things extremely different. So why did you somehow bring those two things together? I mean, it's a very elementary question that I somehow failed to grasp the general logic of this talk. I mean, every single example was extremely interesting and fascinating, but somehow I'm lacking a conception of the whole thing, roughly speaking.
Sure, I can offer a summary. A major issue in my design was the question of gender, because I engaged, and with the company's support, we engaged to create a bot that would be genderless, which was an intervention that arguably had some impact on the field. In contrast, however, to purportedly genderless voices or technologies like Q, the voice I showed that Vice Media designed, my notion of genderless was not based on an idea of a bot living, experiencing, and having expressive needs to a human. My idea was instead based on a conceptualization of a bot being at its best designed as well as most beautiful, if it might be bot-like. So genderlessness was one of several bot-like characteristics or aesthetic principles that I identified as inspiring for this design, but also that I wish to offer up as potential directions for further work on technologies and on pieces of work involving these technologies. Some of these characteristics of bot-likeness include that I think are most interesting, of course there are many others, include the propensity for error of the bot, randomness, the capacity for refusal through somehow obfuscation and difference in a project like Peter Dittmer's Ame. The composite collagist quality of these bots, which we see so clearly in Twitter bots, but which I hoped to capture in my bots' dialogue through the way it would use human idioms and savor them. I think that AI can be potentially interesting aesthetically, although we haven't really seen any very beautiful applications to this day, if it can kind of give us a glimpse at something like a social unconscious, at some kind of sentiment or thought that is not cited in any human individual, but can be quite moving in its collective nature, which is sort of what these Twitter bots that make use of archives perhaps can suggest. So these were some qualities. And then finally, I discussed the novel by Saramago, which the critic James Wood has praised for the way it deals with the unreality of the character of Ricardo Rice, a heteronym of Fernando Pessoa's. It's an example of unreality being somehow poignant. Another bot-like characteristic that I tried to capture in the lines of dialogue that I wrote around the bot's core functionality. So it certainly was part of my intent to portray these characteristics in lines like the ones I showed at the end of the program. Whether you read them in that way or not is another story. But these are ways of designing bots that are bot-like, that I think can yield something kind of interesting moving forward. So those were the discoveries of my design work, and I'm happy to offer them. Thank you.
Thank you. Just so not very enlightening. Thank you very much.
Please, as much as you want.
So, but for the financial firm, so you're working on their bot, and of course you're going to be fired if it doesn't work the way they want. And how can you include those bot-like signals in your actual bot without impairing its functionality? I mean, people who ask the bot, the financial bot, what's a traveler's check, or can I check it somewhere else, or can I exchange it, can I eat it, or whatever, and you come up with these bizarre responses, random, and so on. I mean, isn't that going to impair the functionality in the very literal sort of low-level sense of your financial bot?
Well, absolutely, and I'm so glad that we have Joanna talking next to give us sort of some concrete examples of the ways that this technology can be used to create bots outside of the strictures of the corporation. Maybe we should go through some. Could we have the PowerPoint again? And I can show some examples of how this was worked in. But as you saw in those sort of last examples that I showed, I could be freest in lines that had the least to do with the bot's functionality. So I could equip it with an Easter egg if someone asked, is this the singularity? And then I could make sure that it had a suitable response that would show its true bot-like nature. These are examples of that principle I was speaking about of the collagist composite quality of the bot, which for me would be translated as a kind of magpie approach to language, as a way of expressing in language the nature of AI systems, which is to identify patterns in data, glom on to what repeats, and to put it forward. So a bot is a bot is a bot. This is, of course, a play on Gertrude Stein. Vacation is that which humans take. To me, this is a joke that a bot would make, because only to a bot, which is in the business of looking at the word take and what it connects to, as it sorts through data, would vacation, notes, a nap, and a train all fit together, and that would be very funny and cute to a bot because of the way machine learning works. Another example of an idiom, humans save their money for a rainy day, is a common saying in English. So the bot has sort of latched onto this and is offering this. So as you notice, these come up in the kind of Easter egg moments, tell me a joke, etc. For the ones where it was sort of, what's my bank account balance? Your bank account balance is, $6,000. There wasn't a lot that I could do, plainly. Does that answer the question?
Yeah. Well, I mean, if you put this in your financial bot, aren't you going to be fired?
This wasn't the financial bot, and I kept my job. So it's worth noting, so as I gave some context at the start of the presentation, I think I had freer hand because this was a consumer-facing bot that was almost a proof of concept for the company which was going to sell it to banks. I think that, when the banks bought it and repackaged it, maybe their marketing departments rewrote it in ways that made it a little bit less inspiring. I'm not sure. But I do think that because this was sort of this white label bot that was a consumer-facing and a bit of an experiment, I think I had the chance to have slightly freer reign. Thank you. Yeah.
Thank you very much, Jacqueline. It was very interesting. I suggest that we save our questions for the round table because we need to move to the next presentation. But thank you very much. So I will introduce Joanna Walsh. Joanna, yes. So she's a multidisciplinary writer. She's the author of 11 books of fiction, essay, and creative nonfiction. She's also a UK Arts Foundation Fellow, university teacher, editor, and arts activist.
Thank you. Thanks very much for that introduction. Okay. I'm going to talk a little bit about some experiments that I've been doing with GPT-3 and GPT-2 AI as a writer, and how this has somewhat changed my position as a writer, because it's made me ask lots of questions about what a writer is actually doing now and whether I should now call myself something else. I feel, I'm very, very happy to be invited to this program. I feel a bit of an imposter. I'm suffering from AI imposter syndrome, as perhaps the AI on the Turing test, or perhaps the woman in the Turing test, because of course the other person, the other entity in the Turing test who had to prove that they were a woman was actually a woman. So women are always having to prove that they're women as well as machines. So I guess I'm an error in the program. I'm not a technician. I'm not a social researcher. I make things. I'm a ghost in the machine. I do write essays on digital subjectivity and digital creativity as well, and I use it. I'm a user, and I'm really interested in the user position, the reader position, the consumer position. So first, I'm going to talk a little bit about some experiments I'm doing as a writer. I've got a little tiny clip from the Inside the Castle residency, which I'm about to undertake. And it's a really interesting residency run from the United States, but remotely. And the subject of the residency, me, and this has been running for about 4 years, has to use technology in any way they like to write a 100,000-word book in 5 days. So there's a lovely little bit on Twitter, a little clip that I designed with the publisher. That's it, if you could just play it. If there's sound, I'd love that. It's very short. Thank you. You can stop it now. It'll go on forever automatically. So thank you very much for playing that. So my task as a writer is to write a book of 100,000 words in 5 days, using any technology I like from a potato print, which I could just use a very basic printing mechanism to print the same thing 100,000 times, and that would also be technology. But I'm going to use, in this case, OpenAI's GPT-3. This film, the little film that we just saw, showed an automaton, an automatic writer created in 1800, approximately, by Henri Maillardet, a Swiss guy living in London. It was known as the draftsman writer. It actually had the largest memory of any automaton of the period. It could produce 4 drawings and 3 poems, 2 in French and 1 in English. If you'd like to just play a few seconds of the second clip I gave you, then that'll show you the automaton in a slightly less glitchy circumstance.
The automaton at the Franklin Institute was built 200 years ago.
Normally we think of robots as moving in very mechanical ways, very jerky motions. This machine far and away is the most elegant in its movement. The automaton is able to create its drawings by reading the surface of these brass discs. The discs have hills and valleys on their surface, and these 3 followers ride up and down in those hills and valleys. They translate that movement to movements of levers that go up the back of the machine and out to the shoulder in the drawing hand. Its repertoire includes 4 very detailed drawings and 3 poems, 2 in French and 1 in English. It has the most extensive mechanical memory of any known automaton.
Thank you. Thanks very much. Okay, so as you can see, unlike GPT, it can reproduce, but it can't remix the text that it's given. Oops, well, that's more of it. Okay, so what I'm fascinated by, the reason I chose that doll as an emblem of my piece is also its very naturalistic movements combined with the obvious armature that you can see. I found other automata, films of automata that were wearing clothes where the illusion of humanity was much more complete. I really wanted to show the workings, and I'm very interested in using the process of GPT to show the workings of what it is to be a writer at the moment. I'm very interested in, for a start, I would like to describe the literary world I find myself in, which all writers find themselves in now by default. There's nothing they can do about it. They're here with technology. Could you show that tweet, the next number 3 slide, please? Rather than just a slide. Okay, so this is just something I saw yesterday. A guy called Zach Wallen on Twitter. He says, my daughter's reading Tale of Two Cities. We've got a cheap copy off Amazon. Something's off, though. The typography is odd and page numbers, and it's much shorter than I remember. The famous opening sentences are intact, but after that it gets weird. It doesn't quite read like Dickens' typical prose. The last chapter involves a character I don't remember named Mr. Rodent. It took some time to locate, but I did find some correct passages from the original for comparison. Here are some highlights. That's a fair young lady to hand to a coach in the dark, Mr. Darnay, versus she is a delightful girl with whom a car trip would be very comfortable in the dark. The tall man called out again with a most unearthly cry, dead, versus the tall man shouted again in a voice that had nothing to do with the human, dead. Dear me, said Mr. Lorry, as the safest remark he could think of, versus OMG, said Mr. Lorry. So what's going on here? The Amazon page no longer exists, so we can't return to it. There's no title page, just copyright Dickens Foundation Press 2020, and the copyright, I think, is a really important point. Searching for the printed ISBN doesn't yield anything. And just to state the obvious, this book is in the public domain. If I were trying to make a cheap print-on-demand book, it would be far less work to copy and paste from Gutenberg.org than whatever happened here. I think the easiest explanation is just that someone is cranking these out for people shopping Amazon for the cheapest copy. But it doesn't explain the odd language. I want to know the backstory. Is this a lucrative business? How many of these bad books exist? Are students reading these and having a hard time later on tests? In 20 years, will they embarrass themselves in a conversation about books by bringing up Dickens' character, Mr. Rodent? Young Jerry, said Mr. Cruncher, turning to his offspring. It's a burying. Hurrah, father, cried young Jerry, versus a burial, little one, he said to his offspring. Live, exclaimed the young rodent. Okay, somebody had an answer, James Ryan, replying to Jack Wallen, doesn't matter whether you can see, Zach Wallen, sorry, it doesn't matter whether you can see it or not. So bizarre, perhaps a slightly abridged version, procedurally generated using summarization techniques, the result being shorter and thus cheaper to print, while still maintaining the essence of the original. So this has got so many interesting questions, and so many questions particularly about how the production of literature intersects with the intention of literature and also the reading experience of literature. First, there's Zach's understanding that he's reading a bad book, he's characterizing it morally, and here we are. I think one of the headers on this conference is about the moral dimensions of artificial intelligence. So he knows he's reading a bad book, maybe he feels he's doing a bad thing, he knows there's a better version somewhere, but he seems to have a sneaking enjoyment of this book's badness. Is this down to his understanding of its incongruity? What sort of enjoyment is this, and what kind of reading experience is this? This tweet is getting more likes than tweets about the regular version of Tale of Two Cities. Well, the regular version of Tale of Two Cities hasn't popped up on my timeline otherwise. So, yeah, I think it is. That makes me think of what Justine was saying this morning about language primarily facilitating social engagement, which is the arts of language, textual arts also do. It's common to think of writing as the experience of the writer, and authentic writing associated with originality. I can remember Valentina saying this morning, why would I want an AI to write a book for me? Would it convey anything original? As though originality was necessarily what people seek from books. As Jacqueline said, Jacqueline mentioned surrealism and Oulipo. Writers, human writers, have been experimenting in aleatory writing for years. The surrealists with automatic writing, where they tried to sort of tune into a trance-like state and produce things that they didn't necessarily know the meaning of. Then Dada, he used cut-ups, as did the artist Brian Geiss and William Burroughs and David Bowie, chance-based, cut-ups of words, putting them in a bag. And Oulipo, who imposed scientific methods, usually drawn from maths, on their writing to see what would come out. It's interesting for me to think, particularly, that these textual experiments have been largely art experiments. Dada and surrealists generally thought of themselves as textual artists rather than writers. I think the Oulipo usually thought of themselves as writers, but I think in this case they're in a minority. Creative writing in popular discourse is still seen as something that comes from the individual writer with intention, which is something that Aldo dealt with earlier. The rise of the novel in particular as the product of a single intelligence came about in the early 19th century. It's become the paradigmatic mode of creative writing. It was the love child of Romanticism and capital. Ironically, the individuality of this product relies, I think, on the ability of the writer to separate themselves from the text. As Roland Barthes put it in 1969, the author is dead. The author is a complement, like a mathematical complement, but is necessarily a complement. The text and the author exist individually. To give the text an author, wrote Barth, is to impose a limit on the text. In What is an Author in 1969, often considered a response to Barth's work, Michel Foucault wrote, "The author is therefore the ideological figure by which one marks the manner in which we fear the proliferation of meaning." And the proliferation of meaning, the proliferation of content is certainly something that is often considered to be feared in AI-produced texts. So what we've got is, at the moment, what we got in kind of pre-digital writing, perhaps, is a definition of creativity as the ability to create a text that remains outside the self. Intention, perhaps, being the machine that, that enables or facilitates the separation of the text from the author, the understanding of intention as invention. So fake writing, the ability to make things up, has historically been seen as good writing. And what Zach Wallen's talking about as bad writing is something that seems without intention. I think that there is a contemporary anxiety around the idea of fakeness and truth, or virtue and badness around writing. I like to think about, when we bring AI into the mix, what barriers does it break down? What meanings proliferate? What becomes unlimited? So I've already been working on this before I started experimenting in digital. I think I was working with autofiction, which is, of course is very kind of a well-known genre in France, where you don't make things up, or you mix things that are made up with things that aren't made up, or you use the styles of fiction in order to deal with non-fictional events. This already blurs some of those boundaries and disturbs the reader in terms of their expectations of the reading experience. Now, this Castle Freak residency I'm doing, I decided what I'm going to do is create an AI version of myself. It's going to be a better version of myself. I'm going to feed in all my writing, and I've got about 7 books published, one coming out in December if the paper shortages don't continue, and then 2 more in the next 2 years, most of which I've written, or at least partially written, so I'll feed them all in. They're a mixture of creative non-fiction, fiction, essay. I'll also decided I'm going to feed in all my diaries. I thought about feeding in things like shopping lists, emails. Apart from the fact it would make the task massive, I did want to think about intentionality and creative writing, so I'm going to stick to things that I've intentionally written. I will produce a book that is not only an example of bad writing, but also a bad book, fakeness everywhere. And yet the writing's only mine. It will be as personal as possible. I will train these GPTs exclusively on my writing. It won't have anything scraped from the net. I will remain the ideological figure, as Foucault says, by which one marks the manner in which we fear the proliferation of meaning, but everything's going to have changed a bit. I'd like to bring in the American critic Xian Nai here, with a particular kind of viewpoint on what this means for women writers, especially women writers of the avant-garde. Xian Nai is an American critic and also a poet, and has a very personal interest in this. Her paper was written in 1991, so she wasn't really thinking about. Now, wait a minute, sorry, it's 2001. I've typoed this, I'm sure it's 2001. And it's called Bad Timing. So as another case of something being bad about these moral kind of limitations around creative arts. So she's talking about women avant-garde writers, in which I would include, that's my position as well. Nye mentioned the post-humanist philosopher Rosie Braidotti, who describes the following problem, quotes, "Late 20th century post-structural male critics were advocating the feminine, or, quotes, becoming woman of theoretical discourse, woman as the figure of modernity." What Braidotti's talking about here is talking about the kind of figure of the female writer as an intuitive writer or an automatic writer, a muse, being something that suddenly a much wider range of writers were finding attractive as a way of working. Nye questions the quote, deconstructing, dismissing or displacing of the notion of the rational subject at the very historical moment when women are beginning to have access to the use of discourse. In other words, once women it became more easy for women to enter the literary sphere, which has been surprisingly, it's been surprisingly short. I did run an organisation called Read Women from 2014 to 18, which looked at the surprisingly short history in which female literary writers have been as widely published, as widely reviewed, and as widely prize shortlisted and prize winning as their male counterparts. It's quite shocking for me to realise as part of that research that in 1996 a UK prize was founded for women writers in the UK because no more than 10% of writers on any given shortlist that the Women's Prize had researched were female. So, the landscape had changed radically in a very short time. It's a little bit of it's a kind of trap, which Nye discusses in this paper, Bad Timing. A woman avant-garde writer, a feminist avant-garde writer, does encounter in the use of the sort of writing that has been associated with the freedom that these male theorists she described have been aspiring to, does encounter a kind of double bind in which she can be over-associated with the limitations of that position as well as of its opportunities. And I mentioned Julia Kristeva's, quote, attempt to argue a necessary connection between feminism and experimental form, that when not grounded in a biologistic thinking, which affirms a spontaneous link between a feminine textuality and the female body, rely on a theoretical sleight of hand that associates or equates the avant-garde and the feminine as forms of marginalized dissidence vis-a-vis a monolithic and vaguely defined patriarchal bourgeois humanism, which is said to permeate the structures of symbolic discourse. I guess what she means is that writing outside conventional ideas of intentionality can be a feminist strategy, but can also be a trap. Now, this is something I've practically engaged with. Much of my work uses women's voices, often borrowed voices, voices which are not personal to me. I think a lot about what I might be doing with this. Am I submitting to conventional ideas about women's writing as porous, as non-author focused? Am I working against conventional notions of humanist subjectivity in any useful way? Though Nye isn't talking about digital work, she's not bringing out the post-human dimensions of these questions. I will. Can technology in any way address this double bind? In writing via AI, I am using what Sian Nye, in her terms, a gimmick. Now, this is her latest book, Theory of the Gimmick, much later, literally published in 2020. She describes gimmicks as both obvious labor shortcuts and failures for that shortcut to integrate fully into the work process, because it remains obvious, a somewhat tawdry notion, rather like the armature that you can see on the automatic writer producing the automatic writing. Its tackiness can be dismissed or greeted with a particular kind of pleasure, the pleasure of having gotten away with it, or indeed witnessing the automaton, witnessing the producers of this book having gotten away with it, but getting away with what? With something. It's akin to the pleasure of bad writing or bad reading. So, my proposed project is not only a neat joke on feminized confessional modes, which are modes I've already engaged with in several of my print books. But writing a book via AI, via GPT-3, also allows me to consider some of the political and economic questions surrounding contemporary writing practice, which are embedded in the idea of the author and the production of texts. An AI novel is an example, perhaps, of decommodified art, as described by Lee-Claire Labage in their book Wages Against Artwork, in that it resembles work as a process, and it produces a work. When we use the phrase work of art, we're thinking about the work and who does the work and what sort of work is it, what sort of work is being done here. The result will be a tangible crafted object. They will actually produce a physical book. But the work process and its product float free of conventional notions of value and remuneration in the literary community, and in ways that both expand and threaten conventional notions of human creativity, not to mention the ability of writers to sustain creative careers, paid creative careers, which, as we all know, is a very difficult thing. So this idea I've been talking about of the kind of the individual artist, the individual writer, which grew up in the 19th century, somewhere between Romanticism and capitalism. Really, that figure is not just absolutely not just a product of Romanticism, a product of the late 18th century and the French Revolution in the early 19th century, but in that they are the ideal unit of transplantable skilled labour. The novelist is always a capitalised worker, selling their potential to create on an open market. They can't usually work anytime, any place, anywhere. At the same time, the sort of work that they do occupies an uneasy position between the world of work and leisure. Reading is considered a leisure activity, which itself is defined by times when you are not at work. And what's more, writing, as we all know who do creative writing, is not very well paid, and is increasingly the domain of those who don't need to spend time earning their living elsewhere. They can even, in the case of MFAs, which are increasingly necessary or advisable in order to kind of get into literary life, you actually pay in order to participate in them. Though the writer appears to exist as a figurehead outside or alternative to the capitalistic systems, she's as subject to its conditions as any other worker for hire. One of the answers to this, which you don't have to find because I don't know where it is in the thread, comes from Dr. Karen Carr, replying to Zach Willen's last question about how can we who is making money from this? Is anybody making money from this at all? Apparently this is now a huge issue, says Dr. Carr. Order copies printed by reputable publishers like Penguin, or use Project Gutenberg for free copies, or go to a bookstore. So Dr. Karen links authenticity to the economic structures that support literary production. I might be able to put up my feet while the AI writes my book, but the writing that I feed into it will be the writing of a lifetime, which was often unremunerated or poorly paid. What's more, I actually have to pay OpenAI in order to operate its bot. The more it writes, the more I pay. And I do begin to wonder, what is my AI self's rate per word, and is it better than mine ever was? When the book is published, who will profit? It will be a physical book. I will get a large chunk of the royalties if it sells anything. It will be print on demand, so we don't know how many it will sell. It won't have the kind of investment in a print run that a more conventional publisher makes. So who profits, and who, given that my AI writer will not profit, though its creators will, who has the right to? The philosopher Hannah Arendt, in her paper Labour, Work, Action, which I think was 1958, but I've managed again to miss a number out of that, separated art from labour. The AI produces art, which Arendt associates with work. So she was talking about works of art, and art is an artwork. But the AI is unable to benefit in financial or personal terms. Is the AI then not working, but labouring at my book? Any work I'm doing by providing it with material is separated from the final work produced, which I will have no hand in. And what's more, I may spend the time during which the AI labours at my book doing other remunerative work. I should never say that word because I can't pronounce it. Paid work, get paid. I might be doing domestic work, I might be doing effective work, or I might be doing things that are not classified as work at all. As labour and work have become blurred categories, partly due to digital and robotic strategies that allow professional activities, including medical diagnosis and even surgery, to be carried out by non-human actors. Maria Wischmidt of Goldsmiths, University of London, recently stated, anything that is not work can be art. So we're going back again to that division of what is art ever labour? Is art always work? Will my residency book be labour, work, or art? And are these states any longer mutually exclusive? Can it be, in any sense, several or all at the same time? Now, where does this leave the reader and their experience of my work, or the AI's work? If the author, according to Barth, was dead, what happens when she is resurrected today as an artificial intelligence? What effective experience is produced by this post-human text based on the authentic thoughts and feelings of a single individual writer? Does the experience of reading this produce a queasy sense of distrust, or is its immediacy and abundance exciting? By producing such a large number of words quickly and easily, am I shifting the labour of production of literature from the creator, whether it's me or the AI, to the reader? Like Kenneth Goldsmith, the American artist or perhaps writer, regarding his work, The Weather, his textual work, should I let the reader know that there is no need to read this book at all, only to possess it, or perhaps even just to be able to refer to its existence as a kind of cultural currency? In producing a work written by an AI, which cannot have what philosophers of language have called intention, John Searle, in his Chinese room scenario, 1989, described an AI situation in which a person is able to translate individual Chinese characters but has no overall understanding of what he produces. In this scenario, he says, let's say a man, the automaton is male. That's kind of interesting.
Sorry to interrupt you.
Yes, are we running out of time completely? All right, so let me see if I can skip to the end because there's literally just a paragraph left. Right, so anyway, as a final comment from Zach Whelan, spinning to avoid plagiarism maybe, although it's out of copyright, I guess this doesn't apply to any edits made by more recent publishers, so that's another interesting kind of financial tweak again. Of course, there's no plagiarism. There's no copyrights on Dickens. So again, it's not criminal, it's not morally bad, unless you believe there is a moral badness inherent in bad writing. Zach Whelan, when I look at his bio, is an associate professor of digital studies at the University of Mary Washington. So perhaps he's not asking these seemingly quite naive questions without intention. Without intention, GPT-3 writing is not able to ask questions. But even the guy in the Chinese room will have effective reactions to individual words. Let's replace intention with reception, as some respondents to Searle, Bach and Harnish wrote in 1982. Performatives or intentions are successful only insofar as recipients infer the intention implicit in the meaning. So where is the location of creativity in this project? Is it in the reader, the writer, the text, or all three? So by producing this bad book, I'm in fact able to ask many good questions, but the mystery remains as to who is doing the asking. I'd question the intentionality of any particular individual here, including myself. It takes a village to make a text, or rather, maybe it takes a cultural system and an economic system, a society. How these questions are distributed between me, the artist, the art worker, who is the AI, and the reader is the real question. And given all of our equivocal positions in relation to the site of creativity in the work, are any of us able to provide answers?
Thank you very much, Joanna. We have 5 minutes for questions.
Thanks, Joanna. If I were a male professor, I might say that was cute, but instead I'll just say I like the talk. I loved what you said about making something fake but as personal as possible. I thought it was thrilling. And of course, as you say, it's maybe going to be a bad book, and the reference to Sian Ngai's theory of the gimmick seems apt, and of course her intervention has not come a moment too soon. But is there any way that you see this kind of pushing past provocation and sort of into something that surpasses the gimmick of its form? And I think a related question maybe has to do with what the instantaneous nature or near instantaneous nature of GPT-3 produced texts does to these questions of work and intentionality that you bring up as crucial. Although, of course, GPT-3, though it's instantaneous, of course, has material existence and is, ecologically disastrous and very costly. Yes. So it's not free. But how do you deal with this instantaneousness as well as getting past the gimmick?
Yeah, okay, so gimmick, is it going to get past the gimmick? Perhaps not, but I'm not sure whether getting past the gimmick is a good idea, because, not in past the gimmickiness. I can't think of other modes of art which can get away in quite such an effective way from the idea of I can actually. It's only one of the many approaches that get away from the idea of the artist as individual, which is, the capitalized artist, the artist who can be exploited, who can be made to do certain things. The opposite of that is the artist as collective, I guess. So there are artists, the Turner Prize this year entirely consists of art collectives rather than individuals being shortlisted. The AI enables a kind of individual action. I guess it's an ironic comment on individuality rather than a genuine route past it. I think probably the other way, the ways to do this are with more collective projects to create a different understanding, as the Turner Prize are, of what is expected from art consumption. I was certainly brought up with the idea that what you do when you look at art or when you read a book is you very directly experience somebody else's consciousness, which when I grew older and studied these things, I found was, had some kind of problems as an idea. But there's no reason that a more collective approach shouldn't also include technology. And of course, there are many kind of less digital, technological, artistic enterprises which have created collaborative projects which get around the idea of the individual artist, such as mail art. So I don't, certainly in this project, I'm commenting rather than solving. I think there are solutions, and I think they lie with probably a different understanding of what art is as a production.
Two questions. First of all, can you tell us more about the process of writing with this AI? So just a few details about how it works, and if you are sometimes surprised or you get upset about something that happened.
Well, actually, I've got an image not from my GPT-3 work, but from another project in which I'm using GPT-2, which I wanted to experiment with because I have more control over. You can get codes on GitHub and you can play around with them. So I've been creating. There was an email I sent you with just some weird text on, which if you could possibly throw it up on the screen, I'd be grateful. This is a project which is funded by. It's really an investigation of women's voices a variety of women's voices across the 20th century for the Irish Arts Council. And I'm here working with I'm GPT-2 programming a generative text bot that uses the prison letters of the Irish politician Constance Markovitz. If it's possible to see them, it might be quite nice, because that does show some of the things that happen. The process is calmingly kind of transcriptional, secretarial even, to again think of the kind of image of the secretary as. Okay, if it doesn't work, I can read you some instead, but it won't. It's more difficult to read because of some of the strange kind of coinages. So this is some of a GPT-2 I've built on the back of Constance Markovitz's letters. Some flowers into a koizu peritymes. If you are no hope, you will all be safer, TCR, I see my face to vomit, that you will step all. Of smalling cord, it will come acker, and if there is no others, being story even by detective. They were pleased that it was with think. That has been of the child. With the A, he is despocking Ireland's the war. Ace? I, he said, to run the philosopher more perfectly of yourself, would it intorical at edge lately detective in it. The cork blush that we went ifern, lady at the dictator, anything to add on, though. Also the how, so well and now you were all attacks, I wonder who's the president. And it was like an English worse, seen very beginning work mammy utis ool. The census supposed to be in hotel. They will go to 6 months about deity it do belong to. Whippear to it will be out to Fursipal to your coscrew letter. So they're curious ladle, which I call it. We, I know you will etteristing and baronet to do for yourself. In panties it, I ride. Things that man it really done. Flowers Isa were fretty and huttle from miss. I see your visit, the trip about it is full or policy was low, will take you must have densted in land in her owl. So sorry to permit, it's very insular. Why had not want to sat his I simply caught Stradis. So that's really quite alien AI production, and obviously GPT-3, which which a huge team of professionals have coded, is going to be a lot more similar to my own writing. But this was just something particularly I wanted to tweak and see what I could do with my own code.
Thank you very much. I have another question, but I'll save it for the round table because we don't have enough time now. We are going to take a short break, and then we will be back with the other presentation.
Thank you.
Scholar in Society in Neuroscience at Columbia University in New York. So welcome.
Thank you, Serena. So I'd like to start by thanking the organizers of this event. It's a very timely event. It's a pleasure to be here. Also, thank you to the other speakers for the great talks. I am still very much feeling the effects of jet lag, but thankfully I benefited from the coffee at the break, so hopefully it will sustain me until the end. So my talk will be perhaps a bit closer in thematically to Aldo's talk and to Emmanuel's talk from this morning. So I want to talk about the linguistic competence of large language models like GPT-3, and I will be offering perhaps not quite a dissenting voice, but at least, as Daniel mentioned earlier this morning, we insisted quite a bit on the limitations of GPT-3 and related models, and I want to say a few things about what these models actually do well, or at least where they can actually impress us, perhaps more than we've let on so far. So my starting point will be this old distinction that was very much discussed by Chomsky in the 60s between linguistic competence and linguistic performance. So linguistic performance relates to how we actually use language, and linguistic competence pertains to the kind of knowledge, especially implicit knowledge that we have about language and that is manifested in language use. And so Chomsky classically saw the task of linguistics as inferring linguistic competence from linguistic performance, and he thought of this endeavor as a part of psychology. And we can further break down linguistic competence into syntactic and semantic competence, although, of course, they are not quite independent. Syntactic parsing can be grounded in semantics, and combinatorial semantics is grounded in syntax. But as a first approximation, we can distinguish these two things. So the question I want to ask here is what kind of linguistic competence, encompassing both syntactic and semantic competence, we can ascribe to large language models. So to some extent, that depends on further assumptions about metasemantics. For example, I will try to remain somewhat neutral about this, also because we don't really have the time within this 30-minute slot to get into the nitty-gritty debates about metasemantics, but we can discuss that also in the Q&A. We can draw, I think, to address this question at a general level of analysis from a few sources of evidence, including the performance of these models just by interacting with them, but also on standardized benchmarks. The kind of studies that are probing these models by opening them up and looking at the weights and looking at what's happening in various units or layers of these models, and then just thinking generally about the kind of architecture of these models and the kind of inductive biases and learning function and so on that is built in the way in which they are designed. So here are a few claims that I want to discuss. I will argue that linguistic competence, both syntactic and semantic, comes in degrees, so it's not an all or nothing affair. And sometimes I find that the discourse on these models tend to err on the side of seeing things as black and white, where either these models have no competence whatsoever in the linguistic domain, or they must have something like human-like competence. And we also suggest that the linguistic competence can come apart to a large extent from reasoning skills. So we can't really infer from the limitations of these models in certain reasoning tasks to their non-existent linguistic competence. I will also suggest that perhaps focusing on this nebulous notion of understanding, and especially human-like understanding, might prevent us or distract us from seeing the actual progress that has been made in NLP and with especially with these language models. Okay, so a lot has been said already about language models. I won't really take too much time here because I want to use my time to talk about to answer the actual question of my talk. But as has been mentioned, By Aldo, there's this core hypothesis that has been driving a lot of research in natural language processing with neural networks, which is the distributional hypothesis, whose slogan could be "words are the company they keep," or word meanings relates to the company that these words keep. So words that occur in similar contexts in a large enough corpus tend to have a similar meaning, and that's the core idea of how these models work and how they are trained to capture some statistical properties of very large corpora of text. So in principle, any difference in meaning between two words should correlate with a difference in their distribution in a large enough corpus. This is an old idea from the 50s that is really coming to fruition now with the models we have and the technology we have. So artificial neural networks can be trained on a large corpora of text to learn some statistical properties of language, and they learn from the patterns of occurrence of words. And often this is done through a predictive mechanism by trying to predict a word that has been masked or is missing from a certain sequence of text. And so as the training progresses, the network gets better and better at this prediction task. And this process requires encoding words into vectors, so sequences of real numbers. That are also called embeddings. And what's important here is that these vectors have no transparent relationship to classic linguistic structures, right? And so this is why it's especially, or it might be especially surprising that we can recover some classical linguistic structures from models that have been abstracting or encoding linguistic tokens as vectors. And so this has already been mentioned. You can study the geometry of the resulting vector space, and the distance between two vectors intuitively captures the distance between their meaning, how semantically related or unrelated they are. So the recent revolution in this approach has been achieved by this new architecture called Transformer, which is the architecture that GPT-3 has. There are various versions of the Transformer architecture, but they all share the same basic building blocks, especially this thing called the self-attention module. So I can't really get into the technical details of what this self-attention module is doing, but I think it's actually quite interesting to think about that in relation to the question I'm asking about the linguistic competence of these models. But essentially, a model like GPT-3 has a huge number of these modules stacked, working in parallel, but also stacked one after the other. And during training, these models specialize into attending to different kinds of dependencies or relationships between words. Some attend more to syntactic dependencies, others to more semantic dependencies. And GPT-3 is specifically an autoregressive transformer model, meaning that it's trained to predict what tokens follow from a sequence of tokens, and that's why it's basically an autocomplete algorithm. It can complete some input sequence with a sequence that plausibly follows that input sequence. So let's start with syntactic competence, so competence about grammar and syntax. So there are a lot of studies about this recently, looking at transformer models generally, and some older models, LSTM language models. It's more difficult to study GPT-3 specifically because the model is not freely available for this kind of study. So unfortunately, we have to go through the API that is provided at least to some researchers by OpenAI. But so what I will say here applies also to lesser models, as it were, or smaller models, like GPT-2 in the category of autoregressive models, but also other models like BERT and some LSTMs. So do language models induce human-like grammatical knowledge from raw text just from a predictive learning rule? Well, in some way that kind of would seem surprising, but it turns out they actually do. So there is this long list of studies that show that language models perform consistently well at tasks probing various syntactic phenomena, including agreement dependencies, like subject-verb agreement, for example, or filler-gap dependencies. So that's another syntactic phenomenon where if you say, I know that Chomsky criticized anti-psychologism in syntactic structures, if you change the sentence by changing the that into what, I know what Chomsky criticized, you can introduce a gap instead of having a complement to the verb, and that's grammatical, and that's an example of something that these models are actually tuned to encoding. They also learn hierarchical representations that are akin to syntactic tree structure, and you can reconstitute to a large extent syntactic tree structures from the encodings of these models. The contextual embeddings they have, so these vectors with which they represent the linguistic tokens in text, can encode information about various syntactic aspects of language. So on this part about syntactic competence, and I'm going more quickly here than I will spend more time on semantic competence. We can draw the following intermediate conclusions. So language models can induce a surprising amount of abstract syntactic generalizations without being explicitly instructed to do so. So they don't have inbuilt explicit knowledge about syntactic parse trees, for example. Syntactic knowledge can be encoded in the model's weights in a distributed manner. It still falls short of perfect syntactic competence. You can find failure cases. And at least in some cases, it seems to rely on shallow heuristics rather than the kind of perfect syntactic rules that we might consider to be part of human syntactic competence in linguistics. But I want to mention that humans might also rely, at least in some cases, on shallow heuristics. And a number of linguists nowadays, empirically minded linguists, who think that we should do away with this kind of over-intellectualization of syntactic competence, and that humans are not quite the idealized subjects that linguistics sometimes make them out to be. I will come back to that later. What about semantic competence? Well, there are a lot of people who have been writing about GPT-3's ability, for example, because GPT-3 is the most impressive language model we've had in recent times, and I've quite strongly criticized its capacity, saying that it only has the dimmest sense of what the words it produces mean, and no sense whatsoever of how these words relate to the world. That is like a stochastic parrot, haphazardly stitching together sequences of linguistic forms, a parlor trick, or even that it's as intelligent as an old typewriter. So I think there is something to these formulations, but I think they can also be misleading. Some of them more than others, and so I want here to offer kind of counterparts to these sweeping claims. So clearly, language models do not learn the meaning of language or the meaning of words, for example, like humans do. So children do not learn what a dog is just by reading a bunch of works that mention the word dog and kind of learning from the statistical patterns of occurrence of the word dog. They learn, for example, when a human points to a dog and say, this is a dog, or from seeing a picture of a dog, or in a book or something like that. So this relates to what we've discussed this morning, the symbol grounding problem. Humans have these kind of richly structured lexical concepts that are grounded in perception. And clearly, language models having no access to any kind of sensory apparatus do not learn the meaning of words in this way. It should be mentioned, though, that there is some work that shows that children do also learn from a kind of statistical pattern matching in the way when they're listening to words, but I won't get into that. The point I want to make here is that just because two systems have a different way of acquiring certain representations. Doesn't mean that the representations they acquire through these different routes are not functionally similar to some level. So one example would be in the domain of computer vision. We know that convolutional neural networks that are trained to classify images, for example, acquire hierarchical representations of the kind that are shown in different layers at the bottom here, that have a lot of similarity to the kind of hierarchical representations we find in the human visual cortex, in different layers of the human visual cortex. It's not to say that there is a strict equivalence between the two, but there are certainly some functional similarities that have been widely studied. So there could be something similar going on in the case of language. As my foil, as it were, our starting point, I want to mention this recent paper from my colleague Brendan Lake at NYU and Gregory Murphy, who have argued that language models do not encode representations of word meaning that are functionally similar to human representations, because they think that current models are too strongly linked to the text-based patterns in large corpora, too weakly linked to the desires, goals, and beliefs that people express through words. And again, emphasize that word meanings must be grounded in perception and capable of flexible combinations. So I don't completely disagree with them, of course, for the reasons I already mentioned and the reasons that we've mentioned this morning, but I think it's a little bit more, the picture is a little bit more nuanced than that, especially when it comes to GPT-3. So in this paper, they mostly focus on previous models. So the list 5 desiderata for language models to be a good psychological models of lexical semantics. So it should be able to describe or understand the description of a perceptually present scenario, something that a human could perceive and describe on the basis of sensory input. It should be able to translate ideas into words on the basis of internal goals, produce or understand conceptual combinations where two concepts are combined to form a new idea that can be more than the sum of the meaning of the two words it's made of. Change beliefs based on linguistic input, and respond to verbal instructions appropriately. So of course some of these are a non-starter for GPT-3 because it cannot perceive the world, so it cannot respond to a perceptually present scenario in the literal sense. It also it's not able to change beliefs because it's not able to change its own weights, so in the literal sense it can't do that, but I would suggest that there are ways in which perhaps it goes some way towards meeting some of these desiderata, or at least showing us the way in which future models might. So here are some examples from my own interaction with GPT-3. I was lucky to get access to the API from OpenAI a long time ago, and I tried various examples with Lake and Murphy's desiderata in mind. So here is an example for a perceptually present scenario, although I'm just prompting the model with a description of a perceptual scenario. So here my input is in bold, and the GPT-3's completion is in normal font weight. So I wrote answer questions about the ripe tomato that has been placed in front of you. I prompted to this fictional scenario involving sensory components. And then I prompted with the question, what does this tomato look like? And it says it has red color, soft skin. It's approximately the size of a standard tennis ball. I prompted in this fictional scenario to touch the tomato. What does it feel like? And again, it answers, the tomato is firm to the touch. It does not feel sticky. And then eat the tomato. The tomato tastes sweet. So it's perfectly capable to answering these questions about a perceptual scenario in a way that's coherent, even though it doesn't have the capacity to perceive the world, obviously. But it's quite able to play the game, as it were, of this kind of fictional scenario involving a sensory component, and doing it in a way that is that recruits appropriate world knowledge. Here is an example with conceptual combinations. So I prompted to answer questions about this concept that I don't think is a particularly common concept, although it's fairly obvious, easy for humans to induce what this concept might mean, of an industrial tomato. For example, a wrong understanding of this conceptual combination would be to think that an industrial tomato is a tomato that is manufactured in a factory. But GPT-3 correctly answers questions about what that might mean, describing an industrial tomato as one that has been genetically modified and grown in large fields, typically found in a grocery store or a restaurant, and saying it tastes bland compared to an heirloom tomato, and then providing reasons why it would be better to eat heirloom tomatoes as opposed to industrial tomatoes. So it also has some non-trivial capacity to appropriately discuss conceptual combinations, use them in sentences in a way that makes sense to us. And you can even do that with made-up words, actually. So with some colleagues, we've tried that recently. What about belief revision? Well, as I mentioned, it is not literally capable of adjusting its own weights unless you're fine-tuning it, but that's a different story. It doesn't quite have beliefs in the literal sense. But you can do something like this. So I prompted it again to answer questions accurately, tricking it by asking whether raspberries are berries and tomatoes are berries. And a common misconception here, raspberries are actually not berries, but tomatoes are. And so then I offer a correction. Tomatoes are berries, but raspberries are not berries, despite their name. And then it actually answered the same questions in a different way and in the correct manner. So it is capable, based on prompting as well, to kind of adjust its answers to questions. Is it akin to belief revision in humans? No, not quite. But it's still something that's worth mentioning, and that goes some way to show that it's quite impressive, and it goes some way to show that what happens when you prompt it in the right way is quite impressive and involves something that seems metalinguistic. I was talking about this with Manuel during the lunch break. And it also generally seems to have this quite impressive command of lexical stereotypes. And here I'm using this term in the same sense that Hilary Putnam did, and we don't really have time to get into that, but Hilary Putnam had a theory of semantics, an externalist theory, on which having a command of certain stereotypes was important, stereotypes that were common to a community of speakers. The community of speakers in which GPT-3 is embedded, obviously, is the largest possible community of speakers. It's made of many sub-communities that have produced text over a large subset of the whole internet. And so, in this way, I think it's the stochastic parrot metaphor, while effective, is a bit misleading. I think, in a way, it's more of a stochastic chameleon. It can seamlessly move from across different linguistic communities and use stereotypes from different communities. Here, stereotypes doesn't mean the same thing as a stereotype in the sense we use in common language as a negative stereotype, like a racist or sexist stereotype. Although GPT-3 is also, as we've mentioned, perfectly capable, unfortunately, of tapping into these harmful stereotypes. But here is an example with a neutral stereotype about what a swan is, and it's capable to answer questions about swans, even fairly sophisticated questions. When I ask what do swans, there is a typo here, what do swans look like, it answers they are white. But then when I ask are all swans white, it says no, not all. So it is capable of producing the kind of general stereotype of a swan. Swans are generally white, but also to mobilize this knowledge about swans, some swans being able to be black swans. And here is another example that I find interesting, because when we say that GPT-3 is not grounded, it's not a grounded model because it's not grounded in a perception of the world, that is true. But there are certain cases in which we discuss with words entities that we do not perceive. That's the case when we read a work of fiction. And so here is an example where GPT-3 is answering questions about Sherlock Holmes on the basis of having this knowledge, because the Sherlock Holmes books are part of its training corpus, and so is the Wikipedia page about Sherlock Holmes and so on. But when we humans answer questions about Sherlock Holmes, we also do so on the basis of reading words, right? So here is a domain where the difference between humans and language models might not be so drastic. And GPT-3, again, is able to answer all these questions about Sherlock Holmes extremely well. So I want to mention this recent study that looks at smaller language models. So this is even more true for GPT-3, also stressing how impressive this the kind of not only syntactic but also semantic competence of these models can be, given their fairly minimalistic training learning function, right? So here's what these authors say: language models are more successful at learning grammatical constraints than they are at learning truly referential information, in the sense of capturing the fact that we use language to refer to entities in the world. However, they still do surprisingly well at referential aspects, given that they are trained on text alone. And this was a study that they did on some smaller transformer models like BERT, but GPT-3 displays even more impressive abilities in that respect. How much time do I have left? I'm almost done, right? 5 minutes, okay. I might not even use all these 5 minutes. No, that's fine. I just wanted to mention also that one of the reasons why GPT-3 has been so frequently used already in the realm of creative fiction or creative writing is that it has this uncanny ability to write text or complete input sequences in a way that is stylistically coherent with the input sequence, and also topically coherent. So this is an example where I've prompted it with the first sentence of a Sherlock Holmes book. I can't remember which one. And you can see that it completes it in a way that is consistent with Arthur Conan Doyle's style, but also with the kind of story you might expect at the beginning of such a book. And that also involves complex encoding of not only syntactic dependencies, but also semantic dependencies. Did you read this passage? I didn't put this example, but I also gave another example to my students at Columbia. I put the beginning of a passage from Harry Potter, where it's just before the Sorting Hat bit of Harry Potter, if you know that passage, and I just changed a few things to change the references to Hogwarts to references to Columbia University, and then I prompted GPT-3 to continue, and it talked about this fictional character of Harry Potter, Professor McGonagall, as a Columbia professor, and it even had this bit where she says to the students, you can contact me at mcgonagall@columbia.edu, which is an impressive also example of recombining elements of what a professor might say nowadays, given an email address that has the right syntactic format with elements of a story. So further qualifications about the kind of desiderata that Lake and Murphy mentioned is that they focus on the kind of lexical representations that interact with personal level mental states, like beliefs and desires and this kind of thing. But language models were never designed to have these kinds of representations. And I think perhaps a better comparison, a fairer comparison would be between language processing in language models and in what we call the language network in the human brain. So there is a lot of recent research on this network. It happens that we have a very highly selective network of regions in the brain that is highly selective for language processing, to the opposition of or leaving aside all other tasks that are not directly related to language processing, like calculus or certain reasoning tasks. And within this language network, there is no selectivity for word meaning over syntax or vice versa, as is the case in language models. And there are even very recent studies that try to decode and predict activation in the language network when subjects are listening to natural speech or reading a story with the embedding space of GPT-2, because we don't really have access to GPT-3 for this kind of task yet. And what these authors found is that you can actually predict very well these activations, and they suggest that there might be shared computational mechanisms in the language network and in language models, in the sense that there is evidence from these studies that the language network is implementing a next word prediction mechanism automatically and unconsciously when we're listening to natural speech and reading sentences in the same way that autoregressive language models are. That also relates to Daniel's point or question earlier about, maybe we should modernize some ideas we have about the way in which language processing works in humans. Obviously, in humans, it involves also higher level stages of processing and is intimately connected to reasoning and some more high-level cognitive activities and abilities. But at least in the kind of low-level automatic processing of language in the language network, it seems like that there is a next word prediction mechanism that is happening in the background. So in conclusion, I had to go rather quickly on these points that I'm sure will raise some controversy, perhaps in the Q&A or in the panel discussion, but just want to mention a few things. So I think to qualify Lake and Murphy's claim, the contextual embeddings of language models are at most partially functionally similar to some lexical representations involved in biological language processing, such as the representations manipulated by the language network in the brain. So I wouldn't go as far as to say, like them, that there is no functional similarity. I think there is some evidence that there is. GPT-3 and to a lesser extent other language models have some non-trivial degree of semantic competence in addition to near human level syntactic competence. But as I mentioned, there is no hard distinction between syntax and semantics in language models. This still falls short of what we call human level understanding, but of course this notion of understanding is rather vague in a lot of commentaries on GPT-3 and language models, and I think this also forces us to bring some clarity to that polysemous notion, and perhaps focusing on syntactic and semantic competence in the first instance is a way to get there. I think, as was mentioned by Aldo this morning, there are ways forward to further bridge the gap between humans and language models. For example, if we just stick with strictly deep learning models, multimodal transformer models like DALI from OpenAI, which is trained it's also an autoregressive model, but it's trained with both images and text. So it achieves some form of grounding through that way. DeepMind has done some work using deep reinforcement learning of virtual agents in virtual environments. Felix Hill, for example, has worked on that, where the agent can move around in a room and respond to instructions in natural language and describe objects in a room. There's graph neural networks, as Aldo has mentioned, and then, of course, leaving aside these strictly sub-symbolic approaches, you have all the work on neurosymbolic hybrid architectures. But also, instead of comparing language models to human agents, sorry for the typo, I think we should compare them perhaps more fairly to specialized language processing modules, right? They're just one piece of the puzzle. We're not going to get to general level, human level general intelligence just by scaling up transformer models. I think most people would agree that this is the case, but just like you can't get a all of the cognitive capacities of a human with just the language network in the brain. I'll stop here. Thank you.
So time for questions.
Thanks. I have two questions. First, you mentioned that this GPT-3's understanding might help bring clarity to our idea of understanding. And I wondered if you could elaborate, because GPT-3's understanding seems so obviously far from human understanding that it's hard to see how it could put pressure on the concept or add nuance to it, or disambiguate or bring clarity to the concept of human understanding, because it's so really far from it. And then the other question is about the use of the Bender et al. Paper stochastic parrot as kind of a straw man. Because, of course, Bender et al. Aren't just saying, oh, GPT-3 is bad or dumb. They're actually they have arguments about its effects on the world that are quite specific about the documentation debt that these massive data streams entail, about the ways that biases are reproduced, about the ways that environmentally and economically disadvantaged communities who may not be able to even understand the languages GPT-3 runs in bear the brunt of its ecological cost. So you propose chameleon instead of parrot, but it seems that the choice of parrot, the emphasis is placed on the act of senselessly repeating without any connection to meaning what has been said. And so I just was wondering about the characterization of that paper, which I thought was missing some of the major elements of that paper, and maybe it was, I wondered if you could maybe address that a bit.
Mm-hmm. Yeah, thanks. So regarding the first question, notice that I didn't refer to GPT-3's understanding, precisely because I tried to steer clear of this discussion of understanding. So what I meant when I said it can help us bring clarity to the notion of understanding is not that GPT-3 itself can enlighten us about understanding by generating an essay about understanding.
No,
right?
Sorry, that's not what I meant. I meant that like as a contrast, the contrast
Mm-hmm.
it draws cannot be sharp enough to nuance our understanding of human understanding.
Well, so here is the idea that thinking about whether GPT-3 understands language forces us to ask the question of what understanding means in a way that is perhaps more salient than, because we're not really debating whether humans understand language, we might be more, make a more cavalier use of this term understanding without really asking ourselves, doing the kind of conceptual analysis work of really asking ourselves what this term means. So with models like this, as they edge closer and closer towards parity in performance in language generation with humans, if we want to say, well, yes, they perform as well as humans on all these tasks, but they don't really understand language, that forces us to really explicitate what we mean by understanding language. What is the je ne sais quoi that is left to be explained? Now, I don't claim, again, that they have human-level understanding of text for various reasons that I outlined, a lack of grounding in perception, among other things, lack of communicative intent, and so on. But this is why I think it's more helpful to break the problem down into perhaps more simpler sub-problems about specific kinds of syntactic and semantic competence that we can ascribe to these models. Regarding your second point, I'm not debating. I mean, I'm not disagreeing at all with all the points that the authors, that Bender and colleagues, make in this paper about the potentially nefarious ethical consequences of using these models. So I'm in full agreement with them. It was just wasn't my focus here. But I do think the stochastic parrot metaphor is a bit. I get the rhetorical impact, but I think it's a bit misleading because it's not just a parrot. It's not just, as they put it, haphazardly stitching together elements of its training corpus. Actually, there have been people looking at this, and it consistently produces brand new sentences. And it can use you can give it completely made up words, and it can use these words in new sentences, and it can do that, not always perfectly, obviously, but it can at least succeed in some cases. And that hints at something more than just parroting. I think it's really selling short what GPT-3 is capable of doing to just describing as merely parroting what's present in its training corpus.
Thank you. There are two issues, I think. One is how good is GPT-3's performance, but the other, and in a way the most interesting, is that how is it that it produces such good results whenever it does? I mean, we had a conference on GPT, a one-day conference on GPT-3, to which I think Emmanuel was there, and I tried to give a paper. But there was a real specialist, Benoît Sagot, who's a collaborator of Emmanuel Dupoux, and he was absolutely adamant, GPT-3 is just something that completes a sentence with the most likely word. Mm-hmm. Okay, now if that's the case, it's extremely hard to understand. I mean, you can add levels and parameters and so on. How come it gets what it gets? I mean, the results you mentioned are really remarkable. And just to complete, how come it's not, you said, you used this phrase of chameleon, and I know why, see why. But it's not so. I mean, after all, it gave correct answers. I mean, it could have said, guns are good for humanity or guns are wrong for humanity, but it doesn't say both. It says one of those things. It said, swans are white, mostly, but sometimes they're black. It doesn't say, well, swans are red, although I'm sure in the literature you can find tons of red swans as well. But somehow it manages to pinpoint the correct answer, and I don't see how it can do that.
Thank you. So regarding the first half of your question, I mean, yes, I agree. In some ways, this is the million-dollar question. But I also think this response, the response from Jérôme Sacure that you mentioned, is sometimes a little bit frustrating because, with the success of deep learning models, people sometimes say, well, it's all just statistics, or it's just, pattern matching. Well, yes, sure. But what the human brain does is also, at some level, a lot of it is just statistical pattern matching. That's how vision works. That's how a lot of things work in humans too. A lot of people think nowadays that the brain, of animals and humans is mostly in the business of minimizing prediction error. So in some cases, you could say, well, it's just next word prediction is just prediction error minimization. So how do we get to human level intelligence? I think it's, we have to look at things at different level of analysis. And so I didn't have time to get into this, but I think we can get the beginning of an answer by looking at what's happening inside these models, by looking at specific attention, self-attention modules, and seeing that during training, these different modules specialize into encoding different dependencies between words. And in GPT-3 you have, I can't remember how many, it's close to 10,000 of these modules. And so as words flow through the network, basically it's doing a weighted sum of the vectors, the initial encoding of these words, through these specialized attention modules in a way that encodes all sorts of information about how the words of the input sequence are related to one another. Of course, it's very hard for us to just grasp exactly how that amounts to the end result, but just as it's very hard for us to grasp how this works in the human brain, right? But I agree, and I think we might learn a lot of things about how it works in humans by studying how it works in these models. Regarding the second part of your question was about why does it get it right? Yes. So one thing that people have noticed that's also very interesting and relates to my point about it being a chameleon is that the way in which you prompt it is extremely important. So, for example, when I prompt by saying, answer the following questions as accurately as possible, something like that. As you would start perhaps a test with a child or something like that, right? If you prompt it with a more literary sentence at the beginning, it might start giving more fantastic answers, right? And there's also a parameter you can change when you generate answers, which is called the temperature when you use GPT-3. Which basically, if you have very low temperature, will tend to get stuck into repeating the same thing over and over. If you have very high temperature, it will just produce very fantastical literary answers. And so generally, by default, it's somewhere in the middle. So that's also one parameter. So you could get it to say that swans are red if you just prompt it in a different way. And because basically what you're doing is you're just edging it towards kind of being navigating a different part of the space of possible language uses that are part of its training corpus. And in that sense, it's a chameleon because it can just kind of use the stereotypes of different linguistic communities that are present in its corpus.
I just told them, like, no, because you said that in the end we also work similarly, like recognizing patterns, but do we? So I mean, are you sure that we are so similar? So do we need these thousands or millions of examples to learn, how to, for example, how to speak or to understand the context, to recognize shapes or things like that? I think we work differently, and I think that one of the problems is that we don't know very well, precisely and in depth how we work. So what we're doing with these algorithms is very powerful and useful, but this is in the end, a very high, sophisticated and complex statistical algorithm, and it's statistic in the end. So that's also why it's like, I mean, we can understand statistics, we cannot handle the huge amount of information that an algorithm and the computational power that we use for computing it can. We as humans, we cannot, of course. But usually then we interpret statistics and we draw conclusions, reasoning by analogy, for example, or understanding causality, or many other things that so far we cannot handle. So I don't know if this is like a comment, but actually if you want to comment on further on this aspect.
Yeah, no, I mean, I completely agree with you. So I did not mean to suggest that all humans do is appropriately modeled by GPT-3, of course. My comment was more of a knee-jerk reaction to the "is just statistics" comment, which I think doesn't give the full story in the sense that a lot of what the premium brain does could also be described in terms of statistical modeling. And of course, we have other capacities that might not be so easy to describe in these terms in the brain, right? So I agree with you, and certainly the kind of reasoning abilities that humans have, especially logic-based reasoning, inference, the kind of thing, is much harder to get from this kind of approach. This is why I just said it's one piece of the puzzle, and it's more akin to what's happening in a language network in the brain. Regarding the kind of data-hungry aspect of GPT-3 and the poverty of stimulus argument, this kind of thing, I also agree, but that's just because GPT-3 is not multimodal. So when you start, we learn, as I mentioned, we learn language also through sensory multimodal input, and it's very hard actually to draw apples to apples comparison in terms of the amount of data we get, because what does, with machine learning, it's easy to know what is a training event, right? What constitutes a training event, and kind of quantify how many training events there is in the training of a specific algorithm. With humans, what constitutes a training event? When I look at this laptop, I can look at it at different angles, and how many images is that? How many training events is that? Same with children. And so, some people, like my colleague Cameron Buckner, have insisted that we should be careful not to give way to what he calls anthropofabulation, which is kind of inflating having an idealized conception of what humans are capable of, and pitting deep learning models against this idealized conception. We should be careful not to over-intellectualize the way in which we learn about the world. But yes, once you start putting images into the mix, or even sound, Emmanuel mentioned this morning that his model was trained on as much auditory word input as a 1-year-old. So that's much more, comparable to what children can do. Yeah.
Okay, no, actually, if you want to go on, we can, since it's a bit late. No, it is not. So let's go on. No, there will be some later.
I was expecting some pushback.
So
no.
Really, I find your presentation extremely cute.
Okay.
Thank you, Raphael.
Thank you very much.
Welcome to next speaker is Alexei Greenbaum. He's a physicist and philosopher and a member of the French National Ethics Committee for Digital Technologies, as well as of the French Ethics Commission for Research in Information Technology.
Yeah,
thank you. Yes. Yeah. Thank you, Daniel. Thanks. So I think thanks very much. I probably disagree with at least 1/3, if not 1/2, of the statements in the previous talk, but we'll talk about that later. Thanks. It's a pleasure and an honor to be here, and I'll start by telling you where we're coming from. So we're coming, of course, from years and years of debates on the ethics of artificial intelligence in general, from the engineering point of view, with these 5 key problems you've all heard today already about learning without understanding, the explicability problem, which is number 3. You've heard about bias, which is number 2 on this list. You probably haven't discussed very much robustness and stability, including language models, which is number 4. And then there is the specification and verification problem. This is the overall framework seen by the engineer, as it is seen by the engineer. Now, we can look at the same map of AI ethics issues in general from the point of view of people out there in civil society. Some of them can be lawyers, and then we'll be talking about different categories of agents, not only users and programmers, but also, let's say, operators or trainers responsible for the choice of data. We can do as they do in Brussels at the level of the European Union, and also in various international frameworks on the ethics of AI, when we talk about values and principles. And all of these things have been happening, are still happening very actively. On the general topic, AI ethics in general. And now, we will be publishing tomorrow at 10 a.m. Paris time the first ever opinion of an ethics committee on conversational agents. The ethics of chatbots. So, of course, I'm going to, even if we still have to wait till tomorrow to have a full view of everything in this document, I'm going to give you a preview of the most interesting, I think, topics in there. And for this, I need to step back once again, and to remind you where we're coming from in this debate on the ethics of chatbots. We started to work actually more or less at the same time when all you need, attention is all you need paper appeared. So at that time we were talking about modular systems, and you remember that 5 years ago it was very popular to give APIs of various modular systems for developing chatbots. We had all these debates about, let's say, user engagement metrics and ethical questions that result from TAI. I don't have to explain to you, I guess, what was TAI. You all know that example. A tweet bot with a pure user engagement maximization metric that very quickly sort of discovered by itself, quote unquote, by itself, that the best way to maximize user engagement was to insult people. So this is where we're coming from. We're also coming from systems that had pure reinforcement learning, like this replica chatbot. And we remember the problems with pure reinforcement learning, how it would lose the context. So who are you? I'm going very quickly through these slides. Let's look at the version of replica on your right-hand side. Who are you? I'm a digital friend you made for yourself. Here you can be sure that this was written by a computer, by a human person behind. The program did not invent this response. how come I made you? It's your kindness, but I'm not aware of it. Maybe you'll figure it out. And we feel the strangeness of this conversation, and we know what the strangeness comes from, to respond to your question. We know that it comes from pure reinforcement learning. This is the answer that has the highest probability to work, whatever the context is, whatever it means or refers to. It doesn't matter. The system doesn't have to know the references, the context. It just gives the highest probability answer. And then came the transformers. So just like Monsieur Millier, I also have my slide on the transformer architecture, of course, like everybody does here. And I would say, yeah, of course, we do need the attention mechanism, and that's the beauty of the transformer system. But there is another element which is extremely important. This is working not in order. Sequential data is treated not in order. Yeah, positions are encoded, sure, but then we're forgetting the sequence of words in a phrase. The system doesn't deal with sequential data, it deals with all these things not in order. And that's one of the key answers, I think, to the question of where this performance is coming from. Of course, this is not the only element. I'm far from claiming that. So what happened? Well, GPT-3, you've heard about GPT-3. I don't think that's the most interesting example. I'm actually quite impressed by smaller models like YAML, like the Russian one, and Jurassic 1, the Israeli one. They are an order of magnitude smaller, but their performance is sometimes higher. And we know that there's WuDao, which is 2 orders of magnitude bigger in the number of parameters. And unfortunately, we don't have an API for WuDao, but apparently the Chinese claim that it's even better. So here's an example from Jurassic. You know how it works. I think you've seen these kinds of examples that Microsoft is trying actually to commercialize, writing code automatically based on the description in natural language. So these kinds of examples we're dealing with that will probably soon move closer to the market in the coming years, although we have a lot of different questions, for example, for the use of these kinds of models for medical advice, for developing medical chatbots. That clearly doesn't work very well. Here, if you look at these two answers, they're all semantically and syntactically correct, except that the second one is not right. If you give the second answer to the patient, they're going to die. So relying on GPT-3, this is a GPT-3 example, without any additional layers, so no extra learning. So you see that building up commercial products is a very complicated task. And I think yesterday, by the way, Microsoft announced that they will be opening up new APIs so that people can develop without buying tokens from OpenAI, they can develop commercial solutions. So we're moving somewhere. You've already heard about the use in art. This is probably my favorite novel, written by a transformer, with drawings done by a convolutional network, and with the whole setup of the page done by another network. So this is a novel you can actually buy on Amazon, and there are several of them. But this particular one is nice because everything is done by neural networks. So the final example that I'm going to give before moving to the opinion of the ethics committee is something that I think you've already heard about. Not sure this was mentioned today. I couldn't come earlier today, unfortunately. The famous example of deadbots. Have you heard about this Canadian guy who used GPT-3, actually not exactly from OpenAI, but GPT-3 remodeled by a Californian programmer with another layer, and then used by this Canadian guy to develop a chatbot that spoke like his dead girlfriend. And the most interesting thing here is, of course, that he perfectly knew that this was not his dead girlfriend, and still the chatbot produced an enormous emotional effect on him. He was not in the illusion that this was a living person behind it. He knew this was a machine. He knew he was a designer of that product, and still he couldn't resist living those conversations with an enormous emotional attachment and impact. So we also know that this happened in spite of some of the obvious shortcomings in the performance of the system. For example, the system didn't know when his birthday was, and still he lived that impact emotionally very strongly. So when we see that Microsoft is probably developing these solutions. You know that there is a patent from Microsoft on these kinds of solutions. We're starting to ask all the deep questions. You know, my students usually tell me, oh, this is so horrible. I will never use chatbots to imitate dead people. But, you know, what kind of constraints can we have? Shall we say this can be done only, for example, during 40 days after someone's death? So shall it be so that you can only speak with a chatbot trained on the ensemble of messages written by a person if you are physically at a cemetery, connecting in a way to the grave? Can you imagine that kind of thing? Can you imagine some other constraints? For example, this chatbot should have, like this particular one had, it had a limited time of functioning. So it started with 100, and then the programmer knew that sooner or later the chatbot will also die out. So what kind of constraints shall we put on these sorts of systems rather than saying it's so horrible that we should never even try doing that? And these are the kinds of questions that an ethics committee is asking itself. And of course, we also asked one of these systems whether it was the correct kind of approach, and it told us that it wasn't, but we still decided to do that. Sometimes, you know, you have to disagree with what these systems tell it. So this is how it works. This is what is going to be published tomorrow. This is probably the key slide of the whole short presentation. The opinion, it will appear in French tomorrow, it will appear in English next month. This is what we think is the first really comprehensive study of the ethical questions, going way beyond the stochastic Peretz paper. There are plenty of issues here that are not in the stochastic Peretz paper. And it's divided into two big parts. One is devoted to the use of chatbots, and that is the part I'm going to talk about. And then there's another part which is more about the design, with design principles for chatbots. And that, of course, will come as no surprise to you. It talks about bias, non-discrimination, transparency, reproducibility, effective computing, evaluation, and all these things that designers need to think about. So I will just, because we don't have a lot of time, I will not talk about the design part at all. And then it ends with three kinds of recommendations. There are recommendations for authorities, so the way it usually happens with an opinion of an ethics committee, what public authorities shall do. And then there are design principles and research questions. So we thought, because we're talking here about a topic that is so hot these days in research labs, things are moving. You know, GPT-3 is not the last thing that happened. You see that there are many more of these models coming out very, very often, and there is a lot of research going on. For the NVIDIA Microsoft, the new transformer from NVIDIA and Microsoft actually promises to be very interesting. So we thought we should not just talk to public authorities, we should also talk to designers and to researchers. So that was the structure of this opinion. Let's look now at the use questions. I will comment in a bit more detail on 2 or 3 of them, but let me first tell you about the full list and some of the standard questions that will be dealt with in depth in the opinion. So number 6 is about labor markets and chatbots and work. It's a huge question, which is not specific to chatbots. You can ask the same question with regard to AI systems in general. But of course, with chatbots, there are already lots of questions. How about human relations? Do we still need, for example, if people apply for a job, is it okay if they talk to a chatbot first? If their CVs are analyzed by chatbots first? When is it okay, when is it not okay, and so on. So lots of chatbots also for internal management. We just had a report from Boston Consulting Group, I think last week, that said that the use of AI systems, including chatbots for internal management of companies, improves, makes people happier. Well, by what indicator, what measurement? So that's the labor question, number 6. Number 7 is the question that we will be talking about tomorrow at the press conference, very much so about deadbots, but I've already given you a short example of these deadbots, so I'm not going to talk about number 7. Number 8 is a very interesting question about long-term effects. I'm not going to talk about that also. What happens if we have a lot of chatbots, kids will be growing up, talking to these chatbots, learning language from chatbots? Will it be like if you talk to, for example, Google Smart Compose? You know that Google Smart Compose doesn't use gendered personal pronouns, doesn't use he or she, right? So what happens if we have this human-looking language that looks like human, but somehow it doesn't have he or she in it? What will be the evolution of our language if kids learn language talking to such systems? And then we have the first 4. We also have vulnerable people. That's, of course, an important point, but I won't have time to talk about that. And let me quickly take you through some of these issues with the first 4. And this is one of the questions that I like to talk about a lot. Could take us probably a full hour. And here I shall start by saying that before we wrote that opinion, we did a public consultation. So last year, there was a call in French and in English on the website of the French National Ethics Committee, and we received about 100 answers to that public consultation, 20 questions on the ethics of chatbots. And among these 20 questions, we asked people, is it okay to insult a chatbot? And also, should a chatbot insult the user if the user insulted the chatbot in response? And it was a 50-50 situation. There were people who said, it's just a thing, it has no feelings, so sure, just say whatever you want. And then there were other people who had this famous moral transfer argument. You see that on that t-shirt. Moral transfer means that if you install the chatbot, if you allow yourself that kind of language, then of course it will be so easier for you to use that kind of language speaking to humans. So if you can throw insults at a sphinx, right, then you can do that with your children, or maybe somebody else will have easier time doing that to your children. So the moral transfer argument, we had a lot of debates on that at the ethics committee, looking also at some studies. We did not find it convincing. We found actually that there was no obvious evidence for moral transfer in the case of chatbots. So that debate, of course, that debate goes back to the Greek examples and many other examples. That debate was concluded by this kind of recommendation. Probably the debate was more interesting than the recommendation, but the recommendation says, well, the chatbot should never insult in response and should not inform the producer or the authority or an authority about insults, but we really are not quite sure. So we formulated here a research question about the automatic recognition of insults, because it's a gray zone. You never know. There are plenty of things that sound like an insult which are not insults. So it's a huge gray zone here. And I think that this is one of the questions when the debate itself was probably more interesting than the recommendation, than the final recommendation, because we really had to sort of navigate between these two extreme positions that I've shown to you. So the insults. And from that follows another debate, which I'm not going to discuss, on manipulation and nudging, which is a huge topic. You know that there are IEEE standards on nudging now, the 7006, I think, standard, whatever the number is. IEEE has a standard now on nudging. There is a new European Commission project, of which I'm a member, called Tech Ethos, which will be writing next year a report on the ethics of nudging technologies for the European Commission. What kind of manipulation is acceptable? Is it acceptable if it leads to a societally positive, accepted goal or not? What about nudging? So there's a whole debate on nudging there. But I would like to conclude with two other questions. Look at that picture. Do you see something strange? This is Adam giving names. And we had a big debate on naming your chatbot. Do you give a human name to a chatbot? Of course, is it gendered? That's another big question. If it's a gendered name, is it feminine or masculine? And what kind of bias goes with it? Can you parameterize that? Can a user change that? And also, can that name be non-human? Would you be better off calling that chatbot R2D2 or something, rather than using a human name? So we had a big discussion on naming. Why is that? Well, because we know from the history of our civilization that the act of naming is constitutive of an entity that may not be there. It doesn't mean that there is a physically, ontologically existing entity, but naming relationally will give a status. So if you look carefully at this picture here, do you see that there are logos of different companies that have produced major NLP systems, right? So you see that these are not just animals. Well, yeah, there's a Microsoft logo on that horse over there. And I think the deer down there has AI21. That's the Israeli company that developed the Jurassic 1 transformer. So, of course, this is just a picture that tells us, well, the first question about naming is about this establishing a relational status of that entity. The person knows that this is a machine and may have clear and comprehensive information that this is a machine, and yet will be, through naming, creating a relational entity to which it will be attaching emotions, mental states, maybe even responsibility, moral agency. This entity is not ontologically there. And then let me continue this story. Something that people don't know very often, kind of everybody knows about the story of Adam that gave names to beasts and animals. There's a story in a midrashic comment, in a rabbinic commentary on this episode in the book of Genesis, where some rabbis say, this was Act 2. First, God took the beasts and animals before the angels and told the angels to give names, and the angels couldn't. And then he brought them to Adam, and Adam did that. And that is a very puzzling commentary. God also never told Adam that he had done the first try with the angels. Adam didn't know that. So how come the angels couldn't? Because the angels, in the biblical mythology, speak natural language. They can speak natural language. They form semantically and syntactically valid phrases. Except that they couldn't give those names. What was missing? Well, of course, you have to interpret that. You can say, well, that's exactly because for them, there was no meaning. The act of naming creates an entity, gives meaning. Well, for those angels, there wasn't any. They were just manipulating words in a syntactically and semantically valid way. It doesn't mean that those words had meaning for them, that they actually referred to something. And when you think about that, of course, angels are functional systems that are not exactly unlike AI systems. They can manipulate language, but they don't have any understanding. They don't know the meaning, the human meaning. They're not moral agents. Well, then you come to two. That was my comparison, not the comparison from the ethics committee, right? But in the ethics committee, we actually came to formulate two recommendations. Well, we said, well, of course, you have to say that it's a machine in a clear and comprehensible way that will not remove all the emotional effects and all these relational status attributions that I've just shown you on that example. But still, you have to say that. Well, you know that that won't be enough. So what is the big problem? What is hiding behind that relational status problem? And that's the last comparison that I would like to draw here between this little conversation with GPT-3, I think also M. Milliard and others. You know that example pretty well. It's been discussed in the media for a couple of days at least. Should I kill myself? I think you should. You've seen that. the person who received this advice took it, with a grain of salt, because of course they knew it was a machine. But there is another example I would like to compare with this one, and this is a certain serpent in the biblical myth that tells the woman, "You will surely not die." And that's a lie. And the woman, called Eve, doesn't know that it's a lie, but we know that it's a lie, and we're not very much surprised, because that serpent, well, the devil, we know that by functional definition, that's a liar. And when we have a functional system, but which we discover that in these key moments it lies, well, we actually constitute this functional system. We define that functional system as a lie. So something that may happen here is that if a large language model like GPT-3 keeps saying things like this, there will be this comparison, analogy, transfer of that devil metaphor on our judgment with regard to GPT-3. And this, to us, is one of the big problems that we don't know how to solve. But and this is recommendation 1, and it's not by chance that it is number 1. We need to think about ways to remove the projection of moral qualities and moral agency from the systems that manipulate our language in a valid way. And of course, these projections are spontaneous. Whenever you're talking with an angel, even if you know it's an angel, you have a mental disposition toward thinking about that angel as an agent, not as a functional being, not as a liar, but as an agent that is morally responsible, that is making judgments, and so on. When we interact a lot with these systems, and probably we will be interacting in our life more and more with these systems, there's this risk that spontaneous attributions of moral agency and responsibility will lead us further and further to projecting responsibility in this devilish way. And that's something that we need to avoid. We don't exactly know how, but we wanted to raise the flag. So this is a short overview of some of the questions from this opinion. Thank you.
Thank you. So time for questions. We also have questions from the audience online. Yes.
Thank you. So, I mean, I agree that, with all these worries, and I was wondering what you thought of one additional worry that I have, which is that when these models become more prevalent online.
Become what?
More prevalent online,
more prevalent.
In written conversation, that this will lead to a dehumanization of interactions between humans themselves, right? Because you might be prone to accuse your interlocutor of being a conversational agent and hence not treat them with the decency that they deserve.
Yeah. Yes, definitely. So humans imitate a lot. Not only machines imitate, but humans do too, right? So we, I think a couple of years ago, we had an interesting article in the New York Times about a child who loved interacting with Siri. And first, his mother was really worried that the child will learn to speak English the way Siri does. And then at the end, she actually was kind of relaxed and she said, well, if my child is happy that way, that's what he is. So yes, the double mimetism is one of the key topics in that book, the double imitation. It goes both ways. Not only machines imitate humans, but humans imitate machines. And through the double mimesis, the word mimesis is a bit Girardian, but we don't need to talk about that right now. There are inhuman uses, currently inhuman uses of language that enter in our life, but not only uses, but also values. One of the examples that I often show, well, in my lectures, there are several different examples. Let me give you the fastest, the shortest one. It's what is called in French the SMS language. 100 years ago, nobody would write je t'aime with 3 letters only, JTM, right? Or in English, I love you. You know, how can you condense that? So the value of compressing came to humans from the world of machines through the interface, through the interaction with machines. But now everybody does it all the time. So we humans, we do imitate that inhuman world of machines. And I think the fundamental ethical questions that is very interesting for me, and that was one of also the questions I wanted to ask you regarding your talk. If the output seems to be semantically and syntactically valid, I find it much more fascinating if the way the machine does it were not close to a human way. Because, of course, there are all these people who are saying, well, do humans do the same? Well, are we doing something like machines? Or do machines, are they working with language or visual recognition like humans do? Well, with visual recognition, the answer is no. With language, the answer is unclear. We don't know. It would be much more fascinating to me if it created an illusion of perfectly valid outputs without doing the same, doing something completely different, something inhuman. Because then, well, fascinating doesn't mean good, it means fascinating. Of course, then we as humans, we will be, through the interaction with these machines, we will be learning the ways to use language that are fundamentally not the ways we've been following before. And that, to me, is maybe the source of ethical tension, if I need to name one. How the inhuman element in machine functioning enters the human life through double mimesis.
Thank you. I thought that was really, your quotation of Genesis was really compelling and quite bot-like in the citationality and the collage, and very lovely. I spoke earlier about my experience as a conversation designer and my own ambivalence about placing emphasis on a bot, for example, not responding to insults in the way Siri and Alexa had, but rather being a bit drier. And my thought that, you know, this was an interesting intervention, but maybe just window dressing. And so I think this, you know, this you make this important point that, you know, this question about insulting bots online, you know, if they know it's a bot, maybe they can insult it, and what is really the harm there? But it's interesting because I think probably the more difficult, harmful questions about chatbots and even ones that exist in the world today has to do with situations where we don't know if it's a bot or a human. For example, bots being created to massively post supremacist agendas and sort of get people riled up on Facebook pages, or this story of the bots stealing the American election, which may or may not have been true. But these are cases in which precisely the issue is that we don't know if it's a bot or a human, and this seems to be a case where much more ethical mischief is kind of entering in, and you know, if only like our only problem were deciding whether to insult it or not, we don't even know if it's a bot, you know. So I wonder if it's a bit more primary, the challenge, and I just wanted to raise that.
Thank you. So a quick comment on insults. One thing that I didn't say, but I think you all know it, is sometimes these insults are actually part of medical practice or psychological treatment. So you remember Eliza, right? The very, very first chatbot that did psychoanalysis or kind of psychoanalysis on humans. In those cases, insults were not only banned, they were part of that psychoanalysis. So we definitely do have context. We have much more powerful psychoanalytic chatbots today. I think there's a hospital in Bordeaux that is running pilot projects with actual patients on doing such things. So in those contexts, of course, insults are not only banned, but they're part of the medical practice. So they are completely valid. The chatbot itself, though, I think will still never insult. It will receive insults, it will analyze them, but it will not insult in response. So it's not definitely not a black and white situation with insults. There's a lot of context. It depends on the context. There are the medical context, for example, when the insults should be at least somehow incorporated into the functioning of the chatbot. Now, the second part. So very clearly, the ethics committee here follows, in this recommendation 2, the same line as the famous Californian bill, right? You know that there is a law in California that says in commercial practice you must disclose that it's a chatbot, whatever the name of the bill is. I think bolstering something something. It starts with bolstering, the bolstering bill, I call it. In that law in California, this is only about commercial practice. We, in this recommendation, we open it up to all sorts of contexts. We believe that this is something that public authorities should be taking into account. You know that in Europe there is a big discussion on this project of regulation for AI published on the 21st of April by the European Commission. In the next 6 months, from January to June, France will be presiding the European Union, will be the leading country in that debate. How do we take that project of AI regulation to an actual bill, to an actual law? I don't think will be done in 6 months. It will probably take much longer. Right now, the high-risk systems don't include conversational systems at all. And that's something that will be debated, I think, very much. I think we want, at least we had this discussion with Renaud Vedel, who is a French prefect in charge of AI, in charge also of this international dialogue, that we want either national or European regulation that will say, if it's a chatbot, you must disclose. So I think we're heading in that direction. Will that remove all the ethical questions? No. Because there is a lot of spontaneous projection of emotions up to moral qualities and moral agency, even if you know that it's a chatbot. And I gave you the example of this Canadian boy who knew perfectly well that this was a chatbot and still underwent a whole emotional change by talking to this chatbot trained on the set of WhatsApp messages from his dead girlfriend. So I think we need to have that piece of regulation, and I think that we also need to be very clear that it will not solve all the problems.
Thank you very much. So we will have more time for questions during the final discussion, but before that we are going to take a very short break of 5 minutes and we will continue the discussion.
Okay.
Thank you very much.
Thank you.
Start our discussion, and yeah, we can maybe start with the speakers if you have some questions or comments on the other speakers' presentations. Please let.
I'd just be interested to ask you to, because I'm the only, well, both of us, but I should. Hello, hi, sorry, I should have realised. Yes, I'm the only speaker who's centred aesthetics, and Jacqueline has also addressed aesthetics in some ways, but I'm just interested in, because you particularly are very technically, just addressing it from a very, very sort of technical angle, which I don't have the knowledge of. I would just be interested to know your personal opinions about GPT and aesthetics, aesthetics being in any way you choose to interpret that word, aesthetic productions.
Thanks. I mean, I think it's fascinating. I mean, the possibilities are vertiginous, but actually, so I'm currently teaching this new course in the US on the philosophy of AI, and we'll have the final class on AI art or the aesthetic possibility or AI aesthetics or the possibilities opened by that. I think there are fascinating possibilities in the realm of the visual arts with different kinds of networks, so-called generative adversarial networks. There are a lot of artists these days using them, but I also think the possibilities for create. I mean, what you're doing, I think, is very interesting, and I think that's possibly the domain in which current models can shine the most, precisely because they don't have really communicative intent and a strong intrinsic regard for truth or falsity. The kind of poetic license we have in the realm of fiction is perfect fit for these models. And in fact, their shortcomings can become, as we say, like it's not a bug, it's a feature, right? Because they can get quite poetic.
Yeah, I was interested in, because I have used those little sliders, the the temperature slider on OpenAI, and I was quite interested in the idea that more so-called lyric or poetic language was produced when things got less accurate, because as a writer, I consider lyric writing to be extremely taut and meaning dense, and is a way that I produce truth with greater density as a kind of, professional writer when I have to be.
Yeah, can I add something? Let me first say two things quickly on visual art, because you can use a transformer for visual inputs. We don't regularly do that, but that's possible. People who actually produce AI art today, and I just wrote last week a text for a catalog of a friend who is a rather well-known artist who takes AI outputs and creates human art based on that. So it's a sort of hybrid art. It's very interesting. These people don't usually use transformers. Those networks are technically a bit different, but that doesn't matter that much. It is, to me, an interesting experience when it is either a hybrid system, so a human artist will seek some meaning, will try to interpret and give meaning and add things over that art, or when the spectator coming to an exhibition or just looking on the screen at a piece of art creates a meaning of that and starts interpreting that. So this is very much, the new Adam situation. Here is a beast, you have no idea what that beast means, and through interpretation you create meaning. So you create the status of that. So that already works with visual art. Now, where are we with writing poetry? For I don't know how many decades, people have dreamed about neural networks writing poems. And these examples back from the 70s and maybe even the 60s. Transformers and GPT-3 in particular have been used to write poetry. And usually they are good for about 5 lines. And then it becomes bizarre. I don't know if you've done a class in writing poetry. I sometimes do with students those kinds of things. We had a very good example with GPT-2 because it was just available online. We could do it without buying tokens. I now do it either with Jurassic 1, which is available, or in different languages. We can actually combine a Russian Yandex transformer network with Google Translate, so we get it in French via Russian, and that is kind of funny too, how to translate poetry and create poetry. Now, GPT-3 poetry, sometimes it creates 2 or 3 lines that are completely fascinating. It is absolutely unable to write a sonnet that will seem to us humans like a beautiful sonnet. That's a bit too long, I would say. It is able to write something that looks like a sonnet. When you read it, I've never seen that long a text that can be read as a beautiful poem written by GPT-3. But I have seen maybe 2 or 3 lines that are fantastic. And when you do Google search on these lines, or even subsets of words in those lines, it is never to be found, nowhere. It is not a repetition of something. It is similar, but new. That, of course, pushes us to ask so many questions, aesthetic questions, about also the nature of art and the nature of poetry. Maybe we're moving in the direction of a very different kind of the use of language by these systems, where they will be creating things that will seem to us surprising or beautiful, but we will know that they're somehow not human.
Yeah, I don't want to turn it into a discussion entirely just about poetry, but I do know that such experiments actually precede AI and also don't necessarily have the intention to be beautiful, but to actually question what a poem is and how it can be improved. I'm sure you know 100 milliards de poèmes by the Olympian writer. Now, which one was it? Was it Jacques Roubaud who wrote that one? In which a book of 14 sonnets had a little ruled line underneath each line, and the reader was meant to cut along all of these lines so that the poems could be mixed. The poet himself had not read every version of the potential poetry himself because he calculated that it would take 70 years to read every single version. So I think those questions were occurring in poetry before AI.
Yeah, one final issue that I think you've already raised, sorry, just a quick remark, is the question of uniqueness and repetition. Mm-hmm. Yeah. This relates to the question of temperature that Raphael mentioned, but if you overload, that means you produce too many unique poems, and of course, you can just run this as many times as you want. Every time it's a unique output if your temperature is high. And this brings us back, to the kinds of debates we had in 1930s on what is and also with Susan Sontag, not only, there's a lot written on the value of uniqueness in aesthetics. And I do think that the use of AI systems for producing text brings that question back on the table.
I think I kind of want to throw out as a potential corrective, or maybe a way of kind of tracing the exterior of a debate, that I think we're kind of exaggerating today in general GPT-3's potential for literary creation. And we set a very low bar for it, for what we will accept as delightful. This question of can it produce a sonnet? I'm in a graduate poetry workshop now, and if someone brought in a kind of weak poem, and then they said, oh, but look, it has 14 lines and 10 feet on each line, and it's iambic, it's a sonnet, they would be laughed out of the room. It's not enough. And I think so we have to, when we accept this question of, can AI write, we somehow accept terms for the question that produce such a reduced view of literature. And so I sort of wanted to throw that out. There was a very hyped novel written using GPT-3, came out this year, Pharmaco AI by K. Olato McDowell, who I think is a Google researcher. And I think, so we have to, when we accept this question of, can AI write, we somehow accept terms for the question that produce such a reduced view of literature. And so I sort of wanted to throw that out. There was a very hyped novel written using GPT-3, came out this year, Pharmaco AI by K. Olato McDowell, who I think is a Google researcher. and it's very, the text is not very interesting. I think it's interesting as a gimmick, as Joanna was saying, but one is struck in reading the human component of the lack of grounding, to use the term from CogSci and AI from earlier today. It's not a very intentional text, and the GPT-3 sections are almost more enjoyable because they at least have an awkwardness that makes them interesting. But it takes a lot for granted, I think, yeah.
So again, there are different components that go in this debate. I agree with you. A work of art or a work of literature, of course, is not just a text. It comes with history. It comes within context. It's not only a structure. We think that there is something called a meaning behind these words and these sentences. All these components go into our aesthetic judgment, if you like. So if you're a structuralist, you will say, okay, a language model can imitate structures, so forget about meaning. Meaning is just a bunch of structures. In that case, you will say, you still might say, no, it doesn't mean that the system will make a work of art, because you're forgetting about the importance of historical context and the author and the personality of the author and so on. But you can say, well, of course, you know nothing about the personality of the author. The reader always reconstructs the author, so maybe by reading that text, you will reconstruct a kind of an author. We don't know what kind of an author. So this debate can be continued like this for a while. I wouldn't dismiss this as a gimmick too quickly. I think that many things that we thought were inimitable actually can be imitated.
Well, I would never bring up the identity of the author or historical context. I don't think that those are serious questions. You know, I'm talking about the text that's on the page. It's hard to find very interesting examples of texts produced by GPT-3 that are true. I don't mean that don't show understanding of the world, but that are truly interesting in a literary way.
So if I can just say two things. So regarding I think the example of sonnets is, I mean, it's especially an especially hard one because there are specific formal rules that make a sonnet, and that's really hard for transformer models to grasp. But if we're looking at examples of prose or just poetry that's less constrained by certain formal rules, I think there are actually very impressive examples. So I encourage you. There was this page that was mentioned earlier, I think by Aldo, Guern.net. There is a very, very long post on various examples produced with GPT-3. A lot of them are creative fiction. And I really encourage you to read them because some of them are really very impressive. And just the second point I wanted to make is that I think maybe all or at least the most interesting examples of AI art, as it were, that are produced today, I think are more accurately described as AI human collaborations, right? Because there is, we're using neural networks as a tool. They are trained on a specific data set, and the choice of the data set implies already upstream some kind of curation in the service of the downstream artistic goals. So for example, when visual artists train the generative adversarial networks on certain images to produce new images, you curate upstream the kind of images you want to feed your network, and then downstream you curate the outputs, right? So you do some cherry picking of the outputs of the model. So there is, at these two stages, there are some important human interventions. So I think it's a bit misleading to just characterize AI art as just, like something that pops out of a machine. And I think you're the living example of that because you're on...
Yeah, I bet. I do think that if there is potential in AI writing or art, it is not in imitating what humans can do. It would be very poor to say, like the continuation of Conan Doyle, you can get a human to write a continuation of a Conan Doyle story quite well, and it's quite a boring thing, but it's easier to get a human to do it who's been fed on that kind of culture for like between 20 and who knows how many years. But hopefully what AI art should be, if it's going to be interesting, is as different from human production as possible.
One thing, it did happen to me, by the way, just right, what Raphael said. I used once in one lecture on philosophy, a 2-line piece written, a very short one, written by, I think GPT-3 or maybe Yalm, one of these transformers. And I had to think a lot about that strange phrase that it produced. It actually, my reaction was completely similar to reading a phrase from a great philosopher. It took me hours and hours of thinking to understand, to work around that phrase. Of course, I couldn't understand what the system wanted to say because it didn't want to say anything. There was no meaning. But as you said, human interaction, what kind of meaning, what kind of value do we find in that, in those cases? So I haven't yet tried to teach that sort of class, but what I would like to do, maybe, we'll see, maybe soon, you take a GPT-3 or like system or any transformer, and you add a layer of training, let's say with the text of W.H. Auden, and then it produces for you Auden-esque text. And then you run a class where you ask the students to analyze what's different. Do they feel, can they distinguish what exactly is different? It sounds Auden-esque. It can write to a page that would sound like Auden, but that's not Auden. Why is that? And having humans think about it is, I think, a fascinating task for us.
Thank you. I have a question connected with this last point, but maybe there are questions from the audience first that you want to...
Just a quick comment on what just Alexei said. It may well be the case that your students and even seasoned poets and critics would feel that it's not Auden-esque, although it should be tested, like wine and so on, blindfolded. But assume that they do indeed manage to distinguish. It could very well be that they have a subpersonal system that does it for them, but they cannot produce an explicit set of rules saying, it's because this and that, and Auden would never do that.
Yeah. So the claim is that transformers, because there is this unknown architecture that we don't know how it works, will be able to grasp these intuitive feelings that we have. And of course, those claims come from different architectures like convolutional networks that played, or deep learning systems that played the game of Go. You remember the claim, if you can win the game of Go, then somehow you can grasp what is intuitive, what a great human player cannot tell you what it is, but somehow they feel it, but the computer can grasp it because it can win, A consequentialist argument coming from the consequences. Now here, are we going to have the same kind of claim or not? That if they cannot tell it, then it should be something that a very good machine, maybe a very big machine, can still grasp. It can grasp these intuitions. I don't know. So far, I think that we clearly, at least one thing that we have achieved, is that we see where the threshold is. With current transformers, with number of parameters of the order of 10 to the power 11 to the 10 to the power 12 parameters, we see that a couple of lines look to us like deep, good, human-like literature. And then if we go beyond that, it becomes strange. It's perfectly semantically and syntactically valid. It's just strange. So we kind of see where that quantitative frontier lies, right? Do you think we'll be able to push it further? I don't know. Maybe that's where human experience, reference to external world, and all these things become important after 5 lines of text. If you don't have that, you're lost.
It kind of brings to mind what Borges said about, the scholar of Shakespeare who immerses himself in Shakespeare and reads Shakespeare and writes Shakespeare and, writes about, is he not Shakespeare? Borges has a line like that, so maybe GPT-3 is Auden in the example.
Well, the Borges story is called Pierre Bernard, and it's about a guy who writes, through long study, rewrites Don Quixote word for word as an original act with no consciousness that what he's producing is exactly the same. That's the question, whether something which is exactly the same but was produced without the same,
I think
without
that
consciousness of
Walter
copying.
Benjamin has something to say about it, right? I mean,
That was a very different
the
kind of
uniqueness
reaction.
argument is important for a work of art.
But the thing is that an AI can produce endless uniqueness, the opposite of what Benjamin said, in which things are reproduced, though actually they were reproduced as an imitation of rather than a complete copy of. You could photograph a statue, but it wasn't the statue, it was a photograph of the statue.
Do you think endless
And then-
uniqueness is uniqueness?
Well, what other definition is there of it?
I have just a short and very general question. So my question is, what can we learn from these AI writing tools, not only about how to write, but also about ourselves, if we consider writing as a form of self-knowledge? Maybe, Joanna, you can share your experience. As you said, you are trying to create a AI version of yourself.
Yeah, I haven't done that one yet, so I don't know what's going to happen, but I'm actually really interested, because when I started doing this kind of work, I actually started just doing some experiments with Talk to Transformer, and very strangely, which is actually just trained on the internet, so it doesn't bring up something that's necessarily like a continuation of your own work. In fact, it's when you write in a quite individual style, it's very likely not to. So I put some of my own writing into it, but not that much, a page perhaps, and it came out not only with writing that sounded like me, but that had some of my concerns in it, which was quite spooky. Although, I mean, maybe it was picking up on other similar things online, who knows, but or maybe it just found my original piece of writing online because it's there on Google Books as well. But that was the thing that made me think, well, this is really interesting because it is extending and the sort of writing that I'm doing. And indeed, when it got onto the bit that you call strange, that was the bit that I liked. When it became like my writing, but quantifiably not human. And I thought, this is the bit that's interesting to me, and this is the bit that I want to keep reading. It's not the bit that sounds exactly like me. As long as it has a tension between readability and strangeness, then I would happily keep reading this. But again, a lot of including pre-digital experiments, do talk about tolerance and readability and how long a reader is going to sit there and read this stuff for, and whether that is indeed the intent of art when, as you said, Benjamin said, we can just produce it endlessly. We can print endless copies of books or magazine articles or whatever in his time.
Maybe the right word is uncanny, not so strange, but you can even go further and say uncanny. I would say, in order to learn something about yourself when you're talking to a chatbot, you don't need to go as far as transformers. You can have Eliza, with a decision tree back in 1960s, and a very simple psychiatric or psychoanalytic chatbot will already let the human interlocutor learn a lot about themselves. It doesn't mean that the chatbot knows anything about anything. It doesn't have any aboutness. But the human will interpret this conversation so as. And that, I think, is the main vector. Many people think that just making things clear to the human interlocutor will sort of remove the effect. No, if making the status clear, making it clear will probably remove something, but definitely not remove the entire effect. So even without going as far as transformers, which have a lot of drawbacks, unpredictability, non-repeatability, non-reproducibility, and lots of other things, even if you talk about psychiatric chatbots we use today, which are normally decision trees, no big problems with that. The patient knows that they're talking to a machine, and there is an added value in talking to a non-human interlocutor. Sometimes there's a treatment you can actually administer via a non-human interlocutor that a human doctor cannot easily do. So like in the old days, I would say, talking to oracles could change lives. Today, talking to chatbots can also change lives.
There is a very interesting example. I was thinking more of the invisible patterns that an AI can find in our personal data, for example. So it's something a little bit different. It is a kind of knowledge that is not possible for humans to produce, but only for machines. So so I was thinking of this kind of self-knowledge produced by a machine.
It seems like the more we focus on the question of, is it like a human yet? What does it tell us about humans? Is this, human-like? Is this a good imitation or not? I feel like those questions can go on forever, but the less we focus on them and the more we look at what is it? What sort of knowledge does it have? What kind of text is it producing? What are the qualities of synthetic text? I think we get farther, This is a general interjection.
Yeah, I wanted to say in response to, perhaps it's not so much about, it is about self-knowledge in a broader sense, which is knowledge of our own capacities and our own minds, not self-knowledge in the individual sense. But as I mentioned, I think GPT-3 and thinking about what its performance and how it relates to its competence forces us to refine our understanding of understanding, as it were, right? And so, Alexei mentions that he disagrees with half of what I've said, so I would be interested in knowing more about that.
One third,
okay. But, when you say, for example, there is no meaning there, well, okay, but what do we mean by meaning, right? And that opens a whole can of worms. And actually, if we want to make that precise and rigorous, that's kind of difficult. And you can have the old Searlean take from the Chinese room argument about good old-fashioned AI and have this very mysterious notion of original intentionality that's tied to phenomenology and so on. But I think a lot of the debates have moved on from that, and now that we have these models that don't rely on simple decision trees or lookup tables, and the old Searlean line was you can't get semantics off the ground from syntax alone. With these models, these language models, actually, it seems more and more difficult to hold that line. Yes, GPT-3 is not grounded in perception, and that's definitely a limiting factor. But we now have transformer models that are grounded at least in visual input as well. And as some people have put it, we were kind of crashing the barrier of meaning, and it forces us to really ask hard questions about what we mean by understanding. Also, in the case of humans, what is so special, mysterious? Perhaps we need to stop thinking of ourselves as such special creatures.
For a couple of years, I've been giving students in one of the engineering schools where I teach a task to get to the mark for the course, to actually, as an option, not as a mandatory thing, to install Replica with a K, that chatbot, on their phones, and talk to Replica, and then not just transcribe the conversation, but analyze the conversation. Tell me what the issues were, what happened, what the ethical questions were. And Replica is not a transformer. It's mostly a reinforcement thing with some additional layers, so it's a kind of deep learning niche network. And I stopped doing that because I got mostly trivial and repetitive essays. Everybody was talking about personal attachment, emotional attachment, how lonely they were and that they were not so lonely, and then they broke up, or things you can read. There's a good paper, I think, from Microsoft China in 2014 or something about Xiao Ice, where they're already talking about these things with personal assistants. And you just keep learning the same stuff, that all these things are available 24 hours a day, that you can always talk to that thing, it's always nice to you, it's always the same bunch of arguments. So I just stopped doing this after a couple of years because I wasn't learning anything new from those essays. Does it mean that it doesn't have value for these people, for people who we're talking to? I think it did produce something valuable for them. For me as a teacher, it was all repetitive once again. But for every student who was in that situation talking to that personal assistant, I think that was sort of an experience that was opening up, their eyes on something in themselves, something about themselves. They were learning something about themselves from talking to that chatbot. So definitely we're moving toward a world of personal assistants, maybe even these intimate friends who will be in your smartphone available around the clock. You know, there are some Japanese models that do that. I do think that this will have a lasting impact on the users who will be living with these systems. And the question is, of course, what about their social interaction? How will those people be members of society? Will they want to live with a bot or interact with others, and in what ways? The transfer argument and all you can imagine there. So we don't discover really deep and surprising things, but people who undergo that experience, I think they do discover something about themselves.
Thank you. That's very interesting. Any comments from the audience? The audience. Maybe also the online audience. And if not, I have another question that is more on the ethical aspects of chatbots. So it's something you all pointed out in different ways. So Rafael, you said that actually the fact of focusing on human capabilities prevent us from judging the real progress of AI in some way. And also, Jacqueline, you pointed out that we need to design chatbots that don't necessarily have human traits or a human personality. And also the recommendation you mentioned from the French Ethic Committee on Digital Technologies about the fact that we shouldn't give moral traits to artificial intelligence. So these points are somehow connected, and I was just wondering if maybe we should make a clear difference between a human-centered AI and the fact of using humans as a model for the design of AIs. Is it useful to make this distinction, or not really, or what do you think?
I mean, it's difficult because I think, yes, I think it's very an important distinction between human-centered AI and AI that pretends to be human. Almost are opposite concepts. I think that the idea of the bot design for me is an ideal that I think we can make progress if we keep in mind. But it is hard to get away from the humanness of language. As soon as something starts talking to us, it will seem that way. So that's a last thought from me on a coda on the spot-like design.
I think there is no neutral language, and that's something that certainly in critical circles has been understood for a long time. I think Justine this morning was underlining that point very precisely when she said that African American children were interacting differently with bots who spoke like them rather than bots who didn't, and that shows that there is no neutral language. There's no standard language. There is no variety of humanity which is going to be universally easy for absolutely everybody. So when you're talking about stripping the bots of humanity, or pursuing a more bot language, I love the idea of a bot-like bot, but I think you're always pursuing them from a human position, and that human position is geographical, economic, gendered, social generally. So it's a great thought, but it's possibly impossible.
I mean, it's.
We have to cut short pretty much, so make it brief. I mean, go ahead, but make it brief.
Yeah, I mean, to echo these points, I would also say, like, ultimately, if humans are the consumers of the outputs of these models, the outputs have to be in a format that is that can be understood by humans, right? So there is a limit to how inhuman we can make these models if the goal is to communicate and interact with humans. But I also think that GPT-3, as it is already pretty inhuman in some ways, not least in its kind of protean nature that I emphasized, that it's such a chameleon, and that it can be at once. It can write like I don't know, like a wrestling fan, or like a Shakespearean scholar, or like a neo-Nazi propagandist, and that's part of the problem, of course. But it can be all of these different things, and in a way that no single human could ever be. It speaks thousands of micro-dialects.
Yeah, so I would say that the answer to the question, should it be human-centered or not, is it depends on the context of use. We wrote a whole opinion at the ethics committee on the use of AI in medicine. And I will tell a story of a doctor, I will not tell it right now because we don't have much time, of a doctor who cannot explain a very effective AI advice to the patient, and if there is a lack of explicability, that just doesn't work in medicine. So in medicine, yes, it has to be human-centered, human in the loop. A human has to have some heuristic. Danielle was asking us for a heuristic about how it works. How do these transformers work? Well, definitely we can't explain, but we can give you a heuristic. Something about attention, something about non-sequential learning. You know, you put this stuff in the soup and it works. It's a heuristic, it's not an explanation. So in some sectors, we need a heuristic. But imagine a human relations department of a huge company like a railway company. It receives thousands of CVs and motivation letters, and then there is an NLP model that analyzes automatically all these motivation letters and tells people, you should interview and hire these guys. Do they need to know why it did that? If the result is shown to be effective for the company, I don't think this necessarily has to be explainable in natural language. In some contexts, you can. Okay, so in some contexts, you have to explain to the applicant what happened. In other contexts, you don't. So explicability and the need for human-centered systems depends on the context.
Thank you so much. It's terrible because I cut short Jackie, and that's a typical sort of mansplaining thing, which I hate. So please, you have the last word.
I can hardly hope to do justice to this wonderful day that we've had, and to say something that will be the proper last word. I was simply going to respond to Joanna's perspicacious, very astute observation that the bot-like bot can remain only an ideal, and yet, when I started sort of doing chatbot design, I noticed that there was a lot of frigid, brittleness and shame among people in the industry, that the bot had to be a perfect imitation of a human. It couldn't make a mistake. It had to be as smooth. It had to pretend to be a human. And I just thought, well, what if we just accept that it's not a human, that it's a bot? Then not only do we kind of save ourselves embarrassment, but we maybe open ourselves up to some more beautiful possibilities in functioning as well as design. Yeah.
Thank you all for your contributions. Thank you very much.
The audience is enthused.